So let's now delete the place. The great thing is that we can apply all the previously learned knowledge here, because in the end, deleting a place simply means to find a place by a specific ID and then to delete it. That's the main thing we have to do right here. For that, here in our delete place constant, we can get rid of all our dummy code that we have in here. And let's now again create let place, because it will be the same logic we had before. We need a try catch block once again, and inside this try catch block we need to find our place. So place should again be equal to place dot find by ID, because again the place ID is what we are looking for right here. So let's add place ID, and once again finding a place is of course an asynchronous task, therefore we should add async right here and await ahead of place. So that's the logic to find the place. Once again, we catch our error and we store it in a constant. It should be equal to new HTTP error. And let's say this is something went wrong. Could not delete place. And error code 500. Let's return next error. All these steps we did before basically. So this is finding the place, the first step. Now we have to delete it from our database, of course. For that, as for saving the data, in the end, we again use try catch. And inside our try catch block, we use place.remove this time. So before we had the save method, now we have the remove method. By the way, with all that repetition of the code here, I am aware of the fact that we could refactor the code to save this partially duplicate code. For didactic reasons, I won't refactor the code at this stage so that we can repeat this logic one last time here. So with that, we can remove our place, also an asynchronous task. Therefore, we should add a wait right here to make sure this works correctly. In case of an error, I'll just copy this code up here. Same error code, and we also have to return our next error one last time here. And with that, we are actually done already, because here changing our response doesn't make a lot of sense because we won't get back any document, well, as we remove it. And with that, if we save this now and go back and create one last request here, this time this should be a delete request. And again, the ID of the place that we created right here in our post request, so this ID right here. If we do so, we don't have to add any additional information here. And if I now press send, we get the message deleted place. And if everything worked correctly here, if we go back to our database and reload it, we can see our query results shows 0, so we don't have any more places in our database. And with that, we finished our CRUD operations here, at least for the places. But what is missing at this stage, of course, are our users, because we only worked in our places controller so far, but we actually also got the users controller here. Here we still have our dummy users, so it's time to change that now in the next lectures. So we finished the places for the moment. That's a great first step, but there is more to come. Because in addition to places, we also want to add users to our app. Users means that we want to be able to sign up, so to create a new user account. We also want to be able to log in, so to log into this account. And then we want to be able to create a new place for this specific user. And this actually shows the two things that are missing. The first thing is the implementation of this user sign up and log in logic. And the second thing is the relation between the users and the places. Because if you think about our application data, then we have these users and these places, and each user has different properties, for example, the name, the email, the password, and the user image. And we have the places with the title, description, the address, the location, and the image. This is what we built already. Once we build the users then, which will be the next step, then we also have to make sure to create a relation between these two entities, you could say. Because in the end, we want to make sure that one user can create multiple places, and that one place can only belong to exactly one user. So that's the second important step in the rest of this module, to establish the connection between the users and the places. Therefore, let's now continue with step 1, creating our users logic. Creating the code for the users is pretty straightforward actually, because as for the places, we again need a schema, so what we built right here in our place.js file, where we predefine the structure of a document, so of the data a new user signup has to contain. Then we will export this schema and use it here in our users controllers. So that's actually what we want to do right here. So with that, let's get started with the schema first. And to do this, we again go to our models folder, now create a new file, this time a user.js file, and now we can again follow the logic we learned before. We first have to import Mongoose here, so we require Mongoose. And what else do we have to import? Well, we need our schema constant here with mongoose.schema to be able to create the schema. As I said, now we want to create the user schema, therefore naming our constant user schema makes sense, I guess. We again will instantiate a new JavaScript object here, and this object now contains all the properties our new user needs. So what properties are these? Well, the first property obviously is the user name. As for the places before, we will again use an object here, and the name should be of type string. And it should also be required. So required should be set to true. We can actually copy this because our second property, the email, will kind of have the same information, but I want to add one additional property here. Because our email will be an information which we query a lot. For example, when we do the user login, well, we need to query the user email in our database. Now, although the database in this project, in this course, will not be very big, if you have a really big database, which is typically the case if you store user data, then you want to make sure that your email is queried as fast as possible. And for that, you can simply add unique right here. If you set unique to true, this will just create an index for the email, which in simple words simply speeds up the querying process if you request the email. Therefore, we add this property at this point. Another property we need is our password, of course, for the user. So the user has to add a password. The password should also be a string here, and it should be required. And we could add one additional property, the min length property. This simply validates the minimum length, so the minimum amount of characters our password should have. In our case, we'll stick to 6 characters here. That's optional though, but I guess it makes sense here to at least make sure the user adds a minimum length for the password he uses. The next property is our image. We had this before in our places. This is again a string and required is set to true. Again, we are talking about the URL here, so that's basically the same logic we had before for the places. We don't store any files in our database. The last property we have to add for our user schema is the places property here. Places plural because one user can have multiple places, but one place can only be allocated to one single user. You remember what we talked about in the last lecture. And places will be dynamic later, so we will store the IDs of the places allocated to a user right here. For the moment, I'll just use a string and set required to true. This means we will add the place manually, but that's just step 1. Later in this module, when we add the relation between places and users, this will of course be a more dynamic approach, where we collect the ID from the corresponding place a user created. With that, we are almost done with our schema, and we could already create and export our model, but there is one thing missing here. Because unique up here, as I said, only creates an internal index in the database to make it easier and faster to query our emails. What is missing though at the moment is an internal validation whether the email that we want to create right here exists already. This is not done by unique. For that, we have to use a third-party package, the Mongoose Unique Validator. And to use it, we first have to install it with npm install --save Mongoose Unique Validator. With that, it's installed, and now we can use it by creating a new constant, name unique validator, and now we require the Mongoose unique validator right here. With that, we can use this third-party package to make sure we have a unique email here, and to add it to our schema, we simply add it to the schema via the plugin method here. So we add unique validator, like this. With that, we made sure that we can query our email as fast as possible in our database with unique, and we made sure that we can only create a new user if the email doesn't exist already with our unique validator package here. Now we can create and export our model. We know the syntax already. It's module.exports, and this should be mongoose. Now the model method. And here we have to give our model a name. As I said for the places already, this should be in a singular form and with an upper capital starting character. So in our case, naming the model user makes a lot of sense. As you remember, this will also define the name of our collection. So the collection will be called users without the capital U. And we want to export our user schema here. Let's save this now. And with that, we finished the creation of the schema and the model. Very important though, we still don't have any connection between users and places. I want to repeat that because this will come later. But if we look at both topics separately, we have now the places schema and the user schema. Therefore, let's now use our user model. Let's now use our model. And as for the places where we started with creating a new place, so with creating a document, we have to follow the same approach right here. So first, we should have a look at the create process, creating a new document, meaning we should have a look at the user sign up here, so to create a new user. For that, we go to the users controller and now first import our newly created user model right here. So we use a new constant named user, which is equal to our path. So this is /models/user. Now we can use the user model and we'll work on get users later. But here, our signup constant, this is where we have to change some code now. The first code block, so this part right here, is okay. We'll come back to that later though, because we have to adjust a little thing, but this is not important at the moment. But here, our has user constant, the created user, and how we add the new user. These are the areas we have to change now. Let's start with this has user constant here. Here we have some kind of dummy validation already to check whether a user email exists already. With our newly created user model, this whole logic does not apply anymore, so let's change it here. But one important note. As I said before, we have a validation already in here with our unique validator package. The little issue about this package is that we get a default validation. This means we get an error message in case the email exists already, but it might be a very technical error message. So to make sure we have a nicer user experience, we should add a manual validation logic right here. This means we will get rid of this code right here. And now let's say this is our existing user. And this should be equal to user. So our user model dot, and now how can we check whether an email exists already? Well, with the find one method here. Find one simply finds one document matching the criteria in the argument of our method. And what would be the criteria in our case? Well, it would be the user email. So with that, we can easily check if the email of the user exists already. So as with save or find as we had it before, this right here is again what? Well, an asynchronous task, and therefore we of course should wrap this in our try catch code block like this. And this also means we cannot use a constant right here due to block scoping. So we add let existing user right here and get rid of the constant. Additionally, we have to add async up here and await ahead of our user. So this was step one. Now we check whether an email exists already. If checking this doesn't work, so not if we find an email, but just if this find one method does not work as intended, then we want to catch any potential errors. and store it in an error constant. With a new HTTP error. We did this a lot of time already. As I said, we could refactor the code a bit, but for demonstration purposes, I rewrite this code again. And we could say that signing up failed. Please try again later. With an error code of 500. And we also have to return next error. So let's now say we find a user emailer already, so the user exists. Well then, if existing user, so if this is true in the end, then I want to create another error, new HTTP error here, and I want to return user exists already. Please log in instead. And the error code here would be 422. And we want to return next error to stop the code execution. One side note here, you can argue whether you want to expose the information right here so that the user exists already. You can also be more cryptic here and say login failed. I think for a better user experience at this point, we should give the user the information that the user is existing already. Let's now finally say we don't have an existing user, so creating a new user is possible. Well, then we are at this code block, and again, as we did it for our places, just to remind you down here in the places, we now have to make sure that we add all the properties we created in our user.js file. So name, email, password, image, and places. Let's do this by, well, maybe getting rid even of these and creating it again from scratch. So let's now say that our created user should be a new instance of this class, of our user model in the end. And this should be the name which the user enters, the email the user enters, and an image. Again, the image should not be the file, but the URL to a file. I got a link to a file from the web here, again for demonstration purposes. It's exactly the same process that we followed when we used our places model. So we have this dummy image. Then the user password right here. This is a user input. Another very important side note here. We will save the plain user password at this stage of the course, but very important, this is not the way to go here. At this point, we don't care, but later in the authentication module of this course, we'll of course encrypt the password here, because storing the not encrypted password is of course a serious security issue, so don't do it this way. This is just the right approach at this stage of the project. And finally, we add our places. As I said, places will be a dummy value for the moment, so just what the user adds as the place ID. Once the relation was set up, this will be a lot more dynamic. With that, we can create a new user actually. What is missing though is how can we now save the user? For that, I'll again delete the dummy users code here. And well, for saving the data, what do we use? Well, we use again the save method. If we go to the places controller down here, that's actually exactly the code we need right here. And this time I will actually copy paste the code to speed things up a bit at this stage, like this. So we await not the created place, but the created user at this stage. And we catch an error. And if this fails, we will simply say not creating place, but maybe signing up failed. Please try again later. Error code 500. So that's the same logic we had before. And here for our response, we'll again also use a well-known approach. So we will convert our Mongoose object, the created user, to a default JavaScript object. And we'll also set getters to true. What's the reason for that? Well, it removes the ID, so the underscore in front of the ID property, to make it easier to access the later ID. Very important here, what we get back as a response also includes the password. As I said, this is also not what you would typically do. It's just here for demonstration purposes at this stage of the project. And here we can actually make small u, not the capital U. So let's now restart our development server and go back to Postman, create a new post request here. Again, HTTP localhost 5000 /API/users this time, not places. and now /sign up to create a new user here. Now we need a body with JSON data once again. And here we have to add all the properties we added in our model. So first we need a name, which could be menu, my name here, an email, test@test.com. We don't need an image. We provided that in the code. So we need to add a password here. Maybe test should be a string. And we add the places as said before with dummy input here. We'll change it later when we create the relation. So if I now hit send, and as we can see, we have a problem, but we actually have two problems. First, our request doesn't work. And second, we don't have an error message. So let's first check the problem with the error message here. Yeah, I got it. Yep, that's the problem. We are using throw here, but we are now in an asynchronous task. So this doesn't work. We have to use return next here to avoid this error. So let's put this in here. Now this should at least work, and we should also correct this for all our other cases where we have throw as part of an asynchronous task. For example, here in our places controller, I think we got the same problem. Yeah, down here for update place. Here we should also use return next. Oops. Like this. So with that, we also corrected this problem here. Don't think we have any other throw errors. So if we now go back to Postman and send the request, we at least get an error message that we passed invalid inputs. And the reason for that message now is, well, our password. You remember here in our user model, we said that the password should have a minimum length of 6. Well, and our current password doesn't fulfill these requirements as we only have 4 characters in our password. So if we add 2 or 3 characters, let's say it should be testers, and hit send once again, then we are again in another loop. So that's the third problem we have. But what's this problem? Well, as we are using our dummy property for the places here, so this one in our schema, and also here in our model, we of course also have to add it right here to our constant. So if we add places right here, save this, go back to Postman and hit send, you can see we finally created our new user. We have the ID with our getters logic, we got the name, the email, and all our results. Again, we get back the password here. That's not the final implementation we will have. But if we now have a look at MongoDB, we should see that we have our places database, and in the users collection, we can find our newly created user. So with that, we can now create a new user. So the sign up is done. Now it's time to log in our user. So the next step for our users is now to make sure that we can use our login. So this code right here, because we can create a new user, now we want to make sure that once we stored our credentials in a database, we can also log in. One important note though before we start, the password validation is still going to be some dummy code, because at the moment we don't have any token which is sent with the password, so we cannot really validate our data. Therefore, at the moment, we only have a dummy code, so to say, which will simply check whether a user is existing and or if the password he enters is correct. So it's not a real login, we just implement this basic functionality. Just keep that in mind. However, as I said, we have to work on the login here, and the core logic is not that different from the one we saw for our sign up. So to get started, we'll again delete this code right here. And now what I want to do is I first want to start with our custom email validator that we already implemented up here for the sign up logic. So this code right here, we can basically copy paste it because I again want to make sure that the email address of the user is valid. For that, let's go down and let's paste this code right here. Maybe add a space here. One difference though, here not signing up would fail, but logging in would fail, but the general logic is the same. So that's step 1. We validated our email. Now let's continue with the actual check whether the user email or the password is correct. This is what I was referring to at the beginning of this video. It's not a real finished validation though, it's just a dummy validation in the end to make sure the email and or the password is stored in a database. In case either mail or password is wrong, the user cannot log in. I actually already said what we have to write in the code now. If here and if what? Well, if our existing user, is not stored in the database, or if the existing user password, so we can access the password property here, is not equal to the password that was entered. Well, if one of these is the case, then we again have an error with our HTTP error. And this time we can state invalid credentials could not log you in. Error code here would be 401. And we have to add return next. Again, also nothing new to us. And with that, we are actually done already. We can now validate the email and we can check whether the email and the password are correct. Well, if both is the case, then we should be able to log in now. So let's save this. And I get an error. And why do I get the error? Well, because here find one is an asynchronous task. Therefore, we should make sure to add async also right here. So make sure not to forget this. If I now save, this should work. So let's go back to Postman. And here I'm not in sign in now, but in the login route. And we now only have to add two things, email and password, as we showed it right here. So let's delete this one. And now what is our email? Well, for that, we can go to our database. Here in the users collection, we have the email test@test.com. Let me simply copy paste this one right here. And the corresponding password is here, testers. So if we do this and hit send, we get back logged in. So this seems to work. If I now enter testers1 as a password, I get invalid credentials, so this seems to work. And if I enter test1@test.com, this also doesn't work. Once again, with test@test.com, we get the successful login. So with that, we can now log in. One thing is missing though, and this is up here, our get users constant. We have to work on that as a next step. So what I want to achieve next now is I want to send a request which returns all the users stored in our database. How can we achieve this? Well, by first getting rid of our code right here. We'll also type a new response code so we can delete it for the moment. And in our constant, we use again users and now our find method. Now with find, we can now search the documents stored in the database and then get back the users in theory. But actually, I would like to be a bit more explicit here. I would like to find only the email and the name, so I don't want to return the password of a specific user. As I said, we are not finished with our security and authentication part. This will be covered later. But generally, actually, when we get the users, we should actually return email and name. Now we have different options to do so. By the way, we also used find already here in the places controller. Here with get places by user ID. Down here we use find. Here we refer to a specific property. This time I would like to refer to two different properties, namely the email and the name. And we have two options to do this. We will use the concept of projection right here. This works by adding an empty JavaScript object. And now we can either add email and name like this. So this would return the email and the name. Or we can simply add a minus sign here and now exclude our password. I'll follow this approach here. Both work fine for our purposes. However, storing it as a constant here won't work because, as we know, find is an asynchronous task. Therefore, let's first add async up here. And now what will we do? Well, we'll again create let users here because we will wrap our code in a try-catch block once again. Therefore, we'll add the code right here, get rid of our constant, and add a wait ahead of users. So that's the try block. And now once again, in case this does not work, then we catch the error by storing it in a constant. It's always the same approach in the end. And now return fetching users failed. Please try again later. Error code 500 and return next error. So with that, we can get the users, and if this is successful, then we have to get a response, of course, and our response will again be a JSON response, which will be of users, but now again users.map, because again find returns an array, so we cannot convert this into a default JavaScript object. Therefore we'll add the map method right here and now say that our user should be turned into a default JavaScript object. Now the syntax is working again, and with that we can again use set getters to true to get rid of our ID that will be returned. And if we save that, we can now, if we check our routes again, go to /users. As you can see, no need for sign up or login anymore, as we only want to get the users. So we can get rid of login right here. And if we now send a GET request without any information in the body, so this is of course not required. If we send it, we get back our user menu right here. So not very spectacular as we only have one user, but it seems to work. Let's now add a second user quickly. So here at our API users sign up route, body, raw, JSON. And let's quickly add the name, which could be Max. We have the email, maybe test2@test.com. We have the password, which could be testers2 here. And we have a place, places, let's say New York. There should of course be a post request here. If we send this, storing the user seems to be successful. Let's go back to our GET request, send it, and now you can see we get back both Manu and Max. This works fine. Let's now also see whether it worked in our database. So let's reload this right here. And as you can see, we got both Max and Manu stored in the database. So getting the users also works fine now. There is one crucial thing missing though. And this crucial thing is of course the relation between our places and our users. At the moment I'm using some dummy code here for our places in the users.js file, and here for the creator in the place.js file. And we also enter the place manually if we create a new user. So this code down here where we add the places. This should of course be changed now, and that's actually the last crucial step here in this MongoDB module. So let's continue with that. We are coming towards the end of this module. What is missing now is the relation between our places and our users. To bring this back to your mind again, we have the structure now, so we have users and places. And now in the end, the goal is to make sure one user can create multiple places and one place belongs to exactly one user only. But what does this mean for us though? Well, as we have our sign up logic now, this means we can create a new user. Well, we also will create an ID for this user. And this means if we now create a new place, we want to make sure that if we create this new place, this place will contain the user ID, so the ID of the user it belongs to, and at the same time, the place ID will also be added to the user document, so to the user data. Now, adding the place ID to the user and the user ID to the place, so on both documents, is not required here as we're using a NoSQL database. For SQL databases, this would be required, but for NoSQL, we structure and define our queries. For demonstration purposes, we will follow this approach though, so to add the IDs in users and in places. Another important side note, the sign up logic at the moment, so creating a new user, will return an ID, and when we create a new place, we will copy and paste this ID in the end. This approach will of course be changed in the authentication module of this course. There you can log into a user and then the ID will automatically be added to the place. For the moment, this is just a dummy code we use. But the important thing now is if we create a user now, we get the ID, and if we then create the place and provide this creator ID will be stored in the place, and at the same time, in the user document, we'll store the corresponding place ID. Now this sounds very theoretical here, therefore let's dive into the code and let's start with creating the relation between places and users. And to establish this relation or this connection, we have to change two things in the place.js and in the user.js file. Let's start with place.js here. Here we have the creator, which so far was a dummy ID provided by us. This should change now because now we want this creator to become a real creator ID, a MongoDB ID in the end. And to tell MongoDB that this is a real, MongoDB ID in the end, we simply enter type mongoose types object ID. That's what we have to change here. So with that, the creator will be a real ID that has to be provided here. And required can again be set to true, of course. So we have to provide this ID. But we have to add one additional thing here. And this additional thing is the ref property, which finally allows us to establish the connection between our current place schema and another schema. And what is this other schema here? Well, our user schema. So we have to add the model name here, so user, and place it right here as the reference. This will become important later also when we use the populate method, but more about that in a few minutes. With that, we established the connection from a creator perspective. Now we have to do the same thing for our places. For that, we can actually copy and paste this object and go to our users.js file. And now we can paste this code. But one important difference, of course, here we now have to use the name of our place model, which was place. Can find this right here. So that's the name I'm referring to. And another important thing, we said that one place can only belong to one user. So here we have just the object, this is fine. But we said that one user can have multiple places. Therefore, we have to add an array here. This is how we tell Mongoose that in documents based on this schema, we have multiple places entries instead of just one value. With that, the relation is almost established. There is one additional thing that we have to change though. And this additional thing has to be changed in the user's controller. Because if we go up here to our signup, we still have the places here as a single property. Here we have to change our places because the starting value for the places will be an empty array now. Once we add a new place, this will automatically be added. Therefore, we also have to make sure to remove places up here from our constant, like this. So this was step one. We created the relation between places and users, and we also defined the schema for each single place that gets added right here for our places property. So this object defines each single place that gets added. Let's now continue by creating a new place and make sure that the creator ID is added to this place and at the same time that the place ID is added to the creator. To create the new place and to add it to a user, we have to go to our places controllers now, right here. First, we have to import our user model here because as we want to interact with the user, well, we kind of have to establish this connection. So let's import the user here. And this is located in /models/user. So with that, we can use our user schema. Now we can go down to our create place constant right here. And this is where we have to change some things. One thing that will change is the data type of the creator field. Previously, it was a simple string. Now, since we'll establish a relation between places and users, it'll be a special type which MongoDB uses to manage IDs. Why is this the case? Because we now store a real MongoDB ID in this field, not any dummy string anymore. But generally, our created place constant is fine. Things change down here though, because instead of immediately saving the place, we have to check whether the user ID we provided exists already, because only we have a user created with the corresponding ID, we should be allowed to create a new place. For that, I'll create a new variable and name it user. And I'll again wrap the following code in a try-catch block. It's again the same logic we had before. So in case we have any general error, we should catch this. Therefore, we can actually get started with the catch block here and store it in a constant again, which is a new HTTP error here, stating that creating place failed. Please try again with a 500 error code, and I'll return next code here. So that's what we did before. So that's just some general error. But now the question is, what do we actually want to do with our user here? Well, user should be equal to user.findById creator, because what we want to do right here is we want to access the creator property of our users and check whether the ID we have for our logged in user is already stored in here. So we want to check if the ID of the user is existing. That's the code we have right here. And as we are in an asynchronous task, we have to add a wait right here once again. So we want to check whether the ID of the logged in user is existing already. In case we have a general problem, we catch it right here. But in case our check is successful, so in case we can check the ID of the creators, well, then we just want to make sure that if the user is not existing, so if the user is not in our database, well, then again, we have an error stating that we could not find user for provided ID. Error code should be 404 here. And don't forget to return the error once again to stop our code execution. We could also console log the user here if we want to. That's optional though, but let's maybe add it here in our code. But if this user is existing, well, then we can do two things now. First, we can store or create that new document with our new place. And second, we can add the place ID to the corresponding user. To do this, we have to replace this code here or refactor this code here. The catch block is fine, but here, try, this is what we have to work on. To do that, we need to be able to kind of execute different or multiple operations which are not directly related to each other. And if one of these operations fails, so if either creating the place fails or if storing the ID of the place in our user document, so if one of these operations fails independently from each other, then we want to make sure to undo all operations. So basically to throw this error without changing anything in the documents. So that's the important thing. We want to do two things, and only if both things succeed, we want to continue and we want to change our documents. To do that, we need to use transactions and sessions. The transaction simply does what I just said. The transaction allows you to perform multiple operations in isolation of each other and to undo these. And the transactions are basically built on so-called sessions. So to work with these transactions, we first have to start a session, then we can initiate the transaction, and once the transaction is successful, the session is finished and the transactions are committed. So with that, our place is created and the place ID is stored in our users document. Sounds a bit complicated again. Let's do it step by step now, and you'll see it's actually a quite straightforward process. What we first need is a new constant. Let's call it sesh maybe. This is basically our current session that starts when we want to create this new place. For that, we have to add a wait again. We are still in an asynchronous task here, and we have to refer to the start session method Mongoose provides. As I said, with the session here, we can now also start our transaction. So in our current session, we want to start the transaction, another method we can use here. And with that, we can now tell Mongoose what we want to do here. What we want to do here is we want to make sure that our created place should be saved, right? We want to save it in the database. And as an argument, we have to provide the session property and refer to our current session, so the session that is currently running. With that, we will create a new place and automatically create the unique ID for our place here. And saving, we learned that already, is of course an asynchronous task. Therefore, make sure to add a wait here. So this was part one. Now we stored the place. And now, with the place being created, we need to make sure that the place ID is also added to our user. For that, we can refer to our user here, and now say user.places, right? We want to access our places property, and here we want to push, so to add basically the created place. Push here is not the standard push, which you can use on any JavaScript array, by the way. Instead, this is a method used by Mongoose, which kind of allows Mongoose to, behind the scene, establish the connection between the two models we are referring to here, so to say. Very important here, behind the scenes, MongoDB grabs the created place ID, that's an integrated Mongoose feature here, and adds it to the places field of the user. So it only adds the places ID. That's important at this stage. With that, we stored the place, we added the places ID to our user. What's missing now is, of course, another asynchronous task. We have to save our updated user now. And again, this updated user should again be part of our current session that we are referring to. And only once all these tasks are successful, so we could create the place, we could add the place ID, and we could save the user, well then we want to make sure that the session commits the transaction right here. Another asynchronous task, so don't forget to add a wait. And just to make this clear here, only at this point the changes are really saved in the database. If anything would have gone wrong in the tasks that are part of this session and transaction, all changes would have been rolled back automatically by MongoDB. And that's it actually. With that, we use the session and the transaction for all these tasks, and only if this is successful, then the place will be created and the user will be updated. And just to give you some examples when this error code could occur, either our database server is down or something related to that, or the database validation fails. So these are two cases when things could go wrong here. The response can't stay the way it is. There is one important thing we have to know though, because so far when we created a new user or a new place and we didn't have a collection, the collection was created automatically in MongoDB. For the transaction, this is different. Here, if we don't have an existing collection, so in our case, we want to create a new place. This means we have to create a places collection. You remember here, place.js, we have place. This means places without the capital P would be our collection name. So we have to create this collection manually now. Because if you go to our MongoDB database, you see we have the places database, that's the database name, but this database only contains one collection. Therefore, we have to hit the plus right here and now add the collection name places like this and press create. This makes sure our transaction is successful. As I said, this is only required if we don't have the collection created already. With that, let's go back to our code and make sure we save our places controllers, our place.js, and our user.js file. And of course that our development server is running. And if we now go to our database, to users, here we can now first delete our two existing users. Here and right there. To start this whole thing from scratch. Now let's go to Postman. Create a new post request here, /users/signup. To create a new user, we need the body, raw data, and JSON. And now we need to provide our name. Let's say menu here. Then we have to provide our email, which could be test@test.com. And we need to provide our user password for the newly generated user here. Let's use testers again. With that, if we now hit send, we should see that the user is created. We see we have an empty array for the places as this new user doesn't have any places at the moment. And we see the ID right here. And if we now go back to our database and reload, we can also see that the user was created right there, also with the object ID here. Let's copy this ID because now we will create a new place. And here, as I said before, we have to copy and paste this user ID to allocate this place to a specific user. This will be changed in the authentication part. I repeat that, don't forget about that. It's just a dummy solution at this stage of the project. So back in Postman, we have to create another request, another post request. to localhost 5000, but this time not users, but simply places. We need again the body and the raw and the JSON format here. And now, which properties do we need? We need the title again. And let's stick to the Empire State Building here. We need a description. Again, a very famous building. We need the address. I'll add it in a few seconds. Let me first copy paste our creator ID here. This one, so that's the ID of the user we just created. And now let me quickly grab the address of the Empire State Building. I'm again using Google Maps for that. Here we go. Creator, by the way, so missing the A here. Now the properties look fine. With that, if we hit send now, we get back an error, and I think I know why, to be honest. Because, well, we are using Mongoose here, right? And up here, we didn't import it to our file. Well, this can of course not work, so let's quickly add Mongoose here, save this, and if we now go back to Postman and again hit send, I think this should work. Yeah, this looks good. Now we created this new place, so this is the place ID, and down here we also get back our creator ID. And if we now have a look at MongoDB once again, in our places collection, we can also see that the place was created successfully, also with the place ID and the creator ID. And if you now remember that A5 at the end, that's the ID of the place. And if we check now our users, we see we have the array right here. And if we click onto this array, you can see A5 at the end. This is the ID of our place. So this seems to work fine. Let's now see what happens if we enter a wrong user ID. For that, we can just change the 7 here to a 6, for example. And if we hit send, we get back, could not find user for provided ID. So this works fine. This means we can only create a new place now if the user ID is existing. And this was exactly the goal of this operation here. What is missing now though is of course the option to also delete a place. And if we delete the place, we kind of have the similar logic. So we want to delete the actual place and we want to delete the ID of this place in the document of the corresponding user. Let's implement this as a next step. So back in our code, let's now go down to our delete place constant and see what we have to change here to make sure we can delete the place successfully. The first part here, our try catch block to check whether we have any general error, is fine. There is only one thing we have to add right here. Because what we want to do in the end is we want to find the place ID of a place we're looking for to delete this place. But at the same time, we also want to search through our users collection and see which user has this place. And then we want to make sure that if we delete the place, that this ID is also deleted from this user document. This means we need access to a user document and we need to overwrite or change an existing, well, information in this document. And to do so, we can use the so-called populate method here. Populate allows us to exactly do that, so to refer to a document stored in another collection and to work with data in that existing document of that other collection. To do so, we need a relation between these two documents, and these relations were established in our user.js file here with ref place and in our place.js file here with ref user. Only if this connection is existing, then we are allowed to use populate. Otherwise, this populate method would not work. And the populate method needs one additional information. It needs information about the document where we want to change something. And within this document, we need to refer to a specific property. In our case, this is the creator property, because the creator property contains the user ID. Mongoose then takes this ID, but searches through the entire user data. So the ID allows us to search through the user and then to get back all the data stored in a user document. With that, we have the theoretical option to change something in our user and of course to also find the place by ID in our place document. We can keep the rest of this code here like this. This is fine. Now, before we work on this try catch block though, I see we missed something before, because what we should do here actually is, before we continue, we should check whether a place is actually existing, because this is our general error catching part, but we never check whether a place ID actually exists. Let's quickly implement that. If place like this, so if we don't find a place for the provided ID, well then we want to return an error stating that we could not find place for this ID, error code 404, and of course return next error like this. So this is what we forgot before. Now this is a better error handling syntax, I would say. So let's now focus onto this try catch part though, because actually this is exactly the same approach that we followed when creating the place. Of course, now we don't want to save and push, but, well, remove and pull, little hint here. But generally, the handling of this code is exactly the same. So we again need a session to start our transaction, and only if we can delete the place, and if we can delete the place ID from the corresponding user, then this transaction should be executed. Otherwise, we will have an error here. So this one, something went wrong, could not delete place. So now is your chance to pause the video at this stage and to implement this code on your own. After that, we'll do it together. So let's see. We already have some code here. I would like to start from scratch though. For that, we first need to create our new constant for our current session. Here we have to add await as it's an asynchronous task. And now we need to use start session here. With start session, we can now use the start transaction method here. And with that, we can get started with the actual logic we need to make sure we can delete the place. First, we need to remove the place from our places collection. We checked before whether the place exists. Therefore, we can simply refer to place remove here. And we need to add the session property here to make sure we refer to the current session, so ses here, so this is the session that we just created. And removing also is an asynchronous task. So we remove the place. Now we have to access our place stored in the creator, so the place ID. For that we refer to place.creator, and in the creator we want to access places, so our places array, and here we now don't want to push but to pull, well, what? Our place. As explained before, for push, pull will also automatically remove the ID, so we don't have to explicitly tell Mongoose to remove an ID. This is done internally by default. This should hopefully remove the place from the user. What we need to do now is we need to save our newly created user. This is again an asynchronous task, and we refer to place.creator and now to the save method. Very important though, as we did it for remove with our places, here we again have to refer to our current session. You can name this of course as you prefer. This is the name of the constant here. We can use places pull and save on creator like that because creator, well, thanks to populate, gave us the full user object linked to that place. And if all this was successful, then we can finally commit our transaction. So this is it actually. With that, we can also hopefully remove a place. The response right here is fine, so we can keep this. So let's save this and let's go to MongoDB. And let's say we want to delete the Empire State Building now. For that, we need our object ID here. So this one. So let's copy paste this. Now let's go to Postman, create a new request. This time, this is a delete request. This goes to /places here, and now our ID that we just copied. If we hit send now, we can hopefully delete the place, and we should also see that the place is no longer part of the array in our user. So let's hit send. And this looks good. We get the message deleted place here. Let's also have a look at this in our database. If we reload that, we can see places is empty, so this worked fine. And also for our user here, we still have the array, but as you can see, we don't have any more places here in our array. Therefore, deleting the place from the user also worked fine. With that, we are almost done with this module. There is actually one optional thing I would like to show you, because here we use this populate method. And there is another part in our project where we could use this populate method. This is optional though. I just want to show you how this method works in a bit more detail. And the place where we can use this as an alternative is here when we get our places by the user ID. So in this constant here, this is the last part of this module in the end. So let me show you how we can use an alternative syntax here with the populate method. So how can we change the logic of our get places by users ID constant here? As I said, this is a totally optional approach. Therefore, we don't have to do this here, but for demonstration purposes, I want to show you this. Now keep in mind that here, down there, in our delete place constant, we used populate to get access to the entire content of a document stored in a different collection. We use the creator property here, but with the creator property, which contains the ID, Mongoose can simply access the entire content of this document stored in the other collection. And with that, we can then interact with this document. As we saw it here, we were able to change, for example, the places property. So that's the idea. You get access to the entire content of another document stored in a different collection. Now, and with get places by user ID, it's the same logic. Here we are searching the place for a specific user ID. So the user ID we are providing because we want to get back the places a specific user has stored. But to display all places a user has, we can also use this populate syntax. For that, let me maybe comment this out here as I want to rename this variable. Let's name it maybe user with places like this. And now here we say that user with places is equal not to place.find, but to, well, user.find by ID, right? Because here I want to look for a specific what? For a specific user ID. So the user ID that we send as part of our GET request. So up here, ID, not with a capital D here though. So this is the part where we search for a specific user ID. And with populate, we can now get access to the corresponding places a user has. And for that, we only have to access the places property as part of our populate method here. And that's it actually. We can now search for a specific user ID and check the corresponding places. Our error message right here is still fine, so we can leave this one. Down here, we have to change our variable name now though. So we say whether we cannot find a user with places or whether not places.length, but user with places dot places length. So this is also correct here. The last adjustment we have to make is down here in our response. Here we now also don't use places.map, but we want to access the user with places.places. And with that, if we save this, we can now quickly go to our database again and reload it. And here the thing is, as we deleted all our places before, we should create a new place maybe. For that, I'll grab our user ID here and now go to Postman. So let's now quickly create a new place here, a post request to our well-known route in the meanwhile. So /API/places, go to the body, raw JSON, and here we can now again enter the data. Title would be the Empire State Building, maybe one last time. Description, a very nice building. The address will be added soon. I just want to copy paste the creator ID first here in our creator. So this one, and now the address again from Google Maps here. Let's now see if this works by hitting send. Yeah, this looks good. The place was created. Let's now add a second place to show you that this also works with multiple places. So maybe the Madison square garden, awesome for great events, and also quickly the address here. So let's also create this place. Looks fine. And now we need to create a GET request, because now I want to see whether I can get the places. So /API/places. But here it's now /user. And now we have to enter our user ID. Let's copy that again, paste it, and now send the GET request. And as you can see, now we get all the places which are part of our user by using the populate method. And just to show you that this works, if I would change 7 to 8 here, then we should get an error. Yeah, we could not find places for the provided ID. With 7, this is working. And if I go back to our database and reload it, you can of course also see that we have our user and now these two places in the database. And that's it actually. With that, we implemented a lot of core logic in this MongoDB and Mongoose module. Before we summarize what we learned, let's quickly have a look at our code and see if we can clean it up a bit. Before we conclude this module though, let's have another look at our code and see if we can clean up some things, if we have some redundant code and so on, because we changed a lot throughout this module. Therefore, let's make sure to keep the code as lean as possible here. Up here, the first thing I see is our dummy places part. I don't think we need this anymore, so let's delete these right here immediately. I think this out-commented code can also be removed. Here, we also got some out-commented code. I think we can also get rid of this right here. Also this part. Then let's see here. Yeah, we could actually leave the places here, to be honest, as this is just an alternative way. So let me maybe add our previous syntax here once again, just to make sure you can refer to it. So this was the previous logic we had before we changed our approach to the populate method here in the last lecture. So I'll just keep this as a reference here. So this should be helpful, I hope. This looks all good for me. Maybe also format our code a bit here like this. And the rest looks fine for me at this stage. Here we again have some code we don't need anymore. So let's delete this one. Yeah, and I think the rest of this file looks all right, so we can keep this code. Let's also have a quick look at our users controller here. Here we also have some dummy information, so let's delete our dummy users as we don't need these anymore. Could also get rid of the UID here actually. We don't need that ID generator. So this looks okay now. And if I look through the code, this generally looks quite fine. I don't think we have any more dummy code in here. Same thing for place.js, I guess. This looks also good. And also our user.js file looks all right. Let's also check the places routes quickly, whether we have any kind of comments here. No, this looks okay. And in the users routes, yeah, here we have test@test.com. I guess this code can also be removed, this out-commented code. And in the app.js file, we can also get rid of this out-commented code here, I would say. But the rest looks all right. With that, we really arrived at the end of this module now, and now is finally the time to conclude what we learned. Throughout this module, we learned a lot about how to work with databases from our Node Express backend. We started in the place.js file here. Here we defined our schema and the corresponding model, which we then used in the places controller. Here we were able to perform all CRUD operations, so create, read, update, and delete, referring to our places here. We then applied our knowledge also for the user.js file. Here we again created a schema and a corresponding model, and then were able to create new users or to get the existing users in here in our users controllers.js file. What was missing though was the connection between these two parts, so between the places and the users. This is what we finally added in this module. We learned that we can connect different models and schemas with the ref property right here. And this allowed us to create places and to make sure that when we create a new place, the ID of this place is also added to the corresponding creator. At the same time, we have the creator ID stored in the place. And we also made sure that if we delete a place, that this place, so the corresponding ID of this place to be more precise, is also removed from our creator. As part of this, we learned awesome methods like down here, our populate method, which makes it very easy to get access to documents stored in different collections in MongoDB. So this is it. This was the database part of this course. I hope you enjoyed it. And now we can continue with the next part, and this will be connecting the front end and the back end.
So now that we worked on the backend and were able to send requests to our REST API there, and with Node Express and MongoDB, we are able to store data in the database as well. It's now part to connect the front end we also worked on with the backend, so to connect React with our backend API. Therefore, in this module, we will work on this connection. You could say this, therefore, kind of is the heart of this course, at least if we have a look at the title of the course, because now we're going to bring MERN together. Now we are going to connect React to MongoDB Express and Node.js. Therefore, in this module, we'll have a look at how we send HTTP requests to the backend, to the API from inside our React app, and how we use the response data we get back. We'll have a look at how we can handle errors if something goes wrong, if we're sending invalid data or something like that, and also how we can handle a loading state and show a loading spinner to our users whilst we are waiting for an action to complete or for data to load. And of course, we'll also make sure that we appropriately update the user interface once data was loaded or once some action completed. So, plenty of work to do. Let's not waste any time and instead dive right in. Now, in this module, I will switch between the backend code setup, which you can recognize by the word backend here in the top left corner, and the frontend, the React project with, well, frontend here, so that you can always quickly see where we're working on, backend and frontend. And now for the backend, I will start with one tiny adjustment in app.js, where we have our connection string to the database. There, I will now connect to a new database so that we basically start from scratch and we kind of clear all the data we created in the previous modules so that we don't have any old data lying around in the database. So here I will connect to, let's say, MERN in my connection string so that all data gets written to collections in that database. And other than that, I'm fine with the current state though, and we can dive right in and get started. Now, what does get started mean? Now, obviously, we got all our routes here on the backend to which we can send requests. And just as we started in the MongoDB sections with implementing the create methods first so that we can work with places, for example, I now also want to start implementing the connection for creating something, specifically for creating a user. Why do I want to do that? Well, because on the backend, in the end, we need a user document, so to say, to then also connect it to our place, because we have this connection set up there, and we have all the code for establishing this connection, for example, in the places controller in the create place function. There, when we do create a new place, we connect the place to a creator, which we get here from our incoming request. Later, we'll change this a little bit, and which we then, of course, also look up in the database so that we really only continue if we do find a user for that provided ID. So because we have that user place connection, it makes sense to start with creating users because we need users to create places, kind of. Therefore, on the front end, of course, it's the auth page I want to start on, because there we have our auth submit handler, which in the end fires whenever we, well, authenticate. So whenever we log in or sign up. Now we'll have to tweak that logic here a little bit because I actually want to do different things depending on whether we are logging in or signing up. If we are logging in, after all, I don't want to create a new user. If we are signing up though, I do want to create a new user. In both scenarios, however, I want to send a HTTP request. In one case, I just want to send a HTTP request to the login route, and in the other case, I want to send a HTTP request to the sign up route. That's the idea here. So therefore, let's go back to the front end here, to the auth page, and let's make sure that here we don't just log in as we're currently doing it, but that instead we do send a HTTP request. For this, I will first of all convert this function here in an async function with the async keyword so that I can use async await. This is not a must do. The alternative is to use promises with then and catch, but I prefer the async await syntax here. Now, why do I need it at all? Because we will work with a promise. Because now instead of console logging any inputs, I want to send a HTTP request. And we can do that with the fetch API, which is provided by browsers in modern JavaScript. As an alternative, you could also use Axios or other third-party libraries that make sending HTTP requests simple, but here I will use this built-in API. And now this fetch function here needs a string that points at our backend. So here, I in the end want to point at /signup, or to be precise at /API users /signup. And of course, all of that prepended with our backend host. Now, if I start my backend server here again with npm start, and of course you find a snapshot of this latest backend state attached to this lecture. You'll just need to switch your database credentials if you're using my snapshot and use yours instead. Then, if you run npm install, you should be able to run npm start thereafter and bring up that backend server. And keep in mind that this runs on port 5000 on localhost. So here we want to send a request to HTTP localhost 5000 /API /users /signup or /login, depending on what we want to do. But we first of all need to create at least one user before we can test signing up, I guess. So let's start with this. Now, this sign up request here, if we have a look at our backend routes, should be a post request. So, to configure this to be a post request, we need to pass in a second argument to fetch, and there we can configure this request. For example, we can set the method property to post, and now a post request will be sent. Now, this alone is not enough, though. We also need to set certain headers. So we'll add the headers key here and set this to an object so that we can add key value pairs here, which will represent the headers that are attached to the outgoing request. And there I want to set my content type to application JSON. Without that, our backend will not know which kind of data it receives, and our body parsing in app.js, where we parse incoming JSON data here, will not kick in correctly because it doesn't know it's getting JSON data. So let's set these headers, and of course we need to attach some data. So I want to set a body on this request, and this, and that's now important, always has to be in JSON format. Now conveniently in the browser we have this JSON object where we can call the stringify method, and this takes regular JavaScript data like an array or like an object, and it will convert it to JSON. And here in the end, I of course want to submit my form data. I want to add or send an object which needs to have a name key, an email key, and a password key. Why do I need to send these keys? Well, because that is what I'm expecting on the backend. If we have a look at the user's routes, we see we are validating for a name, an email, and a password. And in the user's controller, when we create a new user here in the signup function, we do extract name, email, and password. So we need to provide these 3 pieces of information here. Hence, here, I will add these 3 pieces, and as a name, I will point at form state dot inputs dot name dot value. Remember, we're having that form state here, which is coming from the use form hook, which manages our different data pieces. When we switch to sign up mode, we add a name field. if we're in login mode, we only have an email and password field. So now this is managed for us by the form hook, and therefore we can extract it here. And of course, extracting just the name is not enough. We also want to extract the email value, and we want to extract the password value. And these values should be valid when we reach the auth submit handler, because we only make this button here, the submit button, clickable if we have a valid form here, thanks to this check. Now, one thing is still not correct though. We don't always want to sign up when we reach this function. This function also gets triggered if we are in login mode. So actually here we should check if is login mode is true. And if it is true, we want to do something else. If it's not true, so if we're in sign up mode, then I want to send this request. With this adjustment, we're now making sure we only send a request to the sign up backend or to the sign up URL if we are in sign up mode. Now, fetch, of course, returns a promise. So since I'm using async here we can add a wait to wait for the response we get back. Now, this actually could also fail. So let's actually wrap this with try catch. So I'll grab all this code here and add it here into try and catch any errors we might be getting. And we'll have to do some error handling here later. For the moment, I will just console log the error. Now, one important word, this will not fail if our backend sends back an error status code, so a 400 or 500 status code. I'll come back to how we handled those a little bit later. For now, let's just wrap it like this and care about error handling later. So we got the response, and when using the fetch API, so this fetch function, the response itself has generally all the response data, but it does not yet have the parsed response body. Instead, we do parse the response body by calling response.json if it's in JSON format, which it is in our API's case, and which is in case of most APIs. This returns a new promise, so we should await this as well, and this will then be our response data, if you want to call it like this. So this will be the actual data in the response body. And if we have a look at our backend, we see what's inside the response is our created user in the end. So we got this back, we got this response data, which should be our created user data. Now for the moment, why don't we just console log this here before we then have a look at what else we could do? One important word about auth login, this should only kick in once all these steps are done, because here we are always awaiting, which means that in the end, this here is in a new then block, so to say, after all these steps completed, even though it's outside of try catch. This will only run, this auth login code will only run once we're done getting the response, parsing the response, and so on. So the order should be correct. With that, if we npm start our frontend here as well to bring up that frontend server, we should be able to send a sign up request. So let's see whether that works. Here is our frontend application. And for the moment, let's click on Authenticate, switch to sign up, and test this. Here I entered max, test@test.com, and then some password and click sign up. And what we see now is actually that we get an error. And this is actually an expected error. Now, what's the problem here? Let's have a look at that in the next lecture. What's causing this error here? This error is a course error. It is an error you might see sometimes when building something like this, when communicating to an API from inside your frontend app. CORS is a security concept. It stands for Cross-Origin Resource Sharing. And the general idea in CORS, or with this CORS concept, is that resources on a server can only be requested by requests that are coming from the same server. So for our backend, which runs on localhost 5000, the idea is that we can only request data from there from an app that also runs on localhost 5000, which our app, of course, doesn't. It runs on localhost 3000. And you might say it's both on localhost, but actually these are two totally different domains. It's like having a page on yourpage.com and thecoolbackend.com. So really two totally separate domains. Now, CORS is a security concept enforced by the browser, which is why we had no problems with Postman. But the browser enforces this, and the browser sees that here we're trying to send a request from localhost 3000 to localhost 5000, and hence it does not take the response by that server. So it's not a server-side error, it's a front-end error. It's an error in our browser because CORS is a browser security concept. To work around that, the server has to attach certain headers to the responses it sends back to the client that basically allow the client to access the resources. And then the browser automatically detects these headers and sees, okay, it's fine, you may access this, and the browser will not throw this error here. So we need to do some work on the backend, and we need to make sure we attach the right headers to our response. And a great place to do that is in the app.js file, because we will attach these headers to every response we send back on the backend. So it's not just on user routes, it's really on every response. Therefore here, let's add a middleware before we forward the request to our specific routes here. And we register a middleware with app use, as you learned. And there I will have a regular middleware function with request, response, and next. So basically what we already learned about in previous modules. And the idea here is that we don't send back a response, but that we just add certain headers to the response so that when later a response is sent back from our more specific routes, it does have these headers attached. So here in the end, we will call next to let the request continue its journey to other middlewares. But before we call that, we want to add certain headers. And we can do that with res set header. This sets a header on the response. And there we will need to set 3 headers. The first header is access-control-allow-origin. So make sure you don't introduce a typo here. It really has to be named like this. The value, which is the second argument we pass to set header, then can be star. This basically allows us to control which domains should have access, so where the browser should allow this. We could restrict this to localhost 3000, but actually here on this API, I'm fine with opening this up to any domain. Keep in mind that this is not a general security concept, but that it's just enforced by browsers. So you can't lock down API access in general here. For example, Postman simply doesn't care about these headers. For the browser, however, this is a first step, but not the only step. It allows any domain to send requests, but it's still not enough. We also need to specify which headers these requests sent by the browser may have. Therefore, we send a new header to the responses, the access-control-allow-headers header. This controls which headers incoming requests may have so that they are handled. We can set this to star as well, but here I want to be a bit more specific. I want to allow the origin header, the x-requested-with header, the content type header. The first 2 are basically set automatically, but the content type header is one we set explicitly on the front end. The accept header, which is also set automatically by the browser. And also the authorization header, which is not set automatically by the browser, but which we will set later in the course. So I will already configure it here. As a next step here, I will add a last header, and that's the access-control-allow-methods header. And this basically controls which HTTP methods may be used on the front end, or may be attached to incoming requests. And there I want to handle get, post, patch, delete requests. Because if we have a look at our routes, these are the type of incoming verbs we handle there. With that, if we save that, our backend restarts. And now we should be able to test this again. Let's go to Authenticate again, switch to Sign Up, enter our data here, and click Sign Up, and it now works. Now you can see that here indeed we are allowing this access, and here as a response we hence got back our user data with all that entered data. Now we do still include the password here, for example, in plain text, which we might not want to submit like this. It is something we can change later once we add authentication. For the moment, this is fine. And therefore here we see that the general auth flow works. If we now check our collections on the backend and we go to that MERN database here, we see there's a new users collection, and in there, indeed, the user I just created. So that's not looking too bad. We are able to send this request, and we made a huge step forward therefore. Of course, though, that's not all. For example, at the moment, we're not giving the user of our application any indication that we're waiting for a response, and we're also not handling errors. So we definitely want to do that as well. So we're sending a sign up request, and that's great. And we got many other requests to send. But before we do so, let's actually improve our setup here a little bit. At the moment, we're sending this request, but there are two things which I'm not liking. For one, we're not letting the user know that something is happening. Now, of course, our application here is super fast because it's all running locally on our machine. So the moment we press login or sign up here, the request gets sent and it only takes milliseconds to complete. This will probably take a bit longer once you really deployed this to a real server and the distance between the user and your code is a bit further. So it would be nice to show some loading spinner, some indicator to the user that something is happening. In addition to that, what if an error occurs? For example, if I switch to sign up here and I hack myself into a wrong form submission by inspecting my content and then manually removing the disabled attribute, now the button is enabled and any user can do that. Of course, this is not a security issue, you're only hacking yourself. But if you do that, nonetheless, you are able to, for example, enter invalid data here. So if I re-enable this, I can press sign up here. And of course, we do get back an error. We can see it here in the log. Our backend validation works. And this is the reason why we do have backend validation, by the way, because frontend validation can be disabled by the user. But still, it's not a great user experience that it still continues and we show no error message. The same, by the way, if we would try to sign up with a user who already exists. In that scenario, we also don't really handle an error. So on the backend, we got some security mechanisms in place. For signing up, we're validating input. And in the sign up controller, when we create a user, we also check whether that user already exists. But at the moment, we're not really taking advantage of this on the front end. We're not giving the user a great feedback, neither for a loading state nor for an error state. So let's change both now. And to change both, in my auth page on the front end, I in the end want to handle, well, two different states, the loading and the error state. So here we already import use state, and with that we can set up new states here in our auth function, our auth component. We have, let's say, is loading and set is loading here. And initially we're not loading, so I start in a false state. And I also have an error and let's say a set error state and function here. And initially we have no error, so this is undefined. Now we can use these two states to kind of update our UI. So here, when we start sending the request, before we send it, I of course want to set is loading to true, for example, because now I am loading and I want the UI to re-render here. Since this here is an async function and therefore all wrapped in a promise, React will also go ahead and immediately update the UI and not batch multiple state updates, for example, state updates that come later together. Instead, it will do this right away because it detects that this is asynchronous and there will be some time between this state update and potential future state updates. So here I set is loading to true. Now we can also, of course, set our error to null here and make sure it is reset, but we don't really need to do that. We should handle that differently. So let's just set is loading to true. Now, once we got our response, I of course want to set is loading to false again. And no matter if we got a response or an error, loading is definitely done. So at this point here, I want to set isLoading to false. Now, if we do have an error, however, I want to call setError and set this to, let's say, error message. It's up to you what you want here, if you want to set this to a more complex object, or if your error should really just be a message which you expect to get here. We can also provide a fallback in case a message property does not exist, where we just say something went wrong, please try again. We shouldn't really need that though, because on the backend we already have error handling in place, which always in the end gives us a fallback error message. Nonetheless, this doesn't hurt, so we now get this set up here, and we're either setting our error state or we're setting the loading state. Now this login thing, I only want to call off login if we didn't have an error, so only here in the try block. And therefore I actually want to set isLoading to false here and here separately. Otherwise I would set it to false after we already changed the context and probably redirect it. So make sure to first clear your local state on this page before you trigger something that might change the component that's loaded. Otherwise we might be updating a state on a component which is not on the screen anymore. So now we have a loading state and we have some error state. Now, of course, we want to take advantage of these new states. And for that attached, you find two new components in the components zip file, which you can drag and drop into your components UI elements folder. That's the loading spinner and the error modal. The loading spinner also has its own CSS file, the error modal doesn't. Now, these are components which do just what the names imply. They render a loading spinner, or they utilize our existing modal. So make sure this import path fits your structure and it points at your modal component file. So they render a modal which shows an error message or a loading spinner. Now with these added back in auth page in the auth component here, let's import those components. So I will import the error modal here from shared components, UI elements, error modal, and of course do the same for the loading spinner, which I import from shared components, UI elements, loading spinner. These two new components help us use our new states we're managing, the isLoading and the error state. Let's maybe start with the isLoading state. Here, inside of this card, I will add a dynamic element where I check isLoading. And if this is true, I want to render the loading spinner, and there, important, add the as overlay prop just like this. You could set it to true, but this is not required. It's true by default if you add it like this. And this in the end will just impact how exactly this loading spinner is loaded. You can check out the loading spinner logic and CSS styles to understand what exactly this does. And with that, if we save this, let's give it a try. Let's go back here. Switch to sign up and enter some credentials here. Click on sign up and now we see a loading spinner and we are redirected. Please also note, however, that I actually got an error here. So I don't want to be redirected. I got an error and still I was redirected. Now that's something we'll have to handle in the next lecture. We're not showing our error modal, but even worse than that, we were redirected as I just said, and this is definitely not what we want. So why were we redirected when we actually had an error? Keep in mind that we only call off login here in the try block, not in the catch block. So if we have an error, we actually shouldn't be redirected because we're not triggering the login action. Well, the problem we have there is that the way the fetch API works, if you get back a 400-ish or a 500-ish error code from the backend, it still treats it as not an error because technically you have no error. You sent a request and you got back a response. Sure, it's a response with an error status code, but that's really just the data attached to the response. Technically, there was no error. And therefore, we don't make it into the catch block if we do have a 400-ish or 500-ish response status code. Now in my application, I want to make it into the catch block though, because for me it clearly is an error if we have a 400-ish or 500-ish status code. And we can thankfully implement this. After we parsed the response body, because I want to use it even if we have an error, after all it's the response body which will include the error message. So after we parse this, I want to check if response OK. The OK property is a property that exists on the response object, and it will be true if we have a 200-ish status code. Or put in other words, if we have a 400-ish or a 500-ish status code, we'll not make it in here. So if response is not OK, we know we have a 400 or a 500 status code. And in this case, I will throw my error here. So in this case, I want to throw a new error, and I will use the default JavaScript error object and basically pass on my response data.message, which should exist here because we send back a message property on any error we generate on the backend. Since we throw an error here, this code will not execute, and instead the catch block should trigger. So if we try this again, switch to sign up, and try signing up with this existing email address again. If I click sign up, we see the spinner, of course only briefly because it's so fast, but then we stay here. And you see now this error gets logged from line 88, which is inside of the catch block. So that's great, that's the first step. But logging it like this is not enough. After all, we do manage our state here. So indeed, it would make more sense to also output some visual element here. And for that, I want to render my error modal. I want to render it next to this card and not inside of it. Therefore, since we must only have one root JSX element, I'll wrap this in a React fragment, this entire card, so that next to the card, in front of it, I can render my error modal. Now, the error modal requires an error which I feed in. And this error should be the error message, so I will just use error, and this now is our error state, which we set with setError. Keep in mind, I named this error here. This is my constant, and this is what I'm passing in on this error prop to the error modal. Inside of the error modal, I then have the logic to show this modal if the error is not empty. Well, and then I also wanna add an onClear prop here, because in my error modal, I trigger onClear if we close that modal, which opens up. It's the default modal just wrapped with some extra logic. So we should provide an onClear prop on the error modal, and there I want to execute a function which in the end resets my error. So here I will add a handle error, or actually an error handler, to stay in line with my other naming function. And the only thing I do here is I will call setError to update my error state and set it to null to basically clear it. And now here I can point at error handler. With these changes made, if we go back and we try this again, try creating a user with an existing email password, and I click sign up, now we get this error modal, and when we click OK, we handle this, we can try again. Now, if I use a new email address, which was not taken before, it therefore succeeds and we are redirected, and otherwise, as you just saw, we get this error. So now we have proper error handling and a loading state in place, and I would say our first HTTP request is looking quite decent. With that, let's also work on logging in. So let's continue our work. We have our sign up functionality. Now let's also make sure users can log in. Of course, keep in mind that at the moment we have no real login. If we check the backend code here in login, in the end what we do have is just a dummy login where we check whether that user exists and whether that password equals the one in the database. But all we send back is just a message, which of course is not really anything that would help us logging a user in for real, because besides this message, we're not doing anything that would ensure that we differentiate between logged in users and not logged in users. We'll worry about a real authentication flow later in the course. For now, let's make sure we can at least trigger this dummy route here. So on the front-end code, when we are in login mode, I basically want to replicate this functionality, which means we can actually move setIsLoading out of the if block and always set this no matter which branch we trigger. And then we can grab this try-catch block here and move that into isLogin mode as well, so into this first if branch. We could also wrap the entire if statement with try-catch if we wanted to. I will separate it here so that we can differentiate the two different pieces more clearly. So now we're sending this request, and of course now we're sending this to /login here, not to /signup. This is important because /login is the route we have here on the backend, /login. So this is the request. It's still a POST request. It still contains JSON data, and it still contains some attached data, however, no longer a name, instead just email and password. Because when we're in login mode, we only have these two pieces of data. Then we parse the response. We check whether we have a 400-ish or 500-ish error code. And otherwise, we continue. Actually, we don't need to log the response data anymore. We certainly do want to log the user here in here if we succeeded, though. Otherwise, we show the error. I can also remove this console log here, by the way. So generally, this looks good. If we now save this, let's give it a try. Let's go to Authenticate and try logging in with a valid user. So this is the correct email I used before and my correct password. And if I click Login, it spins and this looks good. Now if we go back here, I'll try an invalid password now. And it spins and I got invalid credentials, could not log you in. If I enter, let's say, invalid email and a valid or invalid password, doesn't matter because the email doesn't exist, I also get an error. So this looks good to me. As soon as I enter valid data here, I am redirected, and I would say we got login down therefore. We might be able to refactor some code though, because we get a lot of code duplication here. We're sending our request here, and all this state management here really is duplicated. Now, for the moment, I'll leave it like this, because the problem becomes clearer as soon as we also start sending requests on a different page, which I'll do now. I now also want to send a request here on the users page, because there we need a list of users, and therefore now it's time to fetch such a list of users there. So we need a list of users here on the users page instead of our dummy users. So we'll actually get rid of the dummy users here. And instead here, I want to send a HTTP request. And I want to send that request whenever this page loads. And that's a difference, of course, to the auth page. There we send the request in a function when we click the button. Now I want to do this when this page loads. Hence, we could, of course, send a fetch request here, right inside of our component function. And as soon as this component renders, we send the request, right? The problem is, we would also always send this request whenever the component re-renders, which it most likely does once we got the response data and we change something on the page. So we would actually create an infinite loop. To work around that, we can use a React hook, the useEffect hook here. The useEffect hook allows us to run certain code only when certain dependencies change. The code that runs is defined in the function, which is our first argument. The second argument is an array of dependencies, so of data that needs to change for this to rerun. And if this is empty, it means it will never rerun. It will only run once, which is exactly what I want here. So now inside of this only once running useEffect function, we can send our request to http localhost 5000/API/users. And if we check our backend and we check the users' routes there, we see it's just /users. Keep in mind, we only reach this file if we're on API/users here. So it's just /users, which triggers this function, which is the function I want to trigger. And in this function, in the getUsers function, in the end, we return a list of users. So I want to send a request there. It should be a GET request. Hence, we don't need to configure this to send a POST request or anything like that. We also don't need to add a content type header because we're not attaching any data. We're not attaching any content to the outgoing request. And we also, therefore, don't need to attach any body. So this request is good like this. Now it does yield a promise, so we can use then here or async await. Now here's one important rule. Don't turn this function here into an async function. You could technically do that and it would work, but it's not good code. UseEffect doesn't want a function here which returns a promise. And any async function, so any function where you add async, will automatically and always return a promise. So don't do that, it's not good code, it goes against what UseEffect expects here. So instead you can create a iffy, so an immediately executing function. I will name it send request here. This is now a function which in the end has this fetch command in it. This now can use async, and it will then execute this function right away here in the end. So this is just a pattern which I would recommend if you want to use async await, because using async here is not recommended and not really wanted. So now we can await our response here. And then of course we can get the response data by awaiting response.json. And now we want to use the response data. And that's all the difference to before. In the auth component, I didn't care about the response data in the success case. I just called auth login. Now here I do care about the response data. So we actually still want to manage the loading and the error state here, but I also want to manage my response data. So we can again use state hook here and set up some states in this component. We got the isLoading state, which we set with setIsLoading, which initially is false. We got the error state and setError, of course, initially undefined. And we got the, let's say, data state, or actually loaded users maybe, since we know that this is what we'll have here, and set loaded users. And this initially is also undefined, let's say. And now here we got the response data. Once we got that, I want to call set loaded users and set this equal to response data. And now let's have a look at the backend and see what exactly we get back. We get back an object which has a user's key, and that user's key will be an array of users. So in our response, we should have that user's key. So here I want to set my loaded users, which should be an array, equal to response data.users. I also will set isLoading to false here because I want to set it to true right before we send the request. Here, set it to true. We also might have an error, so we can use try catch again, move all of that into try and then catch errors here. And then in here, we can therefore also set isLoading to false, but I also want to set my error to error.message. And just as before, we don't get an error by default if we have a 400-ish or 500-ish status code. So I will check if the response is not okay, so if we have such a code, in which case I throw my own error here. Response data.message. And then we'll still make it into this catch block. We could now also move setIsLoading after try catch so that this only runs no matter if we do have an error or not. Here in the catch block, we then just update the error state. Otherwise, we update setLoaded users. Now I will also add a function, error handler, just as before, where I will call setError and reset this. And now we can add the error modal and the loading state, and of course also then make sure we use our loaded users. So let's first of all import some extra component here. Let's import the error modal from the shared folder, and there from components, UI elements, error modal. And let's repeat this for the loading spinner, this other component we have in there. With both imported, let's go down to our JSX code. And here, items which I pass in should be my loaded users now. But besides that, I will use React Fragment because I want to have multiple top-level JSX elements here, which only works with React Fragment around them. Because, of course, I also want my error modal here. And the error I pass in is the error state we're managing. OnClear points at the error handler. And besides the error modal, I also want to show a loading spinner. So dynamically, I'll check if isLoading is true. And if it is, I will actually add a div here with a class name of center. That's a globally defined CSS rule. And in there, I want to output my loading spinner to have a full screen loading spinner. With all of that, let's see whether that works. If we save that, we get an error here. Cannot read property length of undefined. Now this error makes sense for two reasons. For one, it makes sense because we render a users list all the time. That includes the initial rendering of this component. So before this request was sent and before we got back a response. Loaded users initially is just undefined. And undefined doesn't have a places property, and therefore there is no way for us to render anything. So we should actually only render the users list here if we're not loading and if we got loaded users. Then I want to render this users list so that we don't render this if loaded users is undefined. With that, this looks way better. Now, we still don't output places correctly, and you see I picked a really cool picture here for my avatar. But besides that, you see the number of places is incorrect. There is no number shown at all. The reason for that is that the places we get back now on our loaded users is actually an array of places. In the users list component, we expect places to actually be, well, the number of places itself. So actually, since places now is an array, we just need to change this and set place count equal to user.places.length. And with that, if we save it, we see 0 places. So now we can click on a user and we're taken to that user's page. But of course, we can't load any places because at the moment we have no places. So we want to make sure that now when we are logged in, we can also create new places. However, before we do that, we might want to reorganize our HTTP request sending code a bit because, as I mentioned before, we have a lot of duplication. Managing all the loading and error state is basically always the same. The same is true for extracting the data and checking the response status. And I don't want to repeat that in every component which needs to send a request. This screams for a custom hook. And hence, we will create one. A custom hook that sends requests and manages all the related state. So let's create a custom HTTP hook which handles all this data parsing, response status code checking, and state management logic. So that we just have a function, let's say, which we can call, which then sends a request and which then updates all its state behind the scenes automatically. For that, in the hooks folder, in our shared folder, I'll add a new file, and that is the http-hook.js file, which should have this HTTP hook I want to create. So in there, I will export a function. Use HTTP client sounds like a fitting name to me. And this function here will then, well, do all that stuff we do manually in each component behind the scenes for us. Now it should be named use something to fulfill this rule of hooks using use at the beginning. And we now need to import some things from React, of course. We'll definitely use state because we need to manage the loading and error state here so that in the components that use our custom hook, we got that state managed automatically. Now, what do we want to do inside of this use HTTP client hook? Now, I would say we certainly want to manage our loading and error state in there. So I want to copy that and move that into my HTTP hook. Then in here, I want to have a function, maybe we name it send request, because that is what I want to do there, which in the end should do just that. It should send a request. Now, of course, this function needs to be configurable. We need a URL there to which we want to send a request, the request method, which by default could be get. the request data, so the body, let's maybe name it body therefore, which by default will be null. Headers, which by default will be an empty object. Not null, but an empty object. That's important. And yeah, that looks good to me. Now, inside of send request, we can then call fetch and send it to a URL and pass this configuration object in. In this object, we want to set the method to the method key we're getting here, which is get by default, which is fine if we set it, but which could be post and so on. And I'll use the shortcut here where we don't write this, but let JavaScript expand this. We want to set the body and our headers. With this, we have a reusable function, which thus far only wraps fetch though, right? In the end, we just forward all the parameters here to fetch. So right now, we have no real benefit of using this. Well, for one, of course, this is an async function now. So let's use await here. And now we can do all that data extraction logic in here. So if we go back to the auth page, all that logic we're doing in here, where we get the response data and check the response status code, we can do that in here now. We extract the response data and then we throw an error if we have a 400-ish or 500-ish response code. So now we're doing this in our custom hook and in this function there as well. Now I will also wrap this now with try catch here, of course, inside of my hook, like this. So that in here I can set my error to error message if we got an error. I also want to manage the loading state here, of course. So here, before we try this, I will set is loading to true, and I will set is loading to false once we're done. Now, if we stay in the success case, so if we make it past this if check, I just want to return the response data so that the component which uses our hook and uses this function can handle the data, because we need the data in that component. So here I will return response data then. We could also manage some data state in here in the use HTTP client hook, but I don't want to do that. I just want to return it. Now this hook should return is loading an error and send request so that the component where we use this hook has access to these pieces of information and to this function. So in the end here, at the end of my custom hook, I will return, let's say, an array or actually maybe an object. And there I want to return is loading. And we could write is loading like this, or again use the shortcut. Return my error and the send request function. Now, one important note about send request: to avoid infinite loops, I will wrap it with use callback so that this function never gets recreated when the component that uses this hook re-renders. This function has no specific dependencies, so I add an empty array as a second argument to use callback. But now we ensure, well, that this function, as I said, never gets recreated, and we never have inefficient re-render cycles or infinite loops at worst. This can now be our HTTP client here. One additional thing I want to add here, though, is one other function inside of my hook, the, let's say, clear error function, which will call set error and set this to null. And I want to expose that as well here in the object I return, so that the components which use my hook also can call this function. And now there is one last piece I want to add to this hook, which we didn't really take care about before. What if a request is on its way and we then switch the page? Then we would get an error, right? If I save this, for example, here, I don't use the hook yet, but we have our other logic, and there the same problem applies. And now here, I go to all users and authenticate, then enter my data here, and press this and go back immediately. If I would do this super fast, and unfortunately here it loads too fast, then we might get an error because we're trying to update our state on a component that's not on the screen anymore. In such a case, I actually want to cancel my ongoing HTTP request. To do that, I will create a new constant here in the custom hook, active HTTP requests, which is an array. and which actually is not an array like this, but instead I'll use the useRef hook, which is built into React, to turn this into a reference. A reference here in the end is just a piece of data which will not change, or in this case, which will not be reinitialized when this function runs again. And this function does run again whenever the component which uses this hook re-renders. So now this will basically store data across re-render cycles, you could say. So I got active HTTP requests here, and I want to add an active HTTP request once we send a request. So effectively here, right after I set is loading to true, so before I send my request, I will create a HTTP abort controller with new abort controller. This is an API supported in modern browsers, and I will add this to my active HTTP requests. So here to .current, useRef always wraps the data you store in it in an object which has a current property. So this current property holds this array, which doesn't change across re-render cycles. To this, I will push the abort controller. I'm not managing this as state. For a state, React would also manage it to survive re-render cycles, because I don't want to update the UI when I change this data. This is just some behind-the-scenes data I'm managing here. So I'm storing such an abort controller here. Again, abort controller is a functionality built into modern browsers. And we can assign an abort controller to a request, basically. So here, when we send a request with fetch, we can add a signal property to the configuration object and point at our created abort controller, and there at .signal. This basically links this abort controller to this request. And now we can use this abort controller to cancel this connected request. For this, I will use the useEffect hook here, because useEffect can not just be used to run some logic whenever a component re-renders, but also to clean up or to run some cleanup logic when a component unmounts. And for that, let's say here at the bottom, I will call useEffect here. And my second argument is an empty array. The first argument is a function. And therefore, this only runs when a component mounts. But in this first function, when you return a function, so you return a function in this first function, then this returned function is executed as a cleanup function before the next time useEffect runs again, or also when the component that uses useEffect, so in our case, the component that uses our custom hook, unmounts. So in this cleanup function here, I can then have a look at my active HTTP requests.current property, which is an array of abort controllers in the end. And then with for each, I can go through all these abort controllers, and on every abort controller, I can call abort. And the request to which it is linked will therefore be aborted then. And now that warning which I get here, that the value in current will likely have changed by the time this cleanup runs, that is fine for me. I want it to reflect the latest state, so the changed state. I want to go through all abort controllers we registered up to this point. So this is really just some logic added here to make sure that we never continue with a request that is on its way out if we then switch away from the component that triggered the request. This is our finished HTTP hook. Let's now use it in the components we already have. For example, the auth component. To use this newly created custom HTTP hook, in the auth page component here, I'll replace my existing logic to send a request here with the logic in my custom hook. So here, first of all, we can import this hook. We import use HTTP client from shared hooks HTTP hook. And then here we have to call use HTTP client, not when we want to send a request, but initially in this component, because keep in mind, this custom hook creates everything we need to send a request and then returns us, for example, a pointer at this send request function. And this is then the function we need to call to really send a request. So we can get rid of isLoading and the error state here, because this is now managed inside of the hook. and instead call use HTTP client like this. And then this returns us some data, so we can use object destructuring here to, for example, get access to is loading, to the error, and also to send request, which is very important. Also to clear error, which we need to, well, clear an error. Now with that, if we scroll down, we got a couple of errors. Set is loading does not exist anymore, and we don't need it anymore. It will be done all inside of the send request function, which is managed in our own hook. And instead of using fetch here, I will now call send request, pass my URL, but then actually not such an object here, but as a second argument, the HTTP method. So just post as a string as a second argument. The third argument, if we have a look at send request, should then actually be the body. So back in the auth component, let's grab this piece of data here and add this as a third argument here after post. And fourth argument then is our headers object. This now sends a valid request, hopefully, and send request also returns a promise. This, however, then already has our response data, and we don't need to manually parse it or check for the 400-ish status code. That is already done inside of our hook. Therefore, we don't set is loading here, we don't set it here, and in the catch block, we also don't need to set an error in the end because we're doing try catch already in our custom hook. So we don't need to do any try catching here at all. We can get rid of this because everything will be handled by the custom hook. Here, we will just get back our response data in the end, or undefined if we do have an error. Now I don't care about the response data in this specific component, so I can actually just await and then log in thereafter. Now we have to be careful though with this logic. In the HTTP hook, I said we do have try catch, and we do, but in the catch block here, we're not returning any response. Instead, we're just doing nothing, which means automatically undefined gets returned. Hence, at the moment, if we do have an error in here, we'll actually still make it to this line here, which I don't want, of course. So a little improvement here actually should be that if we do have an error, yes, we set our error, but we then also throw the error again so that the component that uses our hook has a chance of knowing that something went wrong. And therefore, set is loading should be set here, and also here in the success case before we return the response data. So now I am again throwing an error here in the custom hook, in the function there. And so in our component, we want to re-add try catch just to make sure that we don't always call auth login. So let's move that in here, catch any error here in the catch block, and call auth login only in the try block, so if we get no error. In the catch block, we do have an error, and well, here I don't need to do much with it though. We can log it, we can ignore it, because in the end, here in the catch block, I don't need to handle the error. We're doing all of that. We're setting our error state and so on, all in our custom hook. So this can be an empty catch block in the end. Alternatively, you could not use try catch here and use the good old then method on the promise instead and just omit a catch method. Now, similar logic for our other request here. There, I don't care about the response, but I want to send a request here. It is a post request, and the data is this data here. So I will pass this as a third argument, and then these headers as a fourth argument, just like this. That's now send request there. It is in try catch to handle any errors we're getting. We don't need to do anything of that here though. We just need to continue if we have no error, or do nothing if we do have an error. And in the error handler, we want to call clear error, this function we get from our custom hook, or we get rid of the error handler altogether, and in onClear, we just point at clear error, which is this function coming from our own hook. And with that, let's give it a try. Let's save that, go to Authenticate, and maybe try logging in here. If I do that, see the spinner, And I get an error here. I got an error that abort controller is not a function. That makes sense because I do have this abort controller set up in a custom hook, but at the moment I never remove an abort controller from my array of abort controllers if a request completes. That's a little oversight from my side. Of course, we should do that. Once we have a response, we know that the request completed. So once we're here, after we parse the response body. So here I then want to go to my active HTTP requests and set current equal to active HTTP requests.current and filter out this specific controller that was responsible for this specific request. So here I want to filter all my request controllers and remove the request controller which I used for this request, which I do with this logic. This keeps every controller except for the controller which was used in this request. With that, we're not having any old request controller, which we then would try to use to cancel a request which is not on its way anymore. But in addition, the error actually also, of course, occurred because here I have abort controller.abort controller. The function is just named abort though. So we got an error because I was calling a function that doesn't exist, but this call shouldn't have happened in the first place, which is why adding this logic here also is important. We want to clear the abort controllers that belong to the request which just completed. But of course, we also want to fix this error down there and make sure I use abort and not abort controller as a function name or as a method name. So with this change now, we make sure we don't try to cancel a request which already completed. And therefore, if we test this again here, this looks way better. Now, let's also try signing up here. And let's first of all try this with credentials where we should get an error. This works. If I use valid credentials, this also works. And if I try signing up with invalid data, logging in with invalid data, I get an error and I only continue if I have valid inputs. So this is looking good to me. It looks like our custom hook is doing its job. And with that, we can continue and we can use this custom hook in our users component as well. Definitely feel free to try to implement it there on your own first. In the next lecture, we'll do it together. So let's use our custom HTTP hook in the users component. For that, first of all, we need to import it, of course. Import use HTTP client from shared hooks HTTP hook. Then, just as before, we can get rid of these states, not offloaded users. I do want to manage this here in this component. So I will call use HTTP client here. And what we get back, just as before, is an object which we can destructure. There we'll have the isLoading state, our potential error state. We'll then also have our send request function there and the clear error function. Now here I already got send request as a name, and to avoid duplication I'll name this here fetch users and therefore call fetch users here, of course. So a little adjustment in the use effect function. Then in here we can get rid of set isLoading, and then here I want to have try catch, of course, but I will await send request, so this function that comes from my custom hook. This needs our URL and actually nothing else, because it is configured to, as a default, send a GET request, not add any body, and not add any special headers. So this is just fine as it is. We don't need to do that parsing, as you learned. However, of course, what I get back here is my response data now, because we do that parsing in the send request function in our custom hook, and therefore here we can set our loaded users. If we have an error, we don't need to do anything here, and I will remove set isLoading here. Now you see, useEffect complains here about a missing dependency, because now indeed send request is a dependency of useEffect. I used the send request function in there, and the send request function is coming from outside the effect. That's why it is important to have send request be wrapped and use callback here in the custom hook. Because if this would not be wrapped in use callback, it would be recreated whenever the hook reruns, and the hook reruns whenever the component that uses the hook reruns, because there we call use HTTP client, and it is just a regular JavaScript function after all, so of course it executes again. And if this reruns and gives us a new send request object, even with the same logic in the function, it's technically a new object, use effect would fire again, send a new request, and we would have an infinite loop. So use callback around send request in our custom hook is super important. With that, we can correctly specify it as a dependency here, as we should, and we are sending our request. Now we can get rid of the error handler and just point at clear error here on the onClear prop. And with that, we should be good. If I now reload, you see, this seems to work. If I reload, we're fetching the users. Now let's also see if we correctly get an error here. If I, for example, sent this to an invalid URL where I removed the S at the end, and I get an error, could not find this route. So this works. Of course, our application is broken now, but this clearly also is an error we should catch as a developer during development. So with that, it works again. This is looking pretty decent to me. We're using our custom hook here, and with the custom hook added now and being used in all our user-related routes, it's now finally time to make sure that if we are authenticated, we actually also are able to create a new place here and send a request to the appropriate backend route there as well. So let's continue working on our connection between frontend and backend, and let's now focus on adding places. That's something which is missing right now, which of course should work too. So in the frontend, under places, pages, new place.js, of course I want to send a request here in the place submit handler instead of console logging this here. Now that shouldn't be too hard. We can import our custom hook. So we import use HTTP client from the shared folder, the hooks folder, the HTTP hook file, and then just as before, execute this here in this new place component. Use object destructuring to get the interesting pieces out of it, like is loading, error, send request, and of course clear error. And now we can use all of that here. So for example, here once we submitted the place, I want to send my request, of course. The URL here is http localhost 5000/API/places. And then let's check our backend. Here under places routes, we see for creating a new place, it's really just /nothing thereafter. It is a post request as we just saw on the backend. And for the data which is attached, it has to be JSON data here. So I'll stringify this and pass in an object which needs to have a title, needs to have a description, needs to have an address, and also important on the places controller in the create place function, we see we also try to extract the creator, so the ID of the user who is responsible for this place. So we should provide all that information here. Title, of course, here is form state inputs.title.value, because on this form we are managing title, description, and address. So we can also copy this to also pass on the description from form state inputs description, and then here the address from form state inputs address. Now for the creator, we have a problem. At the moment, we're not really managing the user ID here on the front end in a central place. Now with the help of our auth context, we could actually do that. We're currently just managing is logged in here. We could also manage a user ID here, which initially, let's say, is null, which we then want to send once a user is logged in. So here in app.js, where we do manage the data for our auth context, we could manage user ID as a new state and set user ID here. On login, on this login function, we could expect the user ID, the UID as an argument, and then call set user ID here and set it to that user ID. And when we log out, we reset it and set user ID back to null. And then we feed that user ID back into our context. So down there, where we set the value, we now also set user ID, and we set it to the user ID state we're managing here. Now, actually, we could wire this all up and go to the auth page And there, when we call login, we want to forward that ID we get back. So here from send request, we do actually get back response data, both for logging in and for signing up. And if we have a brief look at the backend again, we see the data which we do get back there in sign up, for example, is our created user here. And the same for logging in. There we also, in the end, can return our user. At the moment, I'm just returning a message here, but I can return existing user to object getters true here and map that to a user property. With this, we return the user there as well. And on that user object, we of course can get the ID. So we can save this on the backend. And on the front end, response data now has the ID. So on response data, we can now access a certain key. And for that, let's go back to the backend real quick again. For logging in, it's the user key which holds our user. For signing up, it's the same. So we access .user here, .id, and that should be our user ID. We can do that both for signing up and for logging in. And now we should actually manage that ID globally in our frontend. And now back on new place, creator is actually the ID of the user, which we can now get from our auth context. So there we just need to import use context from React and import auth context from this file here. So import auth context from shared context auth context. And then in here, simply get access to this by using our auth context. This sets up a listener to our context here in the new place component. And on this auth object, we can now retrieve the user ID. That's the idea, at least. So here we can point at auth user ID and attach this to the outgoing request as well. Now let's add async in front of this function here so that here we can use await so that we know once this is done. I also want to wrap this with try catch so that we can continue differently in a success case than we do in an error case. So here in the error case, I don't need to do anything actually because we set the error state inside of our hook. But in the success case, I later want to redirect the user to a different page. We can do this as a next step though. For the moment, let's instead take advantage of is loading and error and clear error. And for that, I will again import components we used before. The error modal from shared components, UI elements, error modal, and also import the loading spinner from shared components, UI elements, loading spinner. And now we can use that here if we scroll down to our JSX code. And for one, wrap the form with React fragment so that we can have multiple top-level JSX elements here. Because next to the form, I want to add my error modal here and forward a potential error we might be having. And on clear, on the other hand, just as before, should point at the clear error function. And for the loading state inside of the form, I will check if we are loading. And if we are loading, I want to render the loading spinner in that as overlay mode, which I set by adding this prop. If we now save this, let's give it a try. Let's go back here and log in real quick. That hopefully sets our user ID. And I now go to add place and add a place here like the Marienplatz, a great place in Munich. And the address is Marienplatz 1 in Munich, let's say. And I click add place, I get an error. Invalid inputs passed. Please check your data. Okay, let's check the outgoing request in the network tab. There, this red request is the one which failed. And let's see, what did we attach as data? I did attach all my data here, including the creator, so that's looking good. We got that user ID as it seems. And still, I got back invalid inputs passed, please check your data. So something was not liked about that data which I attached here. And yeah, I know what the problem is. It can be difficult to spot this issue though. When I send the request here in new place, I do add the URL, the method, and the body. What am I not setting here? The headers. And I said we would need to add the content type header and set it to application JSON. Otherwise, the body parser on the backend would not be able to parse that. And correctly, therefore, the backend would not find the appropriate data. So now with that added here, with this header added on the front end, let's try this again. Let's log in again, create a place here, the Marienplatz, a great place in Munich, and add this address and click add place. And now at least we get a different error. It fails, but with a different error. The message is creating place failed. Please try again. It's a 500 status code, so not a validation error. And this error now has a very tricky error source. Keep in mind that on the back end, we're working with transactions here, right? And if you're working with transactions, this on-the-fly collection creation, which normally works, won't work. So you need to make sure that you first of all create a new places collection here in your database before this operation can succeed. This is of course just a one-time task. You only do this when you set up your application for the first time. With the places collection added here, if we now click add place, this should succeed. And this is looking pretty good to me. We get back a success status code. We're not redirected because we have no logic for that, but we do get the right status code. And if we now inspect our places collection here, we should see our new place here. We see it points at a user who ends with 15E7. And if we have a look at our users, we see that's this first user. And there, if we have a look at the places array, we see that ID of the place we just added, which ends with 05616. That's this place. So storing places works. Now on the front end, I just want to make sure that if we do succeed, so here instead of this comment, we really do redirect. And that's easy to do. We can import something from React Router DOM, and that's the use history hook from React Router DOM. So it's a custom hook provided by this package, you could say. And it's very easy to use. You just execute it. Let's say here after our custom hooks, we call use history. And this gives you a so-called history object, which you can store in a constant. A constant I will here name history. The name is up to you. And you can then use this to redirect, because this history object has a push and a replace method, for example, which allows you to go to a new page by adding it on the stack or by replacing the current page. And here I want to allow the user to go back after the navigation, so I will push. And I will push the user to /nothing, so to the starting page. With that, if we save all of that and we create another place here in our application, we first of all need to log in. Later, we will ensure that users stay logged in. For the moment, we'll have to re-log in. And then I will add a new place here, Empire State Building, an amazing skyscraper. And here I search for Empire State Building in New York. Let's see whether that works. If I click add place, this seems to work and we are redirected, as you can clearly tell. And now just to double check, if we reload this page here in the collections screen, we should now see two documents, and one of them is the Empire State Building with the automatically fetched location and so on. And our user with whom I logged in should now have two places at whom it points. So this is working, and with that, let's ensure that now that we can add places, we can also fetch them on a per user basis if I click on a user. And don't worry that they're all looking the same here. Later, we will add a functionality to upload your own profile picture. So for now, let's make sure that when I click on max here, I do actually fetch the actual places of that user. Of course, that is something you can try on your own first, before we then do it together in the next lecture. So let's make sure we can update a place. For that, when we go to update place, we want to retrieve that place by ID. And at the moment this fails because I worked with dummy places thus far, and in there we can't find a place for the logged in user or for the place ID in the URL, which we actually try to do. So this won't work. Instead, I want to fetch the place data from the backend because that is a common requirement, that you have a single page with details about some entity in your application and you want to fetch the latest data from the backend to display it there. Now, conveniently on the backend, we have a route for this. This get route where we then trigger get place by ID in the end. So now we just need to send a request to this URL from our frontend. So here I will import use HTTP client from shared hooks, HTTP hook, and just as before, initialize it here. So here I can use object destructuring thereafter, call HTTP client. And now we already have a isLoading state here. Let's get rid of that. This is now managed by our hook. So here we have isLoading, we have error, we have send request, and clear error. All the things we already worked with. Now I want to send a request when this page loads to load the latest place data. For that we need use effect, which is already imported, and we will need use state to manage our loaded place data as well. So we'll add a state here, loaded place, and set loaded place, and manage this with use state, and initially that's undefined. Then here, instead of using our dummy places, I want to use effect to send a request and fetch my data. So here in use effect, I'll have send request as a dependency, and I'll also have the place ID, which we get from the URL as a dependency. And in that function, I now want to fetch a place here. So just as before, I'll add a fetch place function in here so that I can conveniently use async await and call fetch place immediately thereafter. And in fetch place, we can now send a request, await the response, and there we got our response data. And here, of course, we need to provide a URL on that request. The URL is http localhost 5000/API/places, and now if you verify this on the backend, /some place ID. So here we simply inject the place ID we got from the URL. This should get us a place. Of course, for whatever reason, this could fail though, so let's actually catch any errors. We don't need to handle them here though, because we do have error handling built into our custom HTTP client hook. And therefore, here we just need to worry about the success case. If I got my places, I can call setLoadedPlace. And now on the backend, if we have a look at the places controller, we see that getPlaceById in the end returns an object with a place key, which contains that loaded place. So here, we want to set the loaded place to response data.place. So this will fetch a place. Now, whenever we fetch a place, we also want to update our form data, right? Before we did this here with the identified place, now we can actually grab this setFormData call here, remove this entire use effect call down there, and instead not just set the loaded place, but actually set form-data, and here use response-data.place.title, response-data.place.description. That just means that we should add setFormData as a dependency here. Now with that we're updating the form correctly, we're storing our loaded place. Now down there we need to check if we got a loaded place, because if we don't, then I want to render this fallback. Otherwise, if we're loading, I'll render this. Though we can do better now actually. We can use a loading spinner here. Make sure you add the import at the top, and you import loading spinner from shared components UI elements loading spinner. And whilst we're there already, we can import error modal from shared components UI elements error modal as well, so that we can also output errors. So now we got that imported. And if we now scroll down, we're rendering our loading spinner here if we are loading. And if we're not loading and we got a place, then here I want to return React fragment so that I can also again use my error modal here and render error modal like this, forward the error, which we get, and point on clear at the clear error function. And of course, you could also, just as before, check is loading here and output a loading spinner here if you wanted to. I just also want to show this alternative of doing this in an extra if statement. Now, one extra tweak I want to apply here is I want to check if we don't have a loaded place and we're not having an error, then I want to show this fallback. Otherwise, we should make it to this block here. And if we now save this, let's give it a try. Let's authenticate here. Log in, and now click on edit, and there you saw could not find place briefly before this is loaded. However, the form is definitely not initialized correctly here, and the reason for seeing could not find a place is that I check is loading too late. I should do this before I check if we're maybe not loading anymore, but we got no place in error, so I should have this order here. But the reason for the form being empty is a different one. We're simply rendering the form too early, and therefore the input gets initialized too early. Here I want to check if we're not loading and we got a loaded place. And only in that case I will render the form. With that added, if we now save this and we log in again, go to our place here and edit it, and we're still not seeing our initial values here. Now we can fix this by changing our logic here in the form a bit more. I'm checking if we're not loading and if we have the loaded place. Now actually, we can also use that loaded place, which we know will have the initial data from the backend, to set our initial title here and set this initial validity to true therefore. And down there we can set this to loaded place.description and setting this to true, and that should do the trick. If we now save that, we log in real quick again. We go to edit here. Now this is initialized correctly. Now briefly, you see the loading spinner there, because our data of course arrives super quick here in this application. And then here we have our data. Now let's make sure that we don't just load the data we want to edit, but that we actually also are able to change it and then click update place and store it on a backend. Now to store our update on the backend, we got a specific route, of course. In the places routes, we got this patch route where we just need to point at API/places/place ID, and where we then add the title and description to the body of that request. So on the front end, in update place.js in the places pages folder, we want to trigger that whenever we in the end submit this form. So here, this will now be an async function so that I can use async await in there. And then here we want to send a request. We want to send a request to the backend. Now, just as before, I will use backticks here so that we can easily inject data into this string. And we'll point at localhost 5000/API/places/ the ID of that place, which of course is place ID, the value we already have available here, which we're extracting from our frontend route, from our frontend URL. Now, this is not a default request, so we need to add a second argument where we set patch instead of the default of get. I want to add a body, and this has to be stringified data, so JSON data. And there we should have our new title, which we get from form state, inputs, title value, and the new description, which is form state, inputs, description value. And last but not least, let's also add our headers here. And there, you know, we need to add this content type application JSON header for the backend to parse the incoming data correctly. We can then await this and wrap it in try catch to make sure that we only continue in the success case. So here I catch any potential errors, but I don't do anything with it. And then here in try, I await the response. I'm not too interested in the response actually, because I just want to redirect the user if we have a success response. So for that, from the React Router DOM package, we can import the use history hook, which we already used before, and then use it here to create such a history object, which then gives us all these functions to move the user around in the front-end navigation. and use history here after awaiting for our response. Here after awaiting for our response, call history, and then maybe push to /nothing. And it's up to you to which route you want to redirect. Actually, here it maybe makes more sense to redirect to the overview of places. And for that, we need the user ID, because we get to that places per user overview page by encoding the user ID in the URL. And to get that user ID, we need to tap into our context, because that is where we manage our user ID of the logged in user. And for that, we also need to import auth context from shared context auth context. And then here in update place, maybe right at the start, we can tap into this context by using use context and pointing at auth context. And now with that, we get this auth object. And when we want to redirect, we redirect at /, then the user ID, and then /nothing was it, right? If we check app.js, all places are loaded for user ID /places, actually, of course. So /places at the end. With that, if we save this, this should actually already be all. If we go to our application and we log in real quick, and I go to my places and I added this and add exclamation marks here, a great place in Munich, definitely worth a visit. And I click update place, we see the loading spinner, and then we are redirected. So this definitely works, and you see the changes reflected here. And of course, also reflected if I reload, right? Then it's still there. We are logged out now, but it's still there. So this worked just fine, and we are now able to update places as well. So let's finish this up by now making sure we can also delete places. So the missing piece is that we can delete places, and for that, on user places, on a single place, so on such a place item actually, in the place item component, we got that delete button, and there at the moment we're just console logging deleting. Here instead I want to send a HTTP request now. So to do that, again, we import our custom hook. So the use HTTP client hook from shared hooks HTTP hook, of course. That's the hook we need. Now, just as before, we can initialize it here with object destructuring and get is loading, error, send request, and clear error, all the functionalities we used multiple times by now. And we want to send a request in the confirm delete handler now, because that is when we're sure that we want to delete. We can turn this into an async function, therefore, so that we can use async await in there and call send request and send this to a specific URL, which has a dynamic segment, which is why I'm adding backticks here, or why I'm using backticks. Because if we check the backend and our places routes, we see that the place ID needs to be part of the URL. So we need to send this to localhost 5000 /API /places /the ID of the place. So here it is HTTP localhost 5000 /API /places /the ID of the place. And we get that place ID here through props. In place list, I forward the ID prop here, which points at the place ID. So in place item.js, I can just use props.id here. This sends a request, but by default a GET request. So we should change this to delete to make sure it's a delete request. We don't need to add any body or extra headers though. We can then await this and of course also wrap it in try catch to ensure that we only continue if this really succeeded. So here in catch I won't do anything. If we succeed, the question is, what do I want to do? Well, in the end, I want to reload the page we're on, right? Because in the end, we are on the page where we display all places. Well, if we deleted a place, I just want to make sure that we update the current page. Now, in the place list component, we in the end map our list of places into place items. And we get our items here from user places in the end. And in user places, we have our loaded places. So in the end, we need to tweak the loaded places once we delete a place. So in the place item component, once we're done deleting, I will call props on delete and expect that on delete, I get a function, which in the end, therefore, is executed through that prop. So in the place list component, we have to make sure that we set the on delete prop on a place item, which is where I call this, to a function, which I expect to get from outside. So here on place list, I will also call on delete place, let's say. So I will forward this to another function I expect to get on a on delete place prop directly on this place list component. So now we need to set on delete place as a prop on the place list here. On delete place. And now here in user places, which is the component I'm working in now, there I want to trigger a function. Place deleted handler maybe. And here I want to update my loaded places appropriately. So let's put place deleted handler into on delete place. And therefore in the end we forward it to on delete in the place item. And in user places in the place delete handler, I then want to call set loaded places and update my loaded places. And I want to update them such that they filter out the place which was just deleted. For that, we can use the function form of setting a state here. So we got our previous places, and I want to return the new places. And the new places are based on the previous places, but there, this is an array. I want to call the filter method to filter out a certain place. So I will go through all my places here and only keep the places where the ID is not equal to, let's say, the deleted place ID, which I expect to get as an argument here. So I expect to get this parameter here, deleted place ID, and only if the place I'm looking at in my existing array of places is not equal, I'll keep it. Because if it is equal, it's the place I want to delete. So in the new array, which I return here, it should not be included. So that I set my loaded places state to a new array where the deleted place is filtered out. Now we just have to make sure that we pass this deleted place ID to this function. And in the end, we are calling this function place item.js here. So here we should forward props ID because that's the ID of the place which was deleted. This is the trick, hopefully. This should do the trick. Now let's still handle the loading and the error state here. And therefore, we import the error modal from shared components, UI elements, error modal, and of course import our loading spinner here from shared components, UI elements, loading spinner. And with that, if we go down there, in React Fragment, we can add our error modal here. And there forward our error we might be getting and point on clear at clear error. Side note, also make sure that in confirm delete handler, you call set show confirm modal false first so that you close the confirm modal before you send that request and maybe also open up an error modal thereafter so that we don't have multiple modals open at the same time. And to also show loading state, I'll scroll down and here inside of my card, so on top of this place which I want to delete, I will check for is loading and then send or render my loading spinner in that overlay mode if we are loading. With that, if we save this, here are the places. Let's now log in like that. And now here, if I click delete, I can cancel, of course. But if I click delete here, you see the loading spinner and we're done. Now this here looks good to me. It seems to work. If I reload, let's see if it still is gone. It is. And if we check the database now and we refresh the places, we should only see one place. Yes, we do. And for users, if we check that, we should also see that the first user only has one connected place, so that this connection to the place was also cleared there, and the other users have no places. And this is looking good to me. It looks like our application is working, and we successfully connected frontend and backend. Now, one error I just spotted in the application we built is that I forgot to change something in nav links here, where I load my places. I always point at U1, and as a result, when being logged in, if I click my places, I always get this error here. Now, therefore, we should change this, of course. This here should be bound dynamically to a string where we say something dynamic and then slash places. And the dynamic thing here is coming from the auth context and should be our user ID. So that we use the real user ID here and not that dummy user ID. So with that, if we are logging in here and I go to my places, I might not find any places for this specific user if he hasn't created any. But if we have a place, like here a dummy place I created behind the scenes, then we do succeed. So that is an adjustment you should make. Fix that nav link to ensure that your navigation app works correctly. Now there is a tiny fix or a tiny improvement I want to apply. If we check our auth page, we can see that in the end, on the validation rules for the password, we expect a minimum length of 5 characters. Now on the backend, on the user routes, you see I expect a minimum length of 6 characters. Now I like 6 better, so we'll actually also tweak this on the front end to be 6 so that this is equal. Just a little thing so that we don't allow access on the front end and we treat something as valid, which we then deem as treat valid on the back end. To prove the problem we would have had if I set this back to 5 on the front end, if I switch to Signup and I create a new user, manual, with test4@test.com, which is an untaken email address. Now here, if I enter a valid password on the front end with 5 characters, I would get an invalid inputs passed error, which of course is a super bad user experience because it seemed valid. Now, if I switch this to 6 here on the front end as well, this changes. Now, if I go to sign up and I try to create manual as a user, I have to add at least 6 characters for this to be valid. And then I can indeed sign up. And surprisingly, manual looks like me. Awesome. So this now works. One other issue we see, however, is of course that after logging in, I can also edit and delete here, even though I'm now logged in with manual. And in general, if I do log in, let's say with test2@test.com, which also is another user, I can also click edit and delete, and these buttons also will work. Now the reason for that simply is that if we check out the placeItem.js component, there I do render these buttons whenever I am logged in. Now actually we can improve this as well. Now we are storing the user ID in the auth context as well. Keep in mind, if we are logging in app.js, I do set my user ID and I do pass that back into auth context. So since we have the user ID stored there on a place item, we can actually refine this and not check whether we're logged in, but instead check whether the user ID is the same ID as the creator of this place. Because when I create my place item, I forward the creator ID here. So on place item here, I actually can say, check if user ID is equal to props creator ID. And only if that's equal, I want to show these buttons. So if I save that and it reloads, when I'm not authenticated, I don't see them. Now, if I log in with the wrong user who did not create these places, I also don't see them. And only if I log in with the correct user here, I do see them. So that is an improvement here, both here on place item as well as the auth page with the authentication to make sure we provide the correct user experience. Oh, and here on the auth page, of course, I also want to tweak my error message here to reflect the new requirement of 6 characters for the password. This is it though. With that, we're having a good state here and we can certainly continue. We connected our React frontend to the backend, and obviously connect really just meant sending HTTP requests from inside the React app to the backend. But this is what it's all about. Before, when we worked just on the backend, we only used Postman there. Now we're doing this from inside our React app. But one thing was missing: image upload. Thus far, we worked with some dummy image URLs for both the users as well as our places. It would be much nicer if the visitors of our page could instead bring their own images, if we had file pickers in our forms where users could choose images to use. Well, and that's exactly what we'll do in this module. In detail, you will learn how to accept and handle files, or specifically images, on the backend of our application, so on the server side, on Node Express side. And of course, we'll also cover the front end and see how we can add a file picker there in our form and then get that file from the front end with an HTTP request to the backend. All these things will be done in this module. So back in our application, again, I got the front end opened here in one window and the backend in another Visual Studio Code window next to it. Now it's all about accepting files both on the front end as well as the backend. And it's up to you where you want to start. I would say let's start at the front end so that we have a file right away which we then can send to the backend, so that we then as a next step can work on accepting that file on the backend. Now on the front end I got two places where I want to accept files. One is the auth page where new users can authenticate, where they can sign up. When you do sign up, I also want to offer a possibility for the user to provide an image, or not just a possibility, you have to provide an image. So that's one place. You should provide an image here. The other place where I also want to accept a file is in the places area in the new place component. When you add a new place, besides adding title, description, address, and so on, I also want to ensure that you have to provide an image for that place. Because we are using images for places and for users, and I have these really nice dummy images here, well, would be nice to replace them. So, in order to do that, I will build an image picker, and I will build a brand new component for that, which we can reuse both on the new place as well as the auth page. So in form elements, in shared components form elements, I will add an image upload.js file. And of course, you can name this however you want. Attached, you also find the image upload.css file, which you can just copy into this shared components form elements folder, so that in the image upload.js file or in the image upload component we're about to build, you have the right stylings later. Of course, you can always tweak them to your personal preferences. We'll build the image upload component together from scratch now. And in there, of course, I will import React from React, what we always did. I'll set up my image upload component like this, like this, accepting props from outside, and then in there we'll later return some JSX. And of course, we have to export the component here so that we can use it in other files as well. Now also don't forget to import image upload.css to ensure that the styling gets applied. Now, in the image upload component, I want to return some JSX code, of course. So let's write that markup for the image uploader together. Now, as mentioned, of course, there are different ways of building this. Here's just my way. I will add a wrapping div, which has a class name of form-control. This class name, form-control, is provided in input CSS. And whilst you might think that we're only importing this here in input.js, don't forget that all these classes generally are available globally in the application. They're not scoped to a component. We're not using CSS modules or anything like that here. Hence, we can use the form control class also in the image upload component. Now in there, I want to add an input, and that input will be of type file, which is a default input type supported by the browser. This input will also receive an ID of, let's say, props ID, and also a little inline style here, just a quick and dirty solution, where I set display to none. This is how you set inline styles in React. You set an object to that style prop, and then you have your CSS properties on the left as keys, and then the values here on the right as values. Well, and I use display none here because I actually want to hide this input. With display none, it's still part of the DOM, but it's not visible. Because I will expose a button to the user, which the user can click to bring up that file picker, I don't want to show this file picker itself because it's relatively ugly. So I will hide it here, set the type to file, and set accept here to .jpg, .png, .jpg with an E. So these are the file extensions which a user is able to select then later. Now, of course, as I said, this is hidden. So to show it, I also want to render a button. And for that, I will import the button component from /button, like this. Below this input here, but inside of that surrounding div, I'll therefore add a new nested div. This div receives a class name of image upload. And actually, I want to be a bit more flexible there, so I will wrap this and put this into a template literal with backticks. Because I also want to check if we do have a center prop being set equal to true or being set at all. And if it is, I also want to add a center class here. This allows us to later control how the image preview which we'll add and the picker button will be positioned, if they're centered or not. So inside of this new div, I'll add yet another div here. And that div receives a class name of image-upload __ preview, because I want to show a preview of the picked image. In there, we need an image element, therefore. And here we'll need to set the source to something and the alt to something. I'll set the alt to preview. The source is something we will come back to. Now, outside of that div here, so of that preview div, but inside of this div, I'll then add my button. And there I'll just say pick image. Now, of course, we have to set a type here, and I'll set this to type button so that it doesn't accidentally submit any form which we might have around our image upload component later. And I will, of course, add an onClick listener, so this onClick prop, to point at a function that should execute when the button is clicked. And for this, we can add a function here, the pickImageHandler. The pickImageHandler should be triggered whenever we click this button. And in the pickImageHandler, I, in the end, want to make sure that we open this built-in file picker so that we utilize this input component, which is invisible, but which, if we could click it, would open up a file picker. So, therefore, to simulate a click on this, we have to get access to this input element and then just call its click method. And to get access, we can use a reference. So we can import useRef from React and now not use it to store some value which survives re-render cycles, but instead to store a value which actually does survive re-render cycles, but which most importantly establishes a connection to a DOM element. So here I'll have my file picker ref created with useRef and set this here on input by adding the ref key and pointing at file picker ref here. And then in the pickImageHandler, we can use file picker ref .current and then call the click method. This method exists on this DOM node and it will open up that file picker. So we utilize the input element without seeing it. That's my idea here. Now, when this gets clicked, the file picker opens, and once the user chooses a file, onChange fires on this input. So here we have to provide a function that should be triggered once the user picked a file. So here I'll add my picked handler function where I get an event object, and I will wire this up to onChange here, picked handler. And now here in the picked handler, the goal is to generate something that helps us preview that file down there, and of course to then also forward the file to the surrounding component where we use the image upload component in. So for the moment here, I'll just console log event.target, which is the file input in the end, and see what's in there. And now let's go to our auth page here and import this component. Of course, we're not done with it yet, but for the moment we can already use it. So I'll import image upload from shared components, form elements, image upload, and use that here in the auth page. There, my idea is that just as with the name input here, I only want to show this image upload button if we are in signup mode. So I'll have the same check here. If we're not in login mode, then I want to render image upload like this. And for the moment, it can be as simple as that. I'll just forward an ID here, and that's the image ID. This ID will be picked up in the image upload component. For example, I bind it here to this input. If we now save that, and this reloads, and we go to Authenticate and switch to signup mode, we see our file picker here. Now, it would be nice if that would be centered. So back in the auth page, I will add this center prop to image upload. And now if we switch back to sign up, we see this is centered. Now that's nice, but of course, this doesn't look that great, seeing, well, no image at all. But what we can already see is if I click pick image, this file picker here opened up automatically, and I can select an image there. And thereafter, you see this log on the right, which logs this, well, this file picker element to the developer console. So this is generally working. Now we have to work on managing this file correctly, creating a preview, and getting it into our form here so that we can submit this in the end. So let's continue with our efforts to build an image upload component. We see that this console log fired when we picked a file. Now my idea is to manage the file here inside of the image upload component to create a preview, which we have in there, but to then also, of course, pass it to the surrounding form, which in the end needs the file to then eventually upload it to a backend. So whenever we need to manage something, which also should update the DOM, it's of course time for a use state. So here in image upload, we definitely need use state because we will have a file which we want to manage with file and set file, which initially is undefined, but which we will of course set at some point. I will also generate another state, the preview URL, and set preview URL, which in the end, well, is the URL of this image preview which we want to generate so that we can show a preview to the user. And last but not least, I'll also add isValid and setIsValid here and use this, and initially let's say it's not valid here by initializing this state to false. So 3 states which I'm managing here. And now with that in the picked handler, it's important to know that in the event target which I logged, which is this input element, you will have a files property that holds the files the user selected. This is default JavaScript. You get that files property on the event target if that event target is a native file picker, which this one here is. So we will have the files here, and therefore we can check if this exists, if it's not undefined. So to ensure that this does not somehow get fired without the user picking a file. And I also want to ensure that files length is not equal to 0. And of course, this should be an AND, a logical AND. So now we're ensuring that we have files, and that if we have files, we have more than one file. Actually, we could also check that it's exactly one file. There shouldn't really be a way to pick more than one here in this app, but if you would manage to do so, I certainly don't want to handle it because we only support the upload of one file at a time here. So we check whether we do have files and if it's exactly one, and if that is the case, we can continue here. Because if that is the case, I want to extract that picked file from event target files and get the first and only one, and then call set file and set it to my well-picked file, to the extracted file. I will also set isValid to true thereafter because we have a file, and then we can return to not execute any other code. Otherwise, if we don't make it into this if statement, we know we picked something wrong. Well, in this case, I want to set isValid to false here. And actually, we can remove the return statement here and instead do this in an else block, because then after the if statement, no matter into which branch we made it, we can call props on input here So I expect to get an onInput prop here on the image upload component, which should point at a function then, to which we forward the ID of this input, which we also receive through props, and this picked file if it exists. Now it does not always exist, of course, so actually let's set picked file here to be a variable and just assign a new value if we do have a file, and otherwise it will be still undefined, which is also fine here. And of course I also forward is valid. Now here it's just important to understand that when we call set is valid, it does not immediately update this state value. Instead it schedules this state update. So when I call onInput here and I forward is valid at this point, it will still be the old is valid value. So not the new one after this update. So actually here, I will add a new variable, file is valid, which I set equal to the current state of is valid. And then here I set is valid, but again, this does not update the state immediately. So in the meantime, I will set file is valid to true here manually and set it to false here. And then just forward file is valid here at this point. So we always basically call the function we receive on onInput, and we always pass our picked file, but that file might sometimes be undefined if we didn't pick a valid file, and we will forward the validity information. That's my idea here. Now, this doesn't help us with the preview though. Now, I want to generate a preview whenever we got a new file, so whenever we basically updated our file state. Now, doing something upon a state change, that screams for a use effect. So here we can add use effect and register a new use effect function. This function here should trigger or should execute whenever the file changes. So we'll pass file as a dependency. Whenever we picked a new file, I want to run my logic here because in this logic, in this function here, I want to generate a preview. So first of all, I'll check if file is not undefined because maybe file changed because it now is not a file anymore, but now undefined. In this scenario, I will return. Because if we don't have a file here, there is no need to continue. We can't generate a preview URL, an image preview anyways. Otherwise, if we make it past this if check, we know we have a file. And now we can generate a image preview URL with an API that's built into the browser, the file reader. So I'll create a new file reader here and store it in a file reader constant. And again, this is baked into the browser and therefore into browser-side JavaScript. The file reader, as the name suggests, helps us read files, helps us parse files. And we can use the file reader to convert a file, which is like a binary data, into a readable or outputable image URL, you could say. Now the file reader has a bit of a clunky API, and to work with it, we have to call file reader read as data URL. Now that's not too clunky, I guess. This is in the end the command to create a URL we can output, but the problem is this does not work with a callback, this does not give us a promise. Instead, before we call read as data URL on the file reader, we have to register the onLoad function like this and execute this function, this anonymous function, whenever the file reader loads a new file or is done parsing a file, we could say. So this function will execute once this reading of the file here is done. And then in here I want to call set preview URL, but then here we also don't get the parsed file as an argument. Instead we have to extract it from file reader.result. Yeah, that's just how this API works. With that, however, we are setting a preview URL, and with that, we can use this preview URL. So down here in JSX, on the image, I now want to output the preview URL here, however, only if we have one. So let's check if we have a preview URL and only output the image if that is the case. If that's not the case, if we don't have a preview URL, I will output a paragraph where I say, please pick an image. And in addition, I also want to output an error text, which can be provided from outside, so from the component that uses the image upload component, in case we picked something invalid, which should be pretty hard, but still. In this case, so if this is not valid, if isValid is false, I want to output props.error text here. With this, if we now save that and we switch to sign up here, I do have my image picker, and now I can pick this image, and here's my preview. It also crashed though. Props on input is not a function. And that makes a lot of sense, because remember that in the picked handler, I do call props on input. So I refer to the on input prop, and I expect to have a function in there which I can call. But at the moment when we use image upload in the auth component, here, I'm not setting this on input prop. So we need to do this. And there we now need to point at a function. And you might think that we now need to create a new function, but thankfully that's not the case. If we have a look at the on input arguments we're passing here, we see it's the ID, then the file that was picked, and then the validity of this file. Now, that is pretty similar to what we have in the input. In our input component for regular text input, we also in the end call on input at some point, and we forward the ID, the value, and whether that value is valid. Now that's exactly the same as we have here. Here I have the ID, the value, because the picked file is just the value of this control, if you will, and then the validity. So therefore, in auth, we can just bind this to input handler. So on input takes the input handler function. And in case you don't remember, the input handler function is coming from our custom form hook. Here it is. So we can manage our file, our picked image, with our form hook as well. Because the form hook, our custom form hook, does really not care about the data we're managing with it. It doesn't have to be text data. It can be a file as well. We should just make sure that whenever we switch modes, if we switch from sign up to login, we add an image key and set this to undefined. Because when we switch from login to sign up, we need to add an image key and set this to an object where the value, let's say, is null initially, not an empty string, because we're not working with strings here. Later, we'll store a file there after all. And isValid is set to false. And now this should be part of our general form validation and of our form data. Now to confirm this, in the auth submit handler, I will console log form state.inputs so that we can see whether our picked file is part of that or not. And with this, if we save all of that, switch to sign up again, and enter a valid name, valid email address, and a valid password, we see the sign up button still is not enabled. If I switch back to login, it is. But in sign up, it is not. Because the image hasn't been picked yet. Now, if I open that picker and close it, that's still not enough. But if I now pick an image here, like this one, you see this gets enabled. And if I click here, of course, we get an error because we already have a user with that email address. At least I here in my setup already have such an error. But from our log here in line 70, we see that we have the image and the value is indeed just such a file. And we can submit this file to the backend. This will be something we have to work on. This will be possible though. So picking the image works. Now, before we ensure that we also can pick an image when we create a new place, why don't we work on the backend and make sure that there we accept such a file? Thus far, we worked on the front end and we can pick a file there. Now let's move on to the backend and let's ensure that there we also accept such a file so that you can indeed attach it to a request, and here on the backend we then extract it and store it. Now for that, we'll add a third-party package which helps us with that, Multer. You can just Google for Multer. It's a Node.js middleware, and it's built for Express.js as well, so a Node Express.js middleware to be precise, that helps us work with multi-part form data. Now that's a specific type of request body we can submit to the backend. Thus far we used JSON data. Now we will actually switch to this different type of data for some requests. And the special thing about this type of data or this data format is that it can contain a mixture of normal text data and file data or binary data. Because JSON can only work with text data in the end. Of course, it can also include numbers, but ultimately that's all just text, right? You can print it. Now, binary data is different, and JSON format can't deal with binary data. Multi-part form data can, and I will show you how to adjust our requests we send to the backend to use this kind of data. But first of all, let's prepare the backend with this package to accept such data. So for this, we need to run npm install --save malter, and then here you can learn all about it, but of course I will also guide you through the steps you need to do to set up malter. So let's first of all install it on the backend, not on the front end, but on the backend. Let's run npm install --save malter. And this will now install this package into the backend. There, on the backend, I will now add a new folder, the middleware folder. You can name this folder however you want, but I create it because there I want to store my own custom middleware. And one middleware is the file-upload.js middleware. Of course, Malter already is a middleware that will help us, but I will basically configure it to my requirements and wrap it into my own middleware, which I then export. So how does this work? In the file-upload.js file, I will import Malter, first of all, like this. And with it imported, I will execute it as a function to which we can pass a configuration object. The result of this function is the actual file upload middleware Malter provides. And you find these same steps basically in the official Malter docs as well. So this is now a middleware which we could use in our Express middleware chain. Therefore, here in the end, I will export file upload. So I will export this middleware. And then we can adjust our configuration here in a global place and use that pre-configured exported middleware in any other file we want. For example, in the user routes. There we have the sign up route. And on the sign up route, we of course want to accept images to be uploaded. So here we can import our file upload middleware by requiring it from the middleware folder, file upload like this. And then here, on the post request, on the sign up request, before we run any other middleware, we can add file upload.single image. This is how you use the Malter middleware. The concrete middleware is actually the result of this single call, file upload. So the thing I'm exporting here is not yet the middleware. It's an object that has a bunch of pre-configured middlewares. For example, a middleware to retrieve a single file, which we get access to with the single method. And then we have to specify the name in the to be expected body of the incoming request that will hold the image or the file that should be extracted. And I here expect to have an image key on the incoming request, which should then hold the, image I want to extract. So this instructs Malter to extract that image or that file on that image key on the incoming request before we continue with the other steps. The question just is, what does Malter do with that extracted image? Of course, we want to store it somewhere. So here in the file upload.js file, we can configure Malter a little bit. We can configure it to tell it where to store something and also which files to accept. First of all, I want to set a little filter here, a limit for our files. We can set a limit in byte here, and I want to set this to 500,000 bytes to have an upload limit of 500 kilobytes. And of course, you can adjust this to your personal likings here. Malter also takes a storage key, and here we can control how data should get stored. Now, this storage key requires a Malter storage driver, and Malter has a built-in disk storage driver. So we can call Malter disk storage to generate such a driver, which we provide to storage. Now here we can set certain object properties on an object we provide to disk storage to configure that disk storage. And there we can specifically set a destination key to control the destination where files get stored, and also a file name key to control the file name that's being used. Now both take functions here. So we pass a function to each of these keys. The destination function here gets the request object, the file which was extracted, and a callback, which we have to call once we're done. The file name function here also gets the request object, also the file, and also a callback. Now let's maybe start with the file name. There, I first of all want to extract my extension of the incoming file. And for that, I will create a little helper constant up there, which I'll name MIME type map. This is a simple JavaScript object where I will map certain MIME types, which look like this, to certain file extensions. And I'll do this for image, PNG, and also for the two JPEG types we have. Why am I doing this? Because Malter gives us some information about the MIME type it found for the uploaded file. MIME types look like this and basically tell us which kind of file we're dealing with. So with this map, I can derive the right extension from the identified MIME type. So I can use my MIME type map here and dynamically access the property that matches my file.mime type. This is the file object Malter gives me, and there I have various fields. One of them is the MIME type Malter found. MIME type will look like this, and therefore then I extract the right extension here, because I dynamically access one of these properties here. These are valid properties in JavaScript. We just have to wrap them in quotes. I dynamically access one of these properties and get the extension that's mapped to it. So this gives me the extension I want to use. Then I want to call this callback, pass null as a first argument. We could throw an error here, pass in an error if something went wrong, but that shouldn't be the case here. And then the file name I want to use. And there I want to generate a unique ID, and for this we can reuse a package we installed earlier, the UUID package, and import v1 for example, and then call UUID to generate a random unique file name here, and then just add a dot and then the extension. So this generates a random file name with the right extension. This is passed as a second argument to callback, and this in the end is handled internally by Malter to then use this file name. Now in destination we do something similar for deriving the path where we want to store this. It's simpler though. I just have to call callback here. I got no error, so I'll pass null as a first argument, and then the string which describes the path where I want to store this. And here I want to go for uploads/images. And I will therefore create a new folder here, which I'll name uploads, and in there a new folder, images. And that is where I want to store my data, just like that. With all of that, the disk storage is configured. Now let's continue configuring Malter, because I also want to set up a so-called file filter, another property we can pass to the object we use to configure Malter. The disk storage is important for storing the file correctly, but of course we also want to validate that we don't get an invalid file. Of course we also have some validation on the front end already, because in my image upload component I already have this accept attribute set on the input, but you learned that on the front end everything can be hacked or simply changed by the user with the developer tools, for example. So we can't rely on front end validation. We don't do that for our other fields, and we shouldn't do it for our files. So on the backend I will add a file filter here. This is a function which receives a request object, the file, and then also a callback, which of course is the same pattern you already saw there. Now here we have to call this callback either with an error if validation failed as a first argument, or with null as a first argument if it succeeded. So therefore, first of all, I will add a constant isValid and then check in my MIME type map if I can find the file MIME type here. So this here will retrieve PNG, JPEG, or JPEG if I have one of these MIME types. If I have another MIME type, it won't find an entry here, and therefore it will return undefined. So now with the double bang operator in front of this, we convert undefined or null to false, and we convert one of these findings here to true. So now we have either true or false, however not here, but here of course. So now we have either true or false stored in isValid. Now next we can create our error here. And there I will basically check if isValid is true. And if that's the case, I will set this to null because then we have no error. But if isValid is false, so if we have some invalid upload, then I will set this to a new error where I say invalid MIME type, like this. And then we can forward our error, and the second argument is a boolean that basically informs Malter if we accept the file or not, and here I can forward is valid, because if that's true, we forward true, we accept the file, otherwise we don't. Though if you pass an error, and that is a real error, you already deny the file. So adding a wrong file should now not be possible. This is the finished configuration of Malter, and with that we should be prepared to accept and store files. With this, we can save this. We are applying this middleware to our signup route. Now we need to head back to the front end, and of course also restart our backend server, but then head back to the front end to make sure that we send the right type of data to that backend, to that signup route, and include a file in our HTTP request. So back to the front end. There we pick a file, and in the auth page, it's part of our form data as we confirmed. Now we need to attach to the outgoing request. And now we need to do something interesting here. We need to send different type of data. Thus far, we always send JSON data. Now sending JSON data still is correct if we're logging in, because then we only submit text data, email and password. And important, when I say text data, I mean all data which we in the end could write like this in JavaScript code. So including arrays and objects, anything we can read as a human. Now for images, that's different. Images are binary data. We can't write an image like this here, right? So therefore, we can't use JSON as a format. Instead, we want to use a better data format. And that would be form data. A format which is already built into the browser and into JavaScript, thankfully. We can create new form data like this. It's a browser API, so it's available just like this. We don't need to install any third-party package for this. And we can store this form data in a constant. Now to this form data object, we can append new data. And the cool thing is, on form data, you can add both normal text data, so things like the email, the name, or the password, but you can also add binary data, so files. So here I will append email. You first, as a first argument, need to specify an identifier. Then, as a second argument, the value for this identifier. So in this case, of course, form state inputs email values, what we have in JSON down there as well. Now we can replicate this 2 times to do the same for the name, and of course refer to form state inputs name.value, and then here the password, and refer to form state inputs password.value. This is the data we submitted before as well. So for this, we wouldn't need form data. But now we can add, or append to be precise, our image. And this should have a key of image, because on the back end, if you remember, I'm looking for this image key here with this line. I'm looking for a request body key named image, which includes my image. And we set up this request body key with this line in the end, because we'll append form data as our request body in just a second. So this has to be image here, but other than that, it's of course forms data inputs image.value, because we are managing this image file in our regular form state. So now we can fine-tune our request. Instead of sending JSON stringify data, so instead of just sending JSON data here, we just add our form data. And the cool thing about form data is that the fetch API, which we use under the hood in send request, automatically adds the right headers. So we don't need to set headers manually anymore. Instead, it should just work like this. And this should send a request with form data, which includes all our old data, but now also our image. Now back on the back end, our controller, our user's controller, and their create user might not fully work yet. We'll see if this extraction here still works now that we're not sending JSON data anymore. We're also not using the file here, by the way. We're storing it on disk, but then here we're not storing a pointer added in the database or anything like that. So I'll come back to this as well. But for the moment, let's just save this and see if this upload process in general works. save the frontend as well. And then go back to the React app, switch to Signup, and let's try creating a new user, pick an image, and of course also pick a URL. For now, this can also be a used one, and click Sign Up. Now we get user exists already, but if we go to the backend, we also see that it uploads images. We should have a new file. And this is the image which just was uploaded. So the upload works. You also see, of course, that this means that despite our validation failing, the file was saved. And the reason for that is that when the validation fails, that of course means that we in the end throw an error here in the user's controller. Here we're checking whether we have validation errors. Now, by the time we reach this code, of course, all our middleware is executed, so the file indeed was stored. So if we want to undo that storage, we'll have to roll it back manually. And in general, in the controller, we're not doing anything with the file. That will be the next step. But what we can see here already is that the general upload and using foreign data works. Now let's just make sure that we also do something with the file here in Signup. So, controller time. Let's work on the Signup controller and make sure we do something with the file. And do something with the file actually means two things. It means link the file to our user in the database, so create a real image URL, but also roll back the creation of the file if we have a validation error, for example. Now let's maybe start with the rollback mode. If we do have a validation error, so if we're in here, then I don't want to continue. I instead want to delete the file. The same, of course, is actually the case for any error I have here anywhere. So if I have an error here or anywhere else, this does not matter. So you could argue that it makes sense to integrate this rollback logic into our general error handler, maybe. So in app.js, we have this general error handling logic here, and there we can check if we do have a file, and if we do, we want to roll back because we had an error. We certainly don't want to keep it. Now the cool thing is Malter adds us a new property to the request object, a file property, if we do have a file. So we can check if this is set, and if this is set, we know there is a file as part of the request. So the request where something failed had a file. We now want to delete that file that was stored on the disk. To delete it, we can import a Node.js core module, and that is the FS, the file system module. Here, like this. This allows us to interact with files in our file system, and it allows us to, for example, delete files. So with this imported in our error handler here, we can call unlink. Well, this doesn't sound like a delete, but this is in the end what it does. It deletes this file. So here we then just have to point at the file. We can do so with request file path. Path is a property that exists on this file object, which Malter adds to the request, and this points to the file, and this will delete it. Now on unlink, provide a callback here, which will be triggered when the deletion is done. You get an error, which might be thrown if something goes wrong, but here I'll just log it. I don't care about an error here. If file deletion failed at this point, it is what it is, but we can always manually clean it up. It's not horrible if we still have the file around. With that, delete the file which is currently stored in images and save everything and try that submission again. So let's click on sign up here, and I get user exists already. Please log in instead. But if we now go back, we see nothing is in images, and that is great. So we correctly roll back this image upload. So that's one thing. Back to the user's controller, we can also use the file for something more useful, because rolling it back, of course, is nice. But more importantly, we want to store it on our user which we create. We are extracting our data here, and Malter will give us this body property on the request with all the text fields it found on the incoming request body. So we will still get that thanks to Malter. But in addition, we have this request file thing I showed you. And with all that information provided, we can add it all to our user. So now here, on the user we create down there, I want to replace this image field here with HTTP localhost 5000 / plus request.file.path, which should be uploads / images / file name. This is the image URL I want to construct here. Now, storing the full URL here certainly is one thing we can do, but we could also argue that we want to prepend this thing here on the front end, actually. So we could just store the file path here in our image field, not the full URL, just the path on our server. And with that, new users should have that path included. Now, to see that in action, I'll go back to MongoDB Atlas and actually delete all my users I got here so that I can start from scratch again and I don't have any existing users in the database. So let's delete all the users we created in here, step by step, every one of them. And whilst this is deleting, I'll also go to places and also delete all the places I created in the past. In my case, that's one place, so let's delete this as well. And with that, we should have no more places and no more users. We got 2 empty collections here. And we can now go back to the React app and leave the credentials here as we have them and click sign up. And this doesn't look too bad. Now, this image is not displayed here yet because we're storing just the path on the server, not the full URL. But if we have a look at our users collection here again, we see our user and we see the image path here. And now we just need to tweak the front end a little bit, and on the users page, or to be precise, inside of the users list, on a single user item, here on the avatar, what I pass here to image should of course include props image, but since this is just a path, I'll wrap this here into backticks and instead point at HTTP localhost 5000 / and then here dynamically inject props.image. And if we do so and save this and go back to the React app, it still doesn't work. And you see we got a not found error. Now the URL actually is correct though. It's localhost 5000 / uploads / images and then the image name. So why is it not shown here? Because we need to change more on the backend. We're still not seeing the image here despite using a correct URL, because there is something important you have to understand about the backend code, or the way NodeExpress here works and servers in general work. By default, none of the files on the server side, so in our NodeExpress app, are accessible from outside the server. And that's good, because otherwise we could just enter localhost 5000 / app.js and have a look at the source code there. But fortunately, this does not work, because every incoming request on the backend goes into our middleware funnel here in the end, and it goes through all the different middlewares here, and only the logic we have in the middlewares executes. So you can't request any file. You can just go through the middlewares, and you either have a request that's handled by one of the middlewares, or you don't. For example, if we send a request to a URL which ends with /API/ places, we make it into our places routes, and that's how the logic there kicks off. But for some random image link, we got no middleware that would handle this. Now, of course, however, we want to grant access to images. And to do so, we can add a new middleware. Maybe here, after parsing request bodies, we can add a new general middleware and then filter for requests that start with uploads images. So requests which have localhost 5000 / uploads / images at the beginning of their URL. Such requests will be handled by a special middleware which is actually built into Express. Express static. You can execute static as a method, and this will return a middleware actually. And this is a middleware which just returns the requested file. Static serving means that you just return a file. You don't execute it, you just return it. Now here we have to control which files in which folder we want to return. Express static then wants a path pointing at the folder from which you want to serve files without any extra check. Now, such a path has to be an absolute path, and we can build this with the path module, which is built into Node.js. So we import it with this syntax here and expose it on this path constant. And then here to static, we pass our build path where we join two segments, uploads and images. And this builds a new path pointing at the uploads images folder. And any file in there, if we request it, will be returned. Otherwise, all files are locked down, but files in this folder, if requested, are returned. If we save this, and now we go back and we reload our app here, we see our image therefore, because now we're statically serving it. And with this, the upload works and serving it works. Now, of course, we have no places for a user. So let's make sure when we logged in that we can actually also add a place here and that we have an image upload here as well. Now, this is a great practice for you because essentially the steps are the same for uploading an image for a user. So definitely try this on your own first. In the next lectures, we'll do it together. So let's implement image upload when we add a new place. For this on the front end, let's go to the new place component. And there we need to, first of all, import our image upload component. So image upload from shared components, form elements, image upload. Now we can add this to the form there. So here in our JSX code, maybe below the address here, we can add image upload. Now, of course, this now is an input which is always rendered. Unlike in the sign up form, we don't switch between different modes here. The ID can be image and should be image to map this to our form state later. And on input here is bound to our input handler. The error text which we can provide can be, please provide an image, though I didn't do that on the sign up form actually. So let me quickly go back there. And on the auth page, on image upload, I will add that same error text here. So here on image upload, I will also add this error text. This is in the auth page now. A little oversight back then, but normally this can't really be invalid. So back to new place, we got our image upload added there as well. Now let's add it to our form state. So here, when we initialize our form, I add the image key, so the ID we used in JSX as well, and set the value to null initially and is valid to false. This key here, of course, has to match the ID we have down there. So with that, we should have an image upload field there as well, and it should be part of the form data. If we now send a request, we of course need to send form data therefore. So let's add our form data here with new form data and append the different data pieces we have. So the title, for example, which of course is retrieved like this from our form state. And then we repeat this for the description like this. We repeat this for the address. And for the moment, we also need to add our creator here. We don't get the creator from the form state though, but from auth user ID. Once we have authentication, this will change, by the way. Now we need one more input, one more form data piece, and that is our image. And this has to be image because we will retrieve this by this image key later on the backend. Right now I haven't added logic to do so though. But for the moment, let's stick to the front end. Let's store the image here in the image key and of course refer to image here, therefore. So now here we can remove the body and the headers and just add form data to our request we're sending. So this should send a correctly configured request, but now we also need to work on the backend. For one, in the places routes, just as we did it in the users routes, we need to add this middleware here. So in places routes, let's add an import and import the file upload middleware from require middleware file upload. Or actually, as you learned, this is not already the middleware. It's an object with a bunch of middlewares, and we get the right middleware by, for example, calling single. So here on this post request, I will call file upload single and look for the image in a key in the body which is named image. So with that, we're extracting the image upon the creation of a new place as well. Now in the place controller, we have to handle it. We have the rollback logic in app.js in our global error handler, so that should already work. We don't need to add anything there. But in the places controller, I of course now also want to link the image to a newly created place. So in create place, we're extracting the other data from the request body, which is fine. But then here, when we create our place, the image is no longer a URL like this. Instead here, I will use request file path, just like this. This is now what gets stored in my newly created place. And now we just have to go back to the frontend again and make sure that we output or use the right URL there. So on place item, where I render the image of a place, I will wrap this here into backticks and then output localhost 5000 and then dynamically output props image in there, so that we use the path which is stored on the backend and connect this with our URL that points at the backend. With all of that, let's save it and let's give it a try. Let's log in here with the user we created and add a place, Marienplatz, a great place in Munich. The address, Marienplatz 1 in Munich, and pick an image. And here I prepared an image for me already, which is a picture of the Marienplatz. And now if you click add place, this loads. We're redirected, we got one place, and here it is. This is our image of the Marienplatz. Now if I edit this also looks really, really nice. Editing is reflected here. We can view it on a map, and we got our image here. And on the backend, unsurprisingly, if we go to images, then we see our user image, which we uploaded earlier, and that image I just chose. So upload is working here. And with that, we're able to upload images for both users as well as places. Now, last but not least, I want to make sure that when we delete the place, which I'll not do here, but in a second, that we also clean up the file that belongs to the place. And at the moment, we're not doing this. If we have a look at our places controller in delete place, we of course get rid of the place, we of course get rid of the connection to our user, but we're not getting rid of the image that belongs to the place. Now, we don't necessarily have to. We could also write a script which cleans up every month, or we do a manual cleanup, or we want to keep all the images because we're using them for some machine learning algorithms or anything like that anyways. But if you do want to clean it up, it's not too hard to do. Before we get rid of our place here, I'll get the image path here out of the place. In the place document, we can simply access this image key, right? Because that is where we do store our image path. So I get access to this image path, then I delete everything in the database, which is the important thing, because if deleting the image should fail for whatever reason, it's not that bad, it's okay, we can do a manual cleanup. So after all this database cleanup, I want to delete the place. Now for that, I will again import the file system package Node.js offers, because this gives us this unlink method. And with this imported, at the end here, at the end of delete place, we can call fs unlink and use our image path here, which I extracted from the document up there. So now this is what I want to delete. Unlink takes a second argument, a callback function, which might hold an error if things go wrong. Here I will just log it to the console. You could do more with it. I certainly don't want to wait for this to complete though. We could send the response in here to wait for this to complete, but I don't care. This deletion process is started, and as I said, if it should fail for whatever reason or something like that, it's not the end of the world. So with this added, if we now save this, and we go here to the front end, and I click delete and confirm this, it deletes it here. This looks good. We got no error here. And now if we go back to the backend, we see only one image, and that's our user image the place image indeed is gone. And if we quickly have a look at Atlas, we should also see that there the places collection is empty. And if we have a look at our users, we got the user, but the place key was deleted from its places array. So this is now the cleanup finished, and this ensures that when we delete something, when we delete the place, we also delete the image that belongs to the place. This is it for the file upload. Adding file upload has two sides. For one, we need to add it on the backend. Here we use the Malter package and the middleware it offers to us, configured for our needs. So we're configuring the place where it's stored, how the file name is named, and which files we accept. We do this with the help of the MIME type map. Then in the controllers, we simply extract the path, which Malter gives us automatically, and store that in a database. So not the file is stored, but just the path of the file, just a string. We don't want to store files in a database because that would bloat it, slow it down, and be a really bad practice. Store files on the file system, locally instead. Now, in case something goes wrong, we have app.js, where we roll back our file upload if the request where something went wrong has a file attached to it. So if some other request goes wrong, we don't roll it back, of course. And on the front end, we built this new image upload component, which allows us to pick an image and also show a preview. And we easily integrated this into our existing form hook and the form management we have in place already. And then the trick just was to use form data to submit the data to the backend so that we can have a mixture of text and binary data. And that is it. This is file upload added to a MERN app. What's missing in this application we built thus far? Of course, authentication and authorization. We got some dummy authentication implemented in the React part of the app already, but if we're honest, we're not really authenticating users there. We're just switching between different UI states, and that is all. We also got a dummy login route on the backend, but again, this route isn't doing anything useful thus far. Therefore, in this module, we will change this, and we will also not just work on authentication, which means logging users in, but we'll also work on authorization, which means that even if a user is logged in, we don't allow everything for that user. For example, you can't edit or delete places you didn't create. Therefore, in this module, we'll do one very simple thing. We'll add authentication logic on both ends, and that for me then also includes that we add authorization logic so that we control whether a specific user is allowed to do something or not. But let's start with authentication. Now, if we speak about authentication, let's have a look at our current implementation, because on the backend here, we got a login route, right? We can log in. We can send a request to the login route at least. But if we then have a look at our user's controller and there at the login function, we see that what we do in there is in the end very, very trivial. We check whether we find a user for the provided email address. And then if we don't find that user, or if the password of the user does not match the entered password, we return an error. Now, thus far, this logic isn't too wrong, though I'm not happy with storing the plain password like this, the plain text password like this in the database. We certainly want to change this. But still, even with that logic, what we return is not really helpful. I return a user object, and I return a message where I say logged in. This is not really anything that helps us on the front end. It's not a proof that this user is logged in, right? The server says so, okay, that is nice, but if we then in the future send requests from the front end to the backend, how exactly would we remind the server about the fact that the user in our front end is logged in? We get no data from the server which we could send back to the server to prove that the server in the past decided that we are logged in. So how would this normally work, and how should this work in a single page application REST API scenario? We have our React app and we got our backend server, and there we got certain routes or certain requests we accept. We use a HTTP client on the front end, like the Fetch API or like Axios, and we send requests to the backend. And some routes there should be protected, which means only authenticated users should have access, and other routes are open to everyone. Now, traditionally, and with that I mean a web application where we render HTML on the server with the help of templating engines, traditionally we would establish a session. We would create a session on the server. A session is a server-side idea, which we then store in the database there. And we would send the session ID to the frontend and there store it in a cookie. Now, this approach is generally nice, but if we're having a single page application and then a server-side API, these two ends are not as closely connected as they are in an application where the server-side renders the HTML code. To be precise, the API is stateless, which means it's totally decoupled from the front end. It doesn't want to remember sessions and to which front end a session belonged and so on. Instead, we'll use a different approach when we're working with a single page application on the front end and an API like a REST API on the back end. Instead of creating and storing such a session on the server, which we don't want because the server is stateless, we generate a token. This in the end is a string generated with a certain algorithm where certain pieces of data are encoded in. This token is returned to the frontend and there it can be stored in a cookie or in local storage. Now this token then can be attached by the frontend to requests that request protected resources. And now the interesting thing is, the server generates this token, as I said, with a certain algorithm and also by using a private key, which then is just a string that's fed into the algorithm, and the same key for the same data which is encoded will always yield the same token. A different key with the same data will yield a different token. So the server is the only one who knows this private key, which in the end led to this exact token, and therefore the server is able to validate the token which is attached to an incoming request. So on the front end, if you try to fake a token, if you would try to change anything there, you don't know the private key, so you will get a different token, and such a token would be identified as invalid by the server. And with this approach, we don't need to store any data on the server except for this private key, because we then on the server know which tokens make sense for this provided private key. And on the front end, we can use this token to attach it to requests where we need to identify ourselves as authenticated. That's the idea here. That is how authentication typically works in modern web applications, where we have a single page application and an API backend talk to each other. And this is the approach we will therefore also implement in this course. So back in our code, again, I got two windows, one for the backend and one for the front end. You can see it on the top left corner. And I want to start on the backend. There, I want to start by ensuring that we are generating such a token. But actually, I want to start one step earlier when a new user signs up, when we create a new user. Right now, we always store the password as plain text in the database. And thus far, this was okay because we had no real authentication anyways. But now I want to change that because we never ever should store passwords as plain text in the database. Why? Well, if our database gets compromised by an intruder or by an employee who isn't happy, so if someone gets access to our database and is able to extract data from there, if the password is stored in plain text, this attacker has everything, all the information it needs. If the password instead is encrypted, so if it's a string which can't be decomposed to the original password, then the attacker might still have the email and the name, which is bad enough, but at least the attacker doesn't have the valid password. So the data which can be extracted is less useful. Therefore, we don't want to store the password like this, but instead encrypt it, hash it before we store it. And for that, we can install a third-party library with npm install --safe. And the name of that library is bcrypt.js. This is a Node.js library that helps us create secure passwords, or not create passwords, but hash passwords, which means encrypt them, convert them to an unreadable string or to a string which can't be reverse engineered, to be precise. So with that installed, we can rerun npm start, and now in the user's controller, I want to import this library. So there I will import bcrypt by requiring bcrypt.js like this. This library now helps us with hashing passwords. So in the create user function, in the signup function here, therefore, we first of all still check if we have a user, that's fine. But if we come to the conclusion that we can create a new user, I don't want to create this password, but instead, as I said, such a hashed password. Now to generate this, we can call bcrypt, and then there we have a hash method. To the hash method, we pass in the password we want to hash, and that is the password we're extracting from the incoming request, so the plain text password. A little side note, by the way, of course, data between the frontend and the server should be exchanged via HTTPS, but that is something which you don't control here in this controller or on the frontend, but in the end, with the service you use for hosting your application. So I assume that this is the case in production. By the time we receive the password on the server side, we of course automatically unpack it back to plain text, but ideally it was transmitted via HTTPS. So once we got the password here, we pass it to hash, and then hash also takes a second argument, which is the so-called salt, or the number of salting rounds. Now here 12 is a good value, and this simply influences the strength of the hash and how easy or hard it is to reverse engineer it. And with 12 salting rounds, we should have a hash which can't be reverse engineered and which still doesn't take hours to generate. Now hash then returns a promise. So since we're already in an async function here, thanks to async in front of our function parameters, we can of course await this generation, and the result will be the hashed password here. Now of course, as always, this could fail. It shouldn't, but it could, so let's wrap it with try catch and catch any potential errors here. And if we got an error here, well then I will create a new HTTP error and say could not create user, please try again, and send back a 500 status code, because this then is some kind of technical server-side error. And then we can return this error with next here as we did it before. So normally we should make it past this try catch block though, and then we have a hashed password. Now when we create a new user, we set the password key, the password property of that user object, to that hashed password now. And we don't store the plain text password therefore, but the hashed password. Now with that we store this hashed password, but of course the next question is, how do we identify the user by the password then? Because comparing passwords like this won't work anymore. After all, in the database we won't have the plain text password, so we can't compare it to the password entered by the user. And if we did this, if we're sure that we have the right password, how do we generate this token? These are the next questions we have to take care of. So we're hashing the password. Now before we dive into the token creation, let's go to the login function and check how we now actually, with the password being a hash instead of plain text, can compare the password the user sends us, which of course in the end on the server is plain text, to the password in the database, which is not plain text. Now for this we can again use the bcrypt library, because there the idea is that the bcrypt library knows how it created the hashed password. If we provided a new password, a plain text password, it can find out if that password could have been used to create the hash that's stored in the database. So we will in the end not recreate the hash, but we will check if the hash we have for the password in plain text that is provided makes sense. So therefore in the login function, we will still check if we maybe don't have this user. So I will remove that second check here and just check for the user existence. And if we don't, we already return an error, because that means we couldn't find a user for the provided email address. If we do find a user though, then we can check the password. For this, I will add a new variable, isValidPassword, and by default set this to false maybe. And then here, I set isValidPassword equal to await bcrypt compare. Compare also returns a promise, and compare now takes the plain text password, which here is in the password constant. We're extracting this from the incoming request. So we compare the plain text password to the hashed password in the database, so to existing user.password. So this is now not the plain text password, but the hash. We compare that, and this returns a promise, which then in the end yields a boolean, which I stored in isValidPassword. Now, as always, and that's why I split this into a variable declaration and then usage, as always, we want to wrap this with try catch to catch any potential errors. Here we can just say new HTTP error, could not log you in. Please check your credentials and try again. However, this is a server-side error. This error will not be thrown if we have invalid credentials. This is just an error if something went wrong during the comparison. Instead, we will always get back a boolean, even if the comparison fails. Even if we can't confirm the password, we don't get an error. Instead, we just get false as a return value here. So therefore, thereafter, as a next check, I will check if isValidPassword is false with an exclamation mark at the beginning. Because if it is, then we can again return our invalid credentials error. Because here we know that the password is not correct. If we make it past this if check as well, we know the email address exists and the password is correct. So then we can generate the token. Now for that token, I mentioned that it would be a string in the end which we generate, which is generated with the help of a certain private key and a certain algorithm. And then we can encode data into that string. So we can, for example, encode the user ID that belongs to the token into that token. You won't be able to read it directly in the token, but you can then decode the token to find out which data is in there, for example. So to create such a token, we'll install another third-party package. And this package is called JSON Web Token. One word, and simply install it with npm install -- save. This is a package which allows us to generate such tokens with that private key. And therefore, here in user's controller, where I want to generate such a token, I will import it and store it in a JWT constant and import it with required JSON Web Token. Of course, you can name these constants here whatever you want. Let's restart the server with npm start thereafter, and now we can adjust our code. And I want to generate such a token both for sign up, because if a user is signed up, I know that this is a valid user because, well, we just created the user. So we can also create a token there. And of course, I also want to generate a token for login. So let's start with sign up. Here, we're storing a user in the database, so thereafter we know this is a valid user. And now we can generate such a token. And it's thereafter actually the token and maybe some user data which I want to return instead of the entire user object, because not all user data is directly required in the front end here. But that of course depends on the application you're building and your exact requirements. So here I will add a token variable, and then to create it, we can call JWT, so this package I just added, sign. The sign method here returns a string in the end, and this string will be the token. So we can actually say token equals JWT sign, and then it takes some arguments, some inputs. The first argument here is the payload of the token, so the data you want to encode into the token. And this can be a string, an object, or a buffer. Now here I will encode an object, and the entire serialization and encoding logic will be handled by this package. So here we have a vanilla JavaScript object, and there I want to encode the user ID into the token so that we know which user this token belongs to. And for that I will use my created user.id ID is a getter provided by Mongoose on every created user document object we're working with, and this is the ID MongoDB will have generated for this user. And maybe we also want to encode the email address, but it's up to you which data you want to store here. I just chose some examples. So here I'm encoding the user ID, which is very important in my case, and the email into the token. The next argument here is this private key. So this simply is a string which only the server knows, so which you never ever share with any client. It's only in your server-side code. And here I will name this super secret don't share. And of course you can enter any string you want here. The last argument is optional, and here you can configure the token with a JavaScript object where you can set up certain options. For example, you can set a token expiration with expires in, and this accepts terms like 1 hour like this. You can check out the official docs of JSON Web Token to find all information about all config options here and about all the time strings you can pass to expires in. Now, letting the token expire is actually a really recommended practice because the token we send back can't be faked or edited by the client, because whenever you would do so, since you don't know the private key, you would generate an invalid token. So even if you decode it on the front end and you tweak the user ID and try to recreate the token, you won't be able to replicate this token because you don't know the private key on the client. So that is how we secure the token. But if you steal this exact token we're generating here, if someone gets access to your token, then this token is enough to fake that this person is you, because this token is accepted by the server as your identity, so to say. It's accepted as your I am logged in proof. Now, stealing that token on the client is a different thing. It's not that easy, and I will talk about this when we actually store it on the client. So it's not that easy to steal that token. Still, as an extra security mechanism, it is recommended that you let this token expire, for example, in an hour, so that even if it would be stolen, there only is a very short time duration during which attackers could do something with it. Now, this token creation also could fail, so I will wrap it with try catch here. It doesn't return a promise, but it still could fail. So here, try catch. And if it does fail, I will just return my signing up failed error here. If it does not fail, however, we do have a token, and therefore now I can return this as part of the data I want to send back. Now, the data I want to send back totally is up to you. Here, for this user sign up process, I will send back the ID of the user that was created, which I get from created user ID, the email maybe, which is created user.email, and very important, this token. These are the 3 pieces of data I want to return here, but again, it's typically up to you what you want to return to your frontend in the application you're building. Now that was the sign up process. Let's repeat this for the login, and of course feel free to pause the video at this point and try this on your own. After a short pause, which I give you to pause the video, we'll do it together. So, were you successful? Of course, it shouldn't be too hard. We can just copy this token creation code here and go to the login process here. And once we validated that we do have a user for this email address, and once we also validated that the password is correct, so right before we send the response, we want to generate this token. Now, important, use the same private key as above. If you use a different one, you will generate different tokens, and therefore when the client later sends a token with a request, you wouldn't be able to validate them correctly on the server. And here this should be logging in, I guess. So make sure that you use the same key here in login as you did in sign up. I will also use the same expiration date, of course. In general, I want to have the same configuration for my token. Just the data I encode is generally the same, but here in login, I don't have the created user. Instead, we have the existing user here. So I get my ID, which I want to encode from existing user ID, and the email from existing user email. Other than that, it's the same logic, just the error message changes to logging in failed. And then here, As a response, I don't return a message, I don't return the user object. Instead, I return the user ID, which I get from existing user ID, maybe also the email, which we get from existing user email, and very important, of course, the token, which we just generated. And with that data, the client, so in our case, the React application, will be able to use and store this token and attach it to future requests to routes on the backend that require authentication. And that is actually the next step. We are generating this token, but thus far it's totally useless. Thus far on the client we could store it or we could not store it, because besides this token generation, we haven't added any logic to the backend that would protect certain routes from unauthenticated access. Right now you still can send any request to any route here. We're not blocking this. So as a next step, we want to make sure that certain routes, like creating a new place or patching or deleting it, are only accessible if the request has a token attached to it, and this token also is validated by the server, and we can confirm that it was created with this private key. So as a next step, we'll implement this route protection on the backend. So we got certain routes on our backend, to be precise, the route for creating a new place, for updating a place, and for deleting a place, which should be protected, which means you shouldn't be able to send a request to them if you're not authenticated, if you don't have a valid token. Now, how can we ensure that no request without a token, or without a valid token, I should say, can reach these free routes? Well, we can add a middleware in front of them. We can add a middleware in front of them, which ensures that requests have to have a token. If we use router use here, we can add a middleware to any request that reaches this middleware. Now keep in mind that requests in the end travel through your middleware from top to bottom in your files. And if we add a middleware here, we therefore ensure that these first two requests here are open to everyone. And that actually should be fine here. I'm fine with returning place data to everyone. But then, once a request didn't make it into this or this route, it encounters this middleware. And here we can then do something to, for example, send back an error response if the request has no valid token. So a request without a valid token will never reach the bottom routes here, because it will always be handled by this middleware. That is the plan. So we need to write a middleware here which checks an incoming request for a valid token. And if the token is invalid, it will send back a response and it will block the request from continuing its journey to the other routes. This is how we could protect these bottom three routes here. So the only missing piece at this point is a middleware that helps us do that. And for that, I will create a new file in the middleware folder, which I'll just name off, or check-off.js. And in here, we'll write all the logic to validate an incoming request for its token. So in the end here, I want to export a function, right? Because a middleware is a function, as you learned, a function which gets this request object, this response object, and this next function here. And then here, we want to check whether we have a token, and not just whether we have a token, but if it's a valid token. So first of all, we can extract our token from the incoming request. And now the question is, where do we expect this token on the incoming request? You could argue that it should be part of the request body, but you might not always be protecting routes that have a request body. For example, the delete request doesn't have a request body, so the token couldn't be part of the request body here. Any GET request wouldn't have a request body. We're not protecting a GET request in this application, but in other applications you might be protecting such routes as well. So the request body is not a great choice. You could go for query params instead. Query params are these things in the URL which come after a question mark, something like token equals, and then your token. That could be part of the URL, and that would be a valid way of sending a token. But I personally am a friend of using headers. This does not affect our URL and therefore keeps it cleaner, and a token really can be considered metadata that is attached to a request. So I really like the idea of encoding the token in the headers of the incoming request. So we can access the request object, and there we will find a headers property. This is automatically provided by Express.js. This is in the end a JavaScript object where we got key value pairs, where the keys are the headers and the values, well, are the values for these headers. And there we will find an authorization header. Now remember that earlier in the course, in app.js, when we worked on the course headers, I allowed the attachment of an authorization header. Now here with a capital A, but headers are actually case insensitive. So here we're allowing the frontend, the client, to add an authorization header. And now I'm using this authorization header here, again, they're not case sensitive, to extract data. So I access this authorization header, and in there I expect to get my token. However, this header will not be authorization and then the token. Instead, the convention is to have as a value something like bearer token to indicate that this request basically bears such a token here. So the token here is part of the string which is stored in the authorization header. So we want to split the value in the authorization header on the white space, on the blank. So basically here on this white space. And as a result, we will get an array with two values. The first value, the first element will be this bearer string. The second element will be our token. So on the result of this split operation, I can access the second element with index 1 because indexes in JavaScript start at 0 in arrays. So this should be our token. Now, of course, that token might not be found or it might be invalid. So if we don't have this token, if it's undefined, if this fails, then I, of course, don't want to continue. Instead, we know that we certainly have no valid request at this point. So here we can create a new error, a new HTTP error, and for that I will import my HTTP error by requiring it from models HTTP error. And there, as a message, we could say authentication failed. You can, of course, also provide a more detailed message and send back a status code of 401 for not authenticated, basically. And then here, I call next and attach my error. And I also return this to ensure that no code thereafter executes. Now, the problem we also have here at this point, by the way, is that when we split this, if the authorization header is not set at all, this would actually crash and generate an error instead of just returning undefined for the token. So we should actually also wrap this with try catch here to catch any error we might be having here. So this should go into try, and then actually we can send this error in catch. And here, where I check for the token existence, I just want to throw an error. I just want to throw a new error where I say authentication failed, but that doesn't matter too much because in the catch block I generate a new error anyways. So with that, we're handling two scenarios. Scenario 1 is that the authorization header isn't set at all and therefore split fails. And scenario 2 is that it succeeds, but whatever we had in there doesn't give us such a token. Now, if we survive both cases, so we do have a token, the token still might be invalid. So as a next step, we need to verify the token. And for this, we can reuse this JSON Web Token package. So I'll import it here, JSON Web Token, and store it in the JWT constant. Because this was the package we used to generate the token, it's also the package we can use to verify a token. So for this, we can call JWT verify. Now to verify, we pass our token, and then as a second argument, the private key we used to generate the token. So we have to use the exact same key we used in the user's controller to generate our tokens. So make sure to copy it from there and not introduce any typos. Because of course you can only verify the token's validity if you use the exact same private key. Now this verify process will not return a boolean. Instead it returns a string or an object. It returns the payload that was encoded into the token. So here we got our decoded token. And from that payload, we can therefore also get the user ID to which this token belongs. Because remember that when we created the token, we stored the user ID and the email in the token. So when we call verify, in decoded token, we got an object which has this user ID and which has this email. And now here, we know at this point that if this didn't fail, if this verification didn't fail, didn't throw an error, that the user is authenticated. So at this point, I also want to call next here and not add an error, but instead allow the request to continue its journey so that it is able to reach any other routes thereafter that require authentication. But I also want to add something to the request object. I will add a user data property. You can always dynamically add data to the request object like this. And the user data I want to add to the request includes my user ID, let's say, which I get from the decoded token and their user ID. Because again, when we create the token, we added a user ID to its payload. So now every request thereafter will be able to use this user data object, which is part of the request object, and get that user ID we extracted in this middleware. So we're doing two things here. We're validating the token, and once it is valid, we let the request continue and we add data to the request. Now, if verification fails, this will throw an error and therefore will make it into the catch block. This, therefore, is the finished authentication middleware. And now my app crashed after saving because in places routes I have this empty middleware. But this here will now not stay empty. Instead, here we can now use this finished middleware. So back here in places routes, let's import check off by requiring middleware check off. So the middleware function we're exporting there. And here in use, I just point at check off. I don't execute it because this already is the middleware function. Instead, I just pass a pointer at this function to use so that this function gets registered by Express as a middleware. And now with that, any route after this check here, so all these routes at the bottom are protected and can only be reached with a valid token. I can already prove this. If we go back to the front end and we try to authenticate here, for one, you see that this fails. We could not log in because we created this user here earlier in the course, and therefore it has its plain text password stored in the database, which can't be compared with the new bcrypt hash algorithm. But for example, if I create a new user here, pick an image like this here, and then unused email address, now we sign up. But we're not redirected. The reason for that is that we changed the data we're returning on sign up. We're no longer returning a user object, which is what we expect on the front end though. And therefore login here in the end failed when we try to extract the ID from the user object on the response, which is no longer there. But since we don't do anything in the error handler, we didn't see an error for that. Now that's not a problem because this is an error we will have to fix as a developer anyways. Our return data changes, and in general, how we work with this authenticated user changed. Nonetheless, important is that you won't be able to send requests to the backend, to the protected routes now without a token. And whilst I can't show this here in the front end, we can of course use Postman for this. Here on Postman, I created a request to create a new place with some dummy data. And if I click send here, you see I get back a 401 error here, authentication failed. So this proves that this request doesn't even reach our protected route. It's blocked earlier by our brand new middleware. And that is exactly what should be happening. So now with that, let's work on the front and make sure we use that new return data, that token and that user ID which is returned. And we then kind of store it on the front end and also attach it to requests we send to the backend to ensure that we have access to the protected routes again. So let's make sure our app works again. And for that here, I'm back on the front end now. I first of all need to use that new data the backend returns for logging in or for signing up. In both cases, we return an object which has a user ID field, which has an email field, and which has this very important token field. So here to auth log in, thus far, I passed my user ID. Now, of course, I can still pass this. It just now lives in the user ID field instead of the nested user object. So we can simply change this to user ID and it should generally work again. But with that, we're not taking advantage of the token. Still, with that, if we try to authenticate with that new user, which was created after we changed our password hashing logic on the backend, if we click login here, we are redirected. So this now at least works again. We're not crashing our app anymore. Nonetheless, this is not all. I also, of course, now want to use the token we are getting back from the backend. So to log in, I will also forward response data.token, both here for our login mode logic as well as for our sign up logic. And in app.js, where I have this login function, I therefore now no longer just expect the user ID, but I also expect the token as a second argument. Now, of course, I want to manage my token here in state, and actually instead of is logged in, I will store token as a state here and set token, and therefore call set token here and set this to the token I'm getting as an argument. And on logout, we can set this back to null. And therefore here, where I check for is logged in, I can simply check if token, because if token is null, I'm not logged in. If it's something truthy, like a string, which it is, then we'll make it in here. Else, we'll make it into here. And then here at the bottom, where I set is logged in on my context object, I can set this to token with a double bang in front of it as well, and therefore this will be converted to true if it is truthy, so if it is a string, if it is a token, and to false if it's falsy, so if it's null or something like this. In addition, in my context, I also want to store the token itself though, so this is just a convenience property here, which gives us a quick answer to the question whether we are logged in or not. I want to store the token itself as well though, because later when we send requests from certain places in the app, we will need that token. Now, to be consistent, I will therefore also go to the context, to the auth context file, and here in our setup also add the token as a field to the default value. We never really use that default value, but it's better for auto completion if we reflect the actual values we'll have in the context in the end here as well. So now we're storing the token in the context, and we're storing the answer to the question whether we're logged in the context, just as before, just with a different logic. Now we can utilize this token to attach it to outgoing requests. So for example, when we create a new place, so in the new place.js file, we're sending a request, and this is a request which needs a token, because on the backend, in the places routes, we are protecting all routes below this middleware here, and that, for example, includes the create a place route here. So we need to add our token. And if you check our middleware logic on the backend, you see the token has to be part of this authorization header. So here, when we create this request, when we send it, in the end, the send request function here we have from our custom HTTP hook takes a headers argument. So here I want to add my headers, which is an object of key value pairs, and I want to add the authorization header here and set this to, important, what I expect on the backend, bearer, and then my token. And this bearer thing is really just a convention to identify this kind of authentication, basically. So I'll set this to bearer, white space, and then my token. And we get that token from the auth context, to which we already have access here. So auth.token. This header now needs to be attached to the request, and we should be able to create new places thereafter. So if I save this, and I log in again, and make sure you use the right email address, which you used to create a new user after you changed your sign up logic and hashed the password. If we now go to new place, Marienplatz, still a nice place in Munich, Marienplatz 1 in München, and we pick our image. If I click add place, we're getting an error. And we're getting an unauthorized 401 error. Now we're getting this error for an options request though. And such an options request, if we inspect the network tab, is indeed sent. You see that when I try to create a new place here, it sends a request, but please note that the type here is options and not post. But we clearly are sending a post request here. Well, that's just a browser behavior. For certain HTTP verbs, basically anything but GET requests, the browser automatically sends an options request before it sends the actual request you want to send to find out whether the server will permit this to be sent request, so to say, if the server supports the to be sent request. This is just a convention, this is just something the browser does, and we just have to be aware of it. And we have to handle it. This options request has no token attached, and it doesn't need to. So in checkoff in our backend middleware, before we try creating the token or getting the token, I want to check if the request method is equal to options, and if it is equal, I will return next and allow this request to continue. This will not allow the post request to continue, just this options request. So this is a required adjustment to ensure that our options request is not blocked. The actual post request, which then triggers our place creation logic, will still be validated. So with this change on the backend, now if we try this again, this looks way better, and we created a new place here. Now what you'll notice, of course, is that if I try to delete this place, we fail because authentication failed. And that makes sense because we're not yet attaching the token to this request. The same is the case if you click this update button here. So we need to attach the token to these two requests as well. This definitely is a great practice for you, so feel free to try this out on your own before we'll do it together in the next lecture. So let's make sure we also use our token on update and delete requests, because these are the two remaining routes which are protected. So for that, let's maybe start with update place. There we have our HTTP request here, and there we already are attaching a header, but of course we can attach more than one header. We can also add authorization here, and now we need access to our auth object, our auth context. Conveniently, we already got access here, so we can just tap into this existing auth object here and get our token from there. However, remember, what we added to authorization is not just a token, but actually bearer plus token, just a convention we're following here. With that, we're adding the token here, and this should be all for now. Now let's also do this on place item.js, where we have our delete functionality. Here we send the delete request, and at the moment all I do here is set up the URL and then add my method here. Now we certainly need no body, so we can pass null here, but we want to add our headers object. And there we want to set authorization to bearer plus auth token. And we already got access to the auth context object already in this file here. So with that, the token is added to all these requests, and hence we can give that a try and quickly authenticate here with the right user. We will later, of course, also add a functionality to stay logged in. And now if I click edit here and I click update, this works. And if I click delete, this also works. So we are able to update and delete places. We are adding the token there, but we still got missing functionality. For example, we still can delete and update places that don't belong to us. We're having some security mechanisms here on the front end. For example, we only show the buttons if we're the right user, but we could use Postman to delete places which don't belong to us because we have no server-side protection against that. And addition to that issue, on the front end, we have the problem that whenever we reload, we are logged out again, which of course is also not great. So there still is room for improvement. So let's improve our application a little bit, and for that I will start in MongoDB actually, and I just want to make sure that I delete my user, which I created before we hashed the password and which therefore still has a plain text password stored. This user here. I will just delete it to have a cleaner database. The other user, as you can see, has a hashed password stored. Here it is. So that's just a tiny fix, however. With that fix, I will log in with that remaining user I have and create a new place again. So the good old place we already know, Marienplatz in München, which is still a very nice place, at least for tourists. The address is Marienplatz 1 for me here, and I will reuse that image I used before. Click Add Place and it will of course work. Now we can also edit and delete this as you learned, as you saw before. And that's all nice, but anyone can do that. Here in our app, only we see these buttons. If we would log in with a different user, they would be gone, because on the front end we have this check when we render these buttons, where we check whether the logged in user ID equals the creator ID of our places. We have no such check on the backend though. There, in places controller, when we delete a place, I find a place, I populate its creator, and then I just go ahead and I try to delete it. Now, this might fail because I'm trying to also remove that place from the array of places mapped to its creator, but this is not guaranteed. Most likely this will succeed. And for updating, here, update place, we're also not checking whether that place really belongs to the user who sent the request. We're just finding the place, we're editing it, and we're saving it back. So we have no checks on the backend to ensure that only the user who created a place is able to change it. I want to add such functionality though. And just to again highlight the problem, if I go to Atlas, to my places, and pick the ID of a place which is stored here, the place I just created, and I then go to Postman and send a patch request to this place, and there I need to add the authorization header here as well, and set this to bearer and then a token. And now I need a token of a user who did not create that place. So for that, back on the front end, I will log out and create a brand new user, manual, who surprisingly looks like me, because I only have that image here. And now there I'll of course use a different email address, create that user, and now I have manual as well. And manual did not create my place, so here in the app he doesn't see the buttons. But of course I can use manual now to still edit the place here. For that I will just log manual in here with Postman. So send my test@test.com and the right password data to the login route. I get back a valid token because this login of course succeeded. And I can use this token now here on the patch request as my token I add here to bearer. And now send a request to that place I created on the other user, so not on manual but on Max, to change it. Marienplatz, and add multiple exclamation marks. A great place. If I do that and I hit send, this succeeds. It edited this. And therefore on the app, when I reload here, we see these changes. Now that's exactly what I don't want. So let's ensure this won't work anymore. And for that, on the backend, let's add some extra security. And let's start with updating. Here in update place, the goal is to ensure that we only continue if the user who's sending the request is the user who created the place. Now the good thing is in the check-off middleware, we are extracting user data, and I'm storing the user ID here, which is part of the token. So that gives us the user ID of the user who sent the request. And this also can't be faked or anything by the client because it's part of the token. And if you would change data in the token, you would generate a new token which wouldn't be verifiable anymore with this private key. So it's 100% unfaked data. So we have that user ID stored in the user data object on our request, and therefore here in update place, once we made it through the general validation, we're looking for a place here, and a place has a creator field, of course, this one, and this will be the ID of a user. So then here we can just check if place.creator is not equal to request user data.user ID. If that's the case, we know they're not equal, and therefore we know, well, this user did not create this place. And in that case, I want to return an error, of course. You are not allowed to edit this place. And this now actually is a 401 error, because 401, which I used before, actually is an authorization error. I'll switch the other error codes in a second. And we send back this error if we determine that this user is not allowed to edit this place. And only if we make it past this check, so if the place was created by the right user, we allow this change. So now if I save this backend and I try this same update request again with the same token, which still is valid here because it has been less than an hour that I got it, I get this error here, not authorized. Now, on the front end, we can check the opposite. If I log in with the user who did create that place, who should be able to edit it, I see that button, but now if I remove all the exclamation marks, I also get this error. So why is this not working? This of course should be working, right? This is the correct user, this is the right user. Now this is not working because of the exact check we're running here. What's inside of creator? It's not a string that will equal this user ID here. Instead, it's an object of type Mongoose object ID, this special ID type Mongoose knows. So we have to convert it to a string by simply calling toString here, which is a method that will be available that will convert this to a string. And then this comparison here should succeed. So if we change this on the backend and we reload, now if I remove the exclamation marks here and I click update place, this succeeds. So now the user who created this is able to edit it, whilst the user who did not create it here, if we test it again in Postman, still gets an error. So this is now added authorization. Now feel free to also add this on your own to delete. I'll do it in the next lecture, and thereafter I'll also make sure that we use different HTTP status codes, which is just a minor thing, but still, to reflect the right kind of authentication error we're having, whether we're really not authenticated or maybe we are authenticated but we're not authorized. So let's ensure that only authorized users can delete a place. Now, here we again extract our place and we populate the creator. That's important. Creator is now not just an ID here, as it is here in update place, where I just find the place and I don't populate creator. Instead, with populate creator, the creator field holds the full user object. That's important to keep in mind here. Now, still here we find a place, and if we don't find a place, we throw an error. But if we did find a place, I want to check if the place was really created by the user who sent the request. So here we can check if place.creator.id, and again keep in mind that creator here is the full user object, which is why I access ID like this here, if that is not equal to request user data.userid. So a similar check as we have it up here in the update place route. Now important here, you don't need to call toString because this ID getter here already gives us the ID as a string, and therefore the check should be good like this. If we have a problem here, we can basically use the same error we used up there. So copy that down and return this error where we say you are not allowed to delete this place in this case here. So now if we save this, let's give it a quick try. Let's try to delete a place by here switching patch to delete in Postman. The URL is right and the headers are right. And now if I send this, I get you are not allowed to delete this place. On the other hand, on the front end, with the right user here, if I click delete and I confirm this, it should succeed, and it does. So this here is now working, and we got authorization added. Now as a last step, as a little bonus actually, I'll fix some status codes. Thus far I always used 401, and to be honest, in the end it's up to you what you use here. It's not that strict. But if you want to be very correct here, then 401 means unauthorized, which means you might be authenticated, but you're still not allowed to do this operation, to perform this operation. We have 403, which means this is forbidden in general, which you could translate with you're not authenticated. So here I want to search for my 401 cases and check if they are all correct. So this is my user ID comparison and this is, so here they are correct. In the user's controller, on the other hand, if I have 401, then here we have invalid credentials, so 403 makes more sense there. And then check off, it's the same. If we fail because we have no valid token, I would say it's rather a 403 error. But ultimately it's up to you, and it's not the end of the world if you use 401 instead of 403 or vice versa. The important thing is that we have this logic added here. So we got authorization added, we got authentication added. Our app is really working quite well. If there wouldn't be one issue, whenever I log in and I reload, I'm logged out again. And this is really not that great. It would be nicer if we could stay authenticated so that if we reload, we already are in the authenticated state again. At least if our token is still valid. It expires after 1 hour, so we'll have to relog in thereafter anyways. But for that hour, if we reload the page, we should keep our authentication status. And that implies one important thing. Storing it on the front end, just in context, isn't enough. Because where is data stored that you store in your React context? Well, in the end, just in memory. It's stored in a variable in JavaScript in the end. It's stored in memory, and whenever you reload the page, in the end, the entire React app restarts, you could say. A page reload is like your React app restarting or starting it for the first time. And that in turn means that any memory allocated to your old React app is basically lost. So the token stored in memory is lost when you reload the page. So to have it survive page reloads, we have to store it somewhere else than in memory. And that is what we'll do now. To store the token somewhere else in memory, in app.js, when we do log in and we set the token therefore, I want to store it in a more permanent storage as well. And the browser got a couple of storage mechanisms. We can find them in the browser DevTools here actually if we go to the application area. There you find things like local storage, session storage, IndexedDB, and cookies. Now IndexedDB is a quite complex database which we don't want to use for such simple data as a token. Session storage is a bad storage because it's cleared whenever you close the browser. Local storage is great because there you can easily add and remove and manage data from JavaScript, and it survives browser restarts and page reloads. And cookies are also great, but not as easy to use from inside JavaScript. So we will use local storage to store the token. And now here is one important note. Some people are concerned about the security of local storage because you can easily write to it and read from it with JavaScript, which actually is the advantage we want to use here. It has an easy to use API. Cookies could be locked down to be not accessible from inside JavaScript, and instead we could set them with the help of some server-side headers. Now this adds extra complexity on the server side, but the most important problem with that is you have some fake security. The problem some people have with local storage is that because it's easy to access with JavaScript, if people get access to your page through a cross-site scripting attack, they can also read and write to your storage and they can steal the tokens. Now here's the error many people who have this thought process make. It's true, if your React application here is vulnerable to cross-site scripting attacks, people can steal the tokens of your users. But here's my point. If your app is vulnerable to cross-site scripting attacks, you have different problems anyways, because the attackers can send HTTP requests to the backend on your behalf, and they could attach any cookies that the users of your app have anyways, so they can still get fake access to your backend even without stealing the token explicitly. So in general, of course, you have to build an app that does not expose cross-site scripting attack vulnerabilities, and our app here, for example, should be pretty secure. Also because React by default sanitizes anything you output and you render to the screen. So all the user-generated content we're storing in the database, when we output it on the screen with the help of React, then it's sanitized by React. So we have built-in cross-site scripting attack protection here. And unless we do something non-React-ish, we should be pretty safe therefore. So this shouldn't be a problem for us, and therefore we will use local storage to store our token. That means here, when we log in and we get the token, we can access local storage like this. This is a globally available object in JavaScript. It's a global JavaScript browser API. And we can add a new entry with set item. And here the entry I want to create is actually called user data. So not just token, but user data. And in there, I will store a stringified, a JSON stringified object. Because to local storage, you can only write text or data that can be converted to text, like numbers. Objects cannot be stored, but with JSON stringify, of course, you can turn an object into text, because JSON in the end is just text, which looks like an object. So that is a way of storing an object in local storage. And here I want to include my user ID, so that UID I'm getting on a user ID key, and that token. I will store both in local storage with this command. If I now save this, and I do log in here, this succeeds. But if I now have a look at my application area, you see that there, in local storage, you have that user data entry, and that's the value for it. And that is JSON data. It looks like an object, but it's really just text. But with JSON stringify and also another method on that JSON object, we can convert it back and forth to and from JavaScript objects. So now we got our data stored here. Now that alone, of course, doesn't log us in automatically when we reload. But now we can use that stored data to log the user in when he reloads. So let's do that as a next step. So we got the token stored in local storage. Now let's use it to automatically log a user in. And for that, we basically want to run some logic whenever our React app starts. When it starts, we want to check whether the user is logged in. Now the app.js file, the app component, is basically the first component that gets rendered when the app starts. Here in index.js, I render this app component as my root component. So any logic we run in here will run when the app, well, is starting up. So if we want to run some logic here whenever this component renders for the first time, we can use useEffect in the app component. So here I will add useEffect and add a function to it that should check local storage for a token. Now the dependencies of this function will be an empty array, which means this function here will only run once when the component mounts, when it rendered for the first time. And that's, by the way, important. useEffect always runs after the render cycle. I explained this earlier in the course already. It's just important to keep in mind. React will already render this component, but of course in the unauthenticated state by default then, and thereafter run this useEffect function for the first time. This is just how React works. You could theoretically manage a state which basically is something like is checking off, and unless this effect finished, this will be true, and you render some splash screen or some fallback page until checking off is done. Here, however, I will keep it simpler and just go to useEffect and in there check our local storage. So in local storage, I can get an item and get it by that key I used to store it. So in my case, that's user data, because that is what we use to store the data. And what we extract will be text. Now we know that it's text which can be converted to a JavaScript object because it will be JSON text, or text which is using the JSON format. Thankfully in JavaScript, we got this JSON object, which does not just have a stringify method to convert objects to JSON, but also a parse method to convert JSON strings back to regular JavaScript data structures like objects. So here I then got my stored data, which I extract from local storage. And this stored data will be such an object with a user ID and a token. So now we can check if we got stored data, so if this is not undefined, so put in other words, if we did find something there. And if we do have stored data, we can check if stored data.token is a thing. If that is a thing, we know we have a token, and therefore we could log the user in. So we could execute our login function here then, and forward stored data.userid and stored data.token. These are the two pieces we need here, and we then trigger our login logic. Now actually useEffect has a dependency, and that is our login function, but thanks to useCallback, this will only run once, and it will not rerun thereafter. And now here we just need to switch order and make sure we execute useEffect after these functions have been defined. So now here we ensure that login is executed with our data, with our user ID, and with the token if we got a token. So if we now save this and I reload here, you see indeed I switch to the logged in mode immediately. We see a brief flickering here because the first render cycle is in unauthenticated mode, but as I mentioned, you could avoid this by instead loading some splash screen for the very first render cycle until useEffect is done. you would just have to manage your is checking off status here inside useEffect and set it to false to indicate that you're done checking once you are done. Here, I don't really need that because it loads so fast. I don't think we have a real problem here with the user experience. So this is now using this token. But with this implementation, there are two things we're not doing. For one, when we're logging out, we're not clearing the token. That is something we can easily do. Here in logout, we just have to add local storage, remove key, and remove the user data. So that wasn't too hard. This ensures that when we do log out, we indeed stay logged out if we reload, so that we don't store the token in local storage. The more important thing we're not doing here, or the more severe thing we're not doing here, is that we're totally ignoring the fact that the token will expire. We shouldn't do that. For one, we want to log the user out automatically once the token expired. And second, when we try to auto-log in the user based on the token he might have, we of course also want to check not only if we do have a token, but if that token still is valid. So we need to include the token expiration into our logic here. So let's ensure we respect token expiration. Now, for that, in login, I know that the token will expire in 1 hour because we're building the backend, and on the backend, I configured it to expire after 1 hour. So when we log a user in, we also want to set kind of a timer after which we log the user out. And we want to derive the expected expiration date and store that in local storage as well, so that when we in the future try to auto-log in the user, we can refer to that stored expiration date and find out if the token still is valid. So let's start by creating an expiration date. My token expiration date is basically a new date which I generate, a new date object. Date, of course, is a built-in API in the browser and JavaScript. And there, I want to get my current date, which I get by calling new date again, on which I call getTime, which gives me basically the number of milliseconds that have passed since the beginning of time, if you want to call it like this, for the current date. And to that number, I add 1000 milliseconds, so 1 second, times 60 to have a minute, times 60 to have an hour. So this now generates a new date object that's based on the current date plus 1 hour. So it overall generates a date object which is now plus 1 hour. This is my token expiration date. Now this token expiration date needs to be stored as part of the user data. So here I will add an expiration key and set this equal to token expiration date. And then important here, to ISO string to ensure that no data gets lost when this date is stringified. This is a special kind of string which basically stores all the important date information and which importantly can be converted back to a date later. Now we have one problem with this logic here though. Here with this logic I always generate a new timestamp which is 1 hour in the future. Keep in mind that login also gets called from inside this useEffect logic here, which runs to automatically log our user in if we got stored data in local storage. So in the end what we need to do here is we need to verify whether the token still is valid, so if the expiration time we stored in local storage is in the future. But then when we see that it is valid and we call login, we need to pass that already stored expiration time to login as well. So that in login, we might be getting an expiration date already, which we then want to use as our token expiration date, but which we also might not get if we log in a user through the login form, in which case we want to generate a new date. So either we have an existing expiration date because we automatically log the user in due to the stored token in local storage, or we don't have that, in which case I want to generate a new one here in login. So the expiration date needs to be extracted here in useEffect as well. Now we're extracting all stored data, and part of that stored data is the expiration key, which is the originally stored expiration date. So here I can also check if we have a token, if stored data expiration is in the future. And now to check this, I will actually wrap this into new date. This will take this stored ISO string and convert it into a date object. And I want to check if new date for this saved expiration date is greater than new date like this, which is the current timestamp. Because if this date is greater than this date, it means that the expiration date is still in the future. Then the token is still valid. And if that's the case, we call login, and here as a third argument, I now forward that extracted expiration timestamp. So the originally saved expiration timestamp without any changes applied to it. This is forwarded to login, and therefore in this case we would get an expiration date and we would keep that instead of creating a new one. And when I then store this in local storage, I overwrite the existing data, but I keep the old existing expiration date. So overwriting this here is no problem. And with that, we're storing the token, we're working with the date, and we shouldn't be able to log the user in if we have an invalid date. What we're not doing is we're not setting a timer to automatically log the user out if the token then expires whilst he's active on the page. So this is the missing thing we should do next. I want to set a timer which basically ensures that we log the user out automatically if the token expired. To do this, I will add a new variable up there, logout timer. It's actually outside of my app because it's just some behind the scenes data I need to manage, not data which should re-render this component or anything like that. So it's not a state of this component, but just a general variable in this file. And now I want to use, or I want to set this timer here whenever our token changes. So we'll add a new use effect call here. We can have more than one effect. And the dependency here is my token. If the token changes, then I want to work with my timer. Now it either changed because we logged in, no matter if we logged in through the form or through auto login, or it changed because we logged out. So here I want to check if token is valid, which is the case after a login. And in this case, I want to call set timeout here, like this, and point at the logout function if this timeout triggers. So logout, the logout function also is a dependency here. Thanks to use callback, it's never recreated, and we have no infinite loop. Now the duration here, of course, depends. Sometimes it's an hour, but after auto login, it also very likely is less than an hour. So we should make sure that we reflect this expiration time here as well. Now the expiration time changes whenever we call login in the end. Then we got a new expiration date. Hence, we can store this as state here. Token expiration date and set token expiration date. And here I call use state and set this to nothing at the beginning. In login, I then create a constant named token expiration date. Thanks to scoping, this will be a different constant than up there. But if this is confusing to you, you can choose a different name here and here then, of course. But this will not override our state or anything like that. It's just a shadowed variable in the end. I do want to call set token expiration date here though, to also set my state and set it to the derived token expiration date we got here. So I set this here, and React will batch these state updates together, so it will not update the same component 3 times. Instead, it will just batch this all into one update. And thereafter, in the next re-render cycle of this component, we'll have the correct token expiration date. So this will then be the token expiration date. So here in useEffect down there, we should also add this as a dependency now, because I will use it in this useEffect function. If I got a token, and I got a token expiration date, then I want to set my timer. Now, of course, the timeout here does not take token expiration date as a second argument though, because this is a date here and not a duration, not a number, which I need to enter here though. So we need to calculate the remaining time. So remaining time for the token to be valid is basically the token expiration time, which is a date object, minus new date, so minus the current date. Now like this won't work, but we can call getTime here to again get this in milliseconds since the beginning of time, which is somewhere around 1970 in JavaScript. And here we call getTime. So now we got the difference in milliseconds. And that's exactly what we need here, because setTimeout wants a duration in milliseconds. So I can pass remaining time as an argument here. And with that, we set the timer to take as long as it takes for this token to expire. Now, if we have no token or no token expiration time, then I want to clear my timeout. So I want to clear any ongoing timers, because maybe we got no token anymore because we manually clicked on logout. In this case, we set the token to null, use effect would trigger, and it would want to clear my timer because there is no need to trigger logout again later if we logged out manually. We just might end up with multiple timers or something like this if we then log in again, which is definitely not what we want. Thankfully, setTimeout returns us an ID of the timer it created, and we can store this in logout timer. So in this variable I have up there, it's just some behind the scenes data I store, so we don't need to manage this in state. And then I can use the same logout timer here to clear this timer whenever the token changes again. So when we log out, we clear the timer. When we log in, we set a new timer. So with that, we hopefully have a flow that now works. Now let's see this. If I authenticate and I log in, I am logged in, of course. Now, if I reload here, I stay logged in. Now, if I go to the application area of my DevTools here, I can edit this data a bit and go to the end and now change that time here to actually 1 hour earlier, and then let's say 50 here. If I now hit enter and I reload, I'm still logged in, but if I wait for a few seconds, this time will be reached, and I should not be logged in automatically anymore, because my time is no longer in the future then. So let's wait a couple of seconds here. And indeed, now if I reload, I'm unauthenticated again. So this worked because I manually hacked this, of course, but just to prove that this auto login logic works. Now let's see if we are logged out if the timer expires. And for that, temporarily, I will reduce this login period to not 1 hour, but just to 2 seconds, so that we see if we are logged out after these 2 seconds. So if I do log in here, I'm logged in, of course, but after 2 seconds, you see the switches. However, now if I try to log in again, I immediately am unauthenticated. So something is not working correctly here. And that most likely has something to do with logout, because remember, we're having token expiration date as a state now, but in logout I'm not clearing this. I'm clearing the token, but not expiration date. I should reset this to null here as well. Otherwise, we still have our old expiration date managed in state here, which of course will lead to an immediate logout, which I don't want. So when we log out, I also want to clear my existing token expiration date. With that, if we try this again and I do log in here, I am logged in, and after 2 seconds I should be logged out. But if I log in again, this should be possible. Yeah, and if I reload real quick, you see, then I had my auto login going on, but of course a new timer was set, which is super short, and I am logged out. So this all seems to work, and with that we can of course increase this again, and not wait for 2 seconds, but 1000 times 60 times 60 instead. And we therefore got properly implemented authentication with the functionality to automatically log a user in and the functionality to automatically log a user out, both after a regular form-based login or this auto login I just talked about. So this is our finished authentication flow. Now let's just do some refactoring to clean it up. We got the general authentication logic implemented. Now there's one tiny optional change I want to make. We got a lot of auth-related logic here in app.js, and you can keep it there. But I personally think a custom hook, which would manage all this user auth-related data and logic, would be quite neat. We could take all that state here, the login and the logout function, and these two use effect calls, and we could cut it all from here if we have a properly implemented hook. So we'll add my own hook here, the auth hook. And in there, export a function, use auth, or however you want to name it. And then there, paste in everything I just cut from app.js. Now in here, I of course need to import some things from React. I need to import use state. I need to import use callback and use effect. And I also here, of course, want to have my logout timer. So I'll cut this variable here as well and add it as a variable outside of my hook here. Now this hook should return something. It should return access to my login and logout functions as well as information about the state. So I will return token here. I will return login and I will return logout. In this object, I return overall from my hook. And now in app.js, we can import use auth from shared hooks auth hook, and then just call it like this here, use auth, and we get back an object which we can destructure, which has the token, which has the login and the logout function. Here at the bottom, I also want the user ID. So in the auth hook, we should return this as well. It is a state of this hook. So of course, we can simply return user ID, this state here. I simply return this here as well. And therefore in app.js, we can extract it. We can extract user ID from the object use auth returns. And with that, our app.js file should work as before. Everything should work as before. We can now just clean up some unused imports here. But we shouldn't have any changes in the app functionality. So if I log in here, this should still work. If I reload, this works. If I manually log out, I stay logged out. If I log in again thereafter, this should also work again. Yeah, looking good. If I try to edit my place here, well, I have no places. So if I add a place here, Marienplatz, you know the place, Marienplatz 1, and pick my image and click add place. This also works. I can retrieve it here. I can add it. So clearly my token is managed correctly. Otherwise the backend would complain. I can reload. And this therefore is all looking pretty neat. So with that, we added authentication. And I think with the auth hook, we also were able to outsource all the core auth logic into a separate file and therefore keep our app.js file really lean. And this is it for authentication and authorization. As you can tell, it has multiple layers. For one, of course, it affects both the frontend and the backend. On the frontend, we want to control what we see so that we, for example, can't edit places that don't belong to us. We want to be able to edit our own ones, of course, though. We also want to manage login and authentication there to stay logged in, but to also automatically log the user out once the token expired. And that token is the heart of authentication. On the front end, we just change what we show to the user. On the back end, on the other hand, we create this token here, a JSON web token to be precise. We can store data in it, and we then, and that's very important, we then make sure that we also validate and verify this token so that we can protect certain routes with a middleware here against unauthenticated access. We check whether we do have a token and if it's a valid token, and then we can extract data from the token and attach this to our requests. Besides this authentication logic here though, where we check whether we do have a token, we also can do authorization to ensure that, for example, only a user who created a place is able to edit it. This also is an important part of authentication and authorization, and in this module you'll learn about this part as well. With that, I just got some tiny tweaks on the backend which we can apply, but which we don't have to. The core of logic should be clear now, and how the backend and the frontend are connected there, and what the responsibility of each side is. Now, to conclude this module, there are some tweaks which we can apply on the backend. In the places controller, for example, when we create a new place here, we're extracting the ID of the user to whom the place belongs from the request body. Now, actually keep in mind that we protect this create place route here. In places routes, we can only get to this route if we are authenticated. And in the check off middleware, I am extracting the user ID and I'm storing it on this user data object on the request. So actually it's better to not get the ID from the front-end user where invalid ID could be provided, but instead to rely on the ID we extracted from the token, which has to be attached anyways and which can't be faked. So here when I create a new place, creator will be request userdata.userid to use this automatically extracted ID, which we get here in the check off middleware. This is a better approach of getting the ID instead of getting it as part of the request body. Now, just to avoid confusion, in the places routes here, where we need a user ID to get all the places for a user, that ID should still be part of the URL because you're able to get places of any user, to see places of any user, not just your own places. If we would get the user ID from the attached token, we would only see our own places because that then is the only user ID we know. So here, this should be part of the URL still. Now, another tweak I want to make is that I want to ensure that whenever we return user-related data, we actually omit the password. But I think we already are doing that. So here in the places controller, we're returning a message here. Here I return the place converted to an object, but there I got no user data mixed in. It's just the place data. In create place, in the end, I return the created place, but again there we got just the user ID as part of the place, not the full user object. For find or get places by user ID, we do populate places on the user, but what I return then is just my array of places, which again just has a user ID then, and not the user data besides that. And for get place by ID, we also just return the place. Now in the user controller, when we sign up, I return user ID, email, and token. When we log in, sorry. When we sign up, I return the same though. And when we get all users, I return all my user data, but I already exclude the password here with projection. So we're already doing the right thing here and we're never sending any confidential data over the wire here. And with that, I'm happy with the setup. Now we just need to reflect this change we made in the places controller, where we now get the user ID differently in the front end. Because now in the front end, we can adjust our code and make sure that when we add a new place here in new place.js, we no longer add the creator field to the request because we're not interested on it on the backend anyways. And with that, let's give it a try. MERN plus 2. There only is one, but still. Let's use the right address and the good old image we used before. If I now click add place, this fails. So let's see why it failed. If we go to the backend, I print null here. Yeah, of course, it fails because I'm still using creator here to find a user by ID. Here, of course, I now also have to use the ID which is part of the request. Creator is not received anymore. So with that, however, we should be fine. Let's quickly search for creator here. This is all in different contexts, so this should be working now. If we save this and we simply resend this on the front end, now it works. Now we got two places here on manual. Can also delete the place, of course. And we got a working application with a little bit of a cleaner backend. We built a complete MERN application with all 4 technologies involved, obviously. Now it's time to not just test it locally, but instead to also deploy it. So to move the application onto a real server where other users can reach it as well. Because at the moment, of course, it only runs locally on localhost, which means only we can see and use this application. Therefore, in this module, we will have a look at the steps we should go through to prepare our application for deployment and some things you should keep in mind and you should have a look at when you want to deploy your application. And then I will show you two different ways of deploying MERN apps you could use. So two different ways of getting your MERN app onto real servers. So let's dive in. Let's start with the preparation steps we should go through before we actually move our code to some server. Now, the first step is the obvious one. We develop our app and we test our code. And we did this throughout this course. We continuously added features and we always tested this. And of course, you want to really test different scenarios, also test with different users, on different devices maybe, and also what was not the focus in this course, you of course also want to ensure that your scripts and your CSS code works across a broad variety of browsers. But the exact steps there really depend on the kind of application you're building. So let's assume everything works fine there and we're happy with the result we got. Well, then we want to move on to the next step before we actually move our code to the servers. We want to swap our URLs, which point at localhost or anything like that, for real URLs, which point at a backend, so to the server where our app really is hosted on. And we also want to make sure that any credentials or API keys we're using in our code, both on the backend or the front end, are prepared for deployment so that they are production ready, that we maybe locked down access to certain IPs or whatever we want to do there. And we want to look into environment variables there. We will do so here in this course so that we can easily swap certain values for testing locally and for deployment. So you will see how we could do that in this module. And once all of that is done, we want to build our application, most importantly our front-end application, which means we want to build the code, optimize it, and bundle it to have as small of a code as possible, and then deploy it to a server. And once our application is deployed, of course the work doesn't stop. Thereafter, we want to test this deployed application as well and check that everything is working. And of course, even once your app is up and running, you want to monitor it and maybe adjust it, bug fix, and so on. So let's now go through these steps and ensure that by the end of this module, we have our application running on real servers. So back in the app we worked on, again, I have my backend opened in one window and frontend opened in another window. Now, in this project here, we want to have a look at the different API keys and URLs we're using to ensure that we can use the same keys and same URLs once we push our app onto a server. Now let's start here on the backend. There, I got a couple of values which I might want to swap between development and production. Most importantly, if we go to the app.js file, there we connect to MongoDB with a certain user, a certain password, and a certain database. Now, it's not unlikely that we might want to use a different MongoDB Atlas account here, a different database, so different values for our app that runs in production than we do for our app that we test locally. The database should definitely be a different one so that we don't interfere with the data of our real users if we then continue working on the app locally in development. So if we then add new features, add new dummy data, and we mess with the database our real users are writing to as well. We don't want to do that. So it would be nice if these values, username, password, and also the database name, would be kind of variable. And depending on whether we run this locally or on a real server, we insert different values there. Now, thankfully, that is something we can do without too much effort. Locally here, I am using NodeMon, right? We're starting app.js with NodeMon. Now we can add a nodemon.json file to provide some configuration to NodeMon. Now you can check out NodeMon's docs to learn all about the configuration values you can provide there. This should be a JSON format, and here I'm interested in the nth key, which we can set up there. Nth for environment. And there we can set up so-called environment variables. These are variables, variable data, which depends, or where the values depend on the environment you're running in. And you can refer to them in your code, and therefore, based on the environment your code is being executed in, you will be using different values in your code. Env in the NodeMon config takes an object, and now there you can have any names, any keys of your choice. For example, db user. You don't have to write it like this can be any name of your choice. And then you enter the value here. So here I will actually stick to this value, and I will use Academind here as a user, and hence enter this here between double quotes on the right side as a value. I will also store my password here with db password, and then here go back to app.js and grab that password and copy that into nodemon.json. And then also the db names, so the database name. Here I will use MERN because that is the value I'm using here too. Now these are my development values. You might wonder, where do we enter the values we want to use in production, so when our app really runs on a server? Well, that depends on the hosting provider you're using in the end. If you're using some service that does all the general setup for your application, as we will do later, then this service will give you an easy-to-use way to provide such environment variables. And I will come back to that once we really move our application onto such a real server. So you will later see how to configure values for the production mode as well. These are our development mode values, and now we just have to refer to them in our script, of course. Now here, I'm already setting this connection string as with backticks so that I can dynamically inject values. If you're not doing that, make sure you do so. And with that here, we can inject the value instead of the hard-coded username. We have to refer to process.env and then the name of your environment variable. So in my case here, db user. This process.env thing is something Node.js provides to you. There is a global process variable, which is always available. It has an nth key, and this gives you access to the environment variables that are injected into the running Node.js process. And NodeMon injects these values, and as I mentioned later, when we run this on a server, different values will be injected. So with that, we can refer to a value for the user, here then also for db password, and then here at the end, instead of this hard-coded database name, it's db_name, which I chose here in NodeMon.json. So with that, we're injecting dynamic values here. Now on the backend, I got two other things I could inject, and that for one is in the util folder, my Google API key here. We might always want to use that. In that case, we could also hard-code it here. But if we want to use a different key for local development and for running this in production, which is not unlikely, then we might want to inject this here or get this from our environment variables as well. So here we could then refer to process.env Google API key, or however you want to name it. And now you just have to provide such an API key here in nodemon.json. Now the concrete value is something I will come back to because I want to tweak that API key, or at least have a look at it in the Google Developer Console before we actually use it again. So I'll just enter a placeholder here. We'll take care about the actual value soon. And one other last place I want to replace with an environment variable on the backend here is my private key for the JSON web token. In the user's controller, when we create a web token, I use this private key here, right? Now we can definitely hard-code it into this file like this, but of course keep in mind that we are reusing it multiple times. We're using the same key here in Signup, and then also here in our check-off middleware. Hence, alone from the code reusage perspective, it would make sense to outsource this or to store this in an environment variable. So here I will add the JWT key and store my key in there without the single quotes. And of course, this can be any string you want. And again, you could be using a different string for local development than you do for production. This might be a good idea because if you push your local development code to GitHub or to some public repository, you might want to ensure that you're not using keys here, which you also use in production. Though if you are pushing your data to a public repository, you might in general not want to include this entire Node.js file in the repository because it contains a lot of confidential data. But if you would push it, it's still better to have different values for development than you do have for production, so that at least your production environment is safe. Well, and now with that, we can again inject this JWT key. So in checkoff here, where I need that key, I can use process.env.jwt key, and of course do the same in the user's controller whenever we use that private key. So here in Signup, and also if we scroll up a bit, that was login, also if we scroll up a bit here in Signup now. Now with this, if I start that, I get an error, db name, here in my connection string, of course, it always has to be process.env.environment variable name. So with that fixed, if I now start this, it should start again. It should connect to the database. That should all be working. And with that up and running, let's next have a look at the front end before I then also come back here to this Google API key thing. On the front end, we also can work with environment variables. There, of course, we're not using NodeMon, but you can simply add a new file, .env, and this file will automatically be used by the configured build and development process we're using here. This is a create React app project in the end, and the React scripts package, which is used under the hood, picks up such a .env file automatically. And we can use the .env file to also store data we need here on the front end. So which environment variables could we use here on the front end? We could use one environment variable for this Google API key we're using in the index.html file in the public folder. And I think we got one other environment variable that would make sense, and that is the URL we're sending our backend requests to. Here it's localhost 5000, and not only are we duplicating this code everywhere where we are sending a request, this of course will not be the correct URL once our application is deployed, because once the Node application is on a real server, it will have a real IP or a real domain attached to it, and therefore this will then simply no longer be correct. So there are two environment variables I want to add. And now here's one important thing. Your environment variables here have to start with React app, all caps. React app underscore, actually, all caps. For Node.js, for the backend, this was not required. You could use any names here. For the frontend, this is required. Also keep in mind that, of course, the frontend code, as you will see later in this module, will be built locally on our machine, and then we just upload the build files, so the prepared HTML, JavaScript, and CSS files to a server. This also means that you must not have any confidential data in your code. So also here in your environment variables, whatever you store here, when you use it in your React code later, everyone can read and see it in the deployed application because it's not running on a server, it's running in the user's browser. So therefore, never store any confidential data in your React app, no matter if you're using environment variables or not. So with that, however, here we could store our React app Google API key. And now you simply set a value here in this file by adding an equal sign and then right thereafter, without any white spaces, the value you want to store. So it looks a bit different than in the NodeMon JSON file. Here we had a JSON format. Here it's just a simple key value pair file. And in a new line, I will add another environment variable, and this will be my backend URL. And now here, during development, that will be localhost 5000/API, let's say. Later, we can swap this for a different value in production. So with this, we prepared the two environment variables. How do we inject them? We get two different syntaxes. I want to inject my Google API key in the public index.html file. There, if you want to inject an environment variable like this key here, you do so by adding percentage signs at the beginning and end, and in between you reference your environment variable name. So React app Google API key in my case here, or whatever value you defined here in this .env file. This should go in here, and it has to be between two percentage signs. So that's how we add an environment variable in the index.html file. In our JavaScript code, we use them in a different way. We use them just as we would use them in Node.js. For example, in newPlace.js, here I want to replace this part now with my environment variable with this React app backend URL environment variable. And to do so, we use process.env again. So the same syntax you know from Node.js. And then simply, well, add your part of the URL, which is dynamic. So this is how we can refer to the backend URL here. And with that, I will quickly search for localhost 5000 in my project here to replace all occurrences. For example, in place item, here I will get rid of this part. Always also delete /API, because in my case at least, I included that in the environment variable. So that's my correct URL now. Here for the image, it's the same. There, however, and that's a little mistake on my side, I don't need /API. So I will add a new URL here, React app asset URL, because we could theoretically also upload our images to a totally different page. So I think it makes sense to store this in a new environment variable. And now I will use React app asset URL here. So $, React app asset URL, and of course access this on process.env. And with that, we make sure that we are able to access the URL where our images are stored. Remove the trailing slash here in the environment variable file though, because I do have this slash here. Now let's move on. Here in update place, I do send a request, so let's remove that part, including API. And instead inject it here, process.env React app backend URL was the URL I was using. Same here. Let's replace this part here with the dynamic, or with the environment variable part to be precise, like this. In user places, it's the same. Let's replace that here with our API. For avatar image, it's again our backend asset URL. So here I will use my other environment variable, process.env React app, and then the name was asset URL. So here asset URL like this. In auth.js, let's get rid of this here. And instead, again, use process.env React backend URL and combine this with the string. In auth.js here, it's the same. Get rid of this part, combine it like that. And in users.js, the same. Get rid of this, combine it like that. So with that, I ensure that everywhere in this application, we are able to conveniently control the backend URL through the .env file here and the Google API key as well. Now, of course, we still have a couple of unanswered questions at this point. How can we provide different values for production here in React's and Node's case? And what do we do with that Google API key? Well, let's start with the Google API key before I then come back to that whole production values thing. Before we build and deploy our application, I want to spend some words on the Google API key we're using, and also about MongoDB Atlas thereafter. So here I logged in with that Google account, which I used to create that Google API keys we're using on both the backend and the frontend. And I also made sure that I selected my project here, which we created earlier in the course. Now here under credentials, you will see your API key. And you see that API key I used in the frontend index.html file and in this util folder, the location.js file on the backend before. Now this key can be configured. If you click on it, you can configure where it can be used, so which apps can use it. Now here it is open to everyone, and maybe that is fine for you, but you should be aware of the fact that you can configure it. You can, for example, control which applications running on which HTTP referrers or IP addresses can use this key. And if your key is getting used on any other location, so on any other server, it won't be able to communicate with this Google service. And that might be something you want to do to lock down your key to the IP address your app is getting hosted on in the end. Now, since we're using the key both on the front end as well as the back end, if you're hosting your two applications, front end and back end, on two different servers, which is something you could do, you want to add all IP addresses of both the front end and the back end server. Otherwise, if everything is getting served from one single server, adding that IP address is the right thing. Or you add the HTTP referrers here. So there you enter the URLs on which your front end and back end will be hosted on. So that is something you could consider. I will pick none here, but it is something you definitely want to be aware of. You can also restrict your key down there. You can restrict your key regarding the APIs it can be used for. And in our example, we're really only using the geocoding API and then the maps JavaScript API. So you might not need the other APIs, and locking it down ensures that if someone else is somehow able to do something with your key you don't want, that at least it can't use it for any API. So that is something you could consider as well. So in general, just consider locking down your key to IP addresses, to domains, and or to specific services that can be used. Now maybe you also want to have two different keys, one which is really locked down and one which is relatively open because only you know it because you only use it in development and you never share it with someone else. Keep in mind that if your key is part of your frontend app, everyone can see it, so that already counts as sharing. But if you only use it locally for development, you could create a new API key which is relatively open, which you use during development, and a different key for production, which is locked down. And to simulate this, I will create a new API key here, which is getting generated. And now I could restrict this, but I will keep it open. But now I have two different keys here. And now let's say this is my development key, the first one. Well, then I can grab this and go back to my code and use this here in the front end for my React App Google API key, and also on the back end for my Google API key. And I can insert this here. And later I will show you how to use different environment variables for production, and then we could use this second locked down key. Now, speaking of locking down, let's also have a look at MongoDB Atlas again. You learned how you can configure it, how you can control the database and network access, and I want to come back to that. Of course, you could create a brand new cluster for your production project, or at least you create a new database in the collections here, which you use for production, which is what I will do here, MERN prod. And in there, I will add a places collection and thereafter also a users collection, so that we have all these collections already prepared. So let me quickly do this here, users. But besides this setup, which absolutely makes sense, but besides this setup, you also might want to revisit your database and network access settings. You might want to consider creating a new user specifically for production because you want to give it different privileges or whatever you want. It's not something I will do here, but you could easily do that. And then, since we manage our user on the backend here through environment variables, once you know how you can provide different values for development and for production, you can easily swap your credentials here, not in this file, but for these variables, to use different users for development and for production. Now, for network access, you want to ensure that, of course, this MongoDB Atlas server is not just open to your local IP address, but that later, once we deployed our application to a real server, you add the IP address of that server here. Now, we'll come back to that once we did deploy our application. For now, we can ignore this. And with this, we're generally set. We added the environment variables. Now let's learn how we build our React application for production to optimize and minify the code to get as small code as possible, how we can provide different values for production, and how we can do the same for the backend. So, a lot of talking about environment variables and keys and so on. Let's now build our app for production. And what does this actually mean? Well, for the React app, for the front end, you have to keep in mind that this will run entirely in the browsers of your users. Here it is running locally on localhost 3000 during development, and everything we do here is of course controlled by a script, which in the end is downloaded. When we reload this page here and we go to the network tab, we see there are a bunch of HTTP requests, and for example, this bundle.js file and this zero-chunk.js file, this is in the end our React code, which is getting downloaded from the backend. So all the React code runs in the browser, and everyone there can see it. You can access it through the Sources tab, through the Network tab, if you inspect the responses of the requests, and so on. So this is not hidden code. So since this does run directly in the browsers of our visitors, we have two important things to keep in mind. For one, we of course, as I mentioned multiple times, need to ensure that we have no confidential data in there. Our API key here is fine, but we might consider locking it down, as I showed it to you in the last lecture. The second important thing to keep in mind, of course, is that we want to make this code as small as possible, because having smaller code simply means that our users have to download less, and hence the application starts up quicker, so we simply provide a better user experience. Now for that, we have a convenient script. npm run build, if you execute this, will build your application. And whilst during development your code is not optimized, it has a lot of debugging, supporting code in it, when you run npm run build, everything which is not necessary will be stripped out, function and variable names will be shortened, and you will get as small of a code bundle as possible. So let's run npm run build here in the front end, and let's wait for this process to finish. Now once this did finish, with this message here, you also get some metrics about the sizes of the different bundles it produced, and you will find a build folder, a brand new build folder, which contains all the files you would in the end deploy to a backend. These are in the end the files that you want to push to a server. Now, we're not entirely there yet though. For one, we didn't swap our variables here for the values we want to use in production. So that's not great. We of course want to do that, right? Otherwise we have a problem here. The second problem we have is we didn't really prepare our app entirely for production. In the public folder in the index.html file, you can revisit some settings there. For example, set a different description of your web page as it will appear on Google search, for example. Check all these settings in general. Make sure if you want to use that fav icon or if you want to provide your own one. You can also delete this manifest.json import file here and also the manifest.json file if you want to. If you're building a progressive web app, you might need that. Otherwise, it's up to you if you want to add this or not. So once this is done, the rest of this file should be fine. Let's focus on the environment variables. To provide different values for this production build, so for building the files which we want to move to a server, we copy this file and name it .env.production. Our React build workflow here will automatically pick up this file when we build for production with npm run build, and we'll use the values set up in there instead of these values. So now we can provide different values here. And for example, in the case of the Google API key, we could use the second key here, which is our production ready API key, let's say, and swap our development one for this one. So now we're using that. Now for the URLs, we don't know yet where exactly our backend will be served, right? Because we haven't deployed the backend to any server yet. So we'll leave them like this for the moment, but I will revisit this later once we deployed the backend. Now one last thing you might want to consider for optimizing your front end for production is code splitting. So let me come back to that in the next lecture. You might notice that when we built our application, we got 4 files here in my case, and the biggest file is, in my case, this chunk here with 52.24 kilobytes. Now that is not a problem, this is not too large, but in bigger applications, of course, this might be bigger. And one problem, if you want to call it like this, which we have in this application, in this React application, is that we're not splitting our code. Now, what does code splitting mean? It means that not all code is required right from the start. If a user visits our page, he or she might be logged in automatically, or he or she might not be. No matter if that's the case or not, we might not yet have visited the places for one of our users. We might not yet have visited the auth page. So the code that is related to authentication and to user places, or the code which is related to creating a new place or for updating a place, might not be needed yet. It is needed once we visit that page, once we navigate to places new, but not before we do so. And therefore, we could load these routes lazily, which means initially when our app starts, we don't download the code for these routes, but as soon as a user goes there, we download the code on the fly and then render these pages, so that the initial page loading time is reduced because we download less code initially. And React thankfully has built-in support for code splitting. So how do we set this up in React? In the app.js file, I will create a new constant here, one for each route which I want to load lazily. For example, users. And then we can comment out or remove this import here. And users can now be created with React.lazy. And React lazy takes a function. And this is a function which executes import as a function. So import not as a statement like this, but as a function instead. This is also supported in modern JavaScript and also in this React build setup here. And there, we pass a path to the file we want to import. So that path here in the end. Now the difference is that now this is not imported immediately when app.js runs, and therefore in the bundle produced here by our build tool, it's not included right from the start, but it will be loaded on demand once this user component is required, this user's component, excuse me. And we still render this as a regular component. React lazy does the rest. So down there, we don't need to change how we use that. We just change how we import it. And now, of course, we replicate this also for a new place, where I grab this path and use it here. And let's comment this out. Also for user places, where I grab this path here and use it there. And also for update place here, grab this, replace it there. And then I want to do the very same with auth, like this. Now, not all lazy loaded routes I set up here make sense. For example, users is the route we load by default at the beginning, so we don't actually need to lazy load that. We can still do it though. But other routes like new place or update place make a lot of sense because we definitely don't load them initially when the app starts up, so there is no need in loading this in advance. Now, you don't need to use a similar syntax in the other React files because this really only works with the routing here at the moment. And in addition, this is our biggest opportunity for splitting our code into meaningful chunks for the different features of our application. So we only need to do this here in app.js. However, like this it wouldn't work. We now have to do something else. We have to wrap our routes, which we render in the end, with another component which we get from React. We import it from React, and that's the suspense component. Suspense is required to make React lazy work. So we wrap this here, our routes, with suspense. So your lazy loaded code is wrapped with suspense. And on suspense, you provide a fallback prop. And this has to point at some JSX code which is rendered as a fallback if loading lazy loaded code takes longer. So if downloading that code for that new route the user wants to go to, if that takes longer, React shows the JSX code you render here in between. There we could render a div with a class name of center, let's say, and then our loading spinner. For that, just make sure that you, of course, also import the loading spinner here. We need to import this from the shared components UI elements folder, And then we can render it here as a fallback if loading of a route should take longer. With that, let's test it locally. So I will use npm start again to build our app for development so that we can test it here on localhost. And let's wait for this application to reload. Now you see, it starts up, I'm logged in, but now something interesting happens. If I clear my network tab, if I go to add place, you see there are new downloads of these chunks. And that in the end are the code chunks that are required for this page. And if we go to authentication, for example, a new chunk was downloaded. So this is the code splitting in action. These are the different code chunks for the different feature areas we have. And therefore now if I quit this and we run npm run build again, we will also see that for production, different chunks are produced. Now the entire when to load what thing will be managed by React. You don't have to worry about that. Therefore, you get a free win here. You got more code files, as you can see. More chunks were created. And therefore, the initial chunk decreased a bit. Now, it's still almost the same size as before, because the majority of this size is actually taken up by the React library itself, and by other third-party libraries we included. But still, we're able to get some improvements out of this here. And on bigger apps, of course, the improvements would be way bigger, because you would be able to get way bigger chunks out of there. In an app like this, where the third-party libraries make up the majority of the code, of course, you don't gain that much. Still, it is important to know this technique. And with that, I would say our React app is looking quite decent. We're ready to deploy it. And to deploy it, we need to understand which two different options, or which two different main options we have for deploying it. When it comes to deploying MERN apps, I see two main options on how you could do that. The first option, probably the better one, or the more common one, is that you deploy two separated apps. And with that, I mean that you use two different servers. I will come back to that. The other option is that you deploy one combined app, so all on one server. Now let's have a look at option number one first, so two separated apps. There, your React app and your Node REST API would simply be deployed to different servers or different services which offer hosting. In the combined app case, we change our Node REST API a little bit to not just be a pure REST API anymore, but to also have a route which in the end returns the React app, so that we have both the backend routes, the API routes, and here's the React app route hosted through the same or served through the same Node REST API. Because the React app simply needs a static host, which is why we can deploy it on a separate server, a separate machine. We just need some server which serves our React assets, which is the index.html file, the scripts, and the CSS files statically. No server-side code needs to execute there. We don't need to execute any Node.js code or any other server-side code to serve our React assets. Therefore, we could use a pure static host like AWS Free, Firebase hosting, and many other providers for static hosting as well. You can simply Google for static hosting provider and you will find many examples. The Node REST API, of course, does execute code on the server, and therefore we need a hosting service, a hosting provider that is capable of executing Node.js on the server. And there, from AWS, we could use our own EC2 instance, which is our own virtual server, which we can configure to our needs in great detail, or Elastic Beanstalk, which is a service that takes a lot of configuration out of our hands and makes that easier. Or we use other providers like Heroku, and again, if you search for Node.js hosting provider, you'll find many, many examples. Now, in the right case, where we have one combined app, we just need a provider which is capable of executing Node.js code, because, well, we have an app that needs to execute Node.js code. And then in our Node.js code, we need to ensure that for certain requests, we just return our index.html file, our React scripts, and our CSS files. So we will need to tweak our Node.js code for that, and then just push it as one app onto some server. Now, I will show you examples for both. One important difference we also will have to adjust in our code is that when we deploy two separated apps, we essentially have the setup we had during development, right? We had localhost 3000 for the React app and localhost 5000 for the Node app. So there, no changes are required. And for example, we need to set these course headers you learned about. Now, if we have one combined app, we need to change something because that's not the setup we used during this course. And then, for example, we could get rid of the course headers because we would be serving everything from the same domain, and therefore the browser wouldn't need these headers to know that access is allowed to the API, because the API would sit on the exact same machine and domain as the frontend does. Now let's have a look at both options, and let's start with deploying two separated apps. Now, as I said, there are many hosting providers. I will start with hosting the Node.js application, and I will use Heroku to host it. A quite popular service, but definitely not the only one. So let's visit Heroku's webpage. And there we can sign up for free, and we can also host the application in the basic requirements we have here for free as well. If you have a real application, you of course might want to check out their pricing and probably choose a different option than the free one, because there you have a lot of limitations. For example, your server goes in sleep mode after 30 minutes of no requests basically, and it then restarts for the next incoming request, which of course makes this specific request a bit slower. And in general, it's great for testing and playing around. For a real application, you will probably need a paid account there. But here we can go with the free one. And once you did sign up, you should see a screen that looks something like this, where you can create a new app. Give it any name you want. Here I'll name it Acad MERN. Choose a region where this will be hosted. For me, US is fine. And click Create App. Now this sets up an app here. You can ignore these steps here. Now for the deployment method, I will use Heroku Git. And that means that you need Git installed on your machine. So in case you're not using Git, Git is a version control system which allows you to control your source code, create different snapshots, and so on. And you can use it for that, and I would recommend using it in bigger projects. But if you don't have it yet, you at least should install it to use it for deploying to Heroku. On the official Git page, you'll learn all about the installation. You can simply download it for your operating system, walk through the installer, and check out the docs if you're having issues with that. It should be pretty straightforward though. Once you got Git installed, you also need to install the Heroku CLI. So we can click on that link to learn how that works. And then just simply download the installer here or run this command. Or for Windows or Linux, use your options, and then simply install that CLI onto your machine as well. So that at the end, you're able to run both Heroku as a command as well as Git as a command in your command prompt or terminal. So then let's run Heroku login first. And I will do this here in my backend project. Simply run Heroku login, go through that login process thereafter. And once you are logged in, continue to the next step. Here, you need to initialize your project as a Git repository and then run this command to basically connect this Heroku app to your local Git repository so that you're later able to push code to your Heroku app and run it there. So let's do that. Let's run git init here in this backend project. Now important, also add a .gitignore file here and ignore node modules. This ensures that when you control something with Git, the node modules folder is not controlled, because uploading this to the backend would take super long, and Heroku will automatically install all dependencies your project needs. It will automatically have a look at package.json and install all these dependencies. So it will create the node modules folder automatically on the backend. So make sure you add this, and then simply run this command here, Heroku git remote, and so on. And once you did this, run these first two commands, and you can provide a different commit message here too if you want, by the way. So let's first of all run git add and then git commit prepared for deployment. Now before we push it to Heroku, make sure that in your package.json file you also tweak the start script here to just node app.js, because Heroku will execute this to then later, start your node application. And we need to also ensure one other thing. Remember these environment variables? They were used by NodeMon. Now we're not using NodeMon on Heroku, we're using Node there. We shouldn't use NodeMon there, it's not a production-ready tool. So these environment variables would not be used right now, they would all be missing. Therefore our app definitely wouldn't work. For example, connecting to the database would already fail because these environment variables at the moment on Heroku simply wouldn't be provided. So to fix this, we have to go to Heroku, can keep this page open, but then here, open this overview part in a new tab. This overview part of your project. There you can learn more about the project. And under settings, you can now set so-called config vars, and these are your environment variables. And here you want to create these environment variables you have in your NodeMon JSON file as well. So add dbuser here and enter the value you have here in NodeMon JSON as well, like this. Also add db password thereafter and provide the correct value here. And of course use the value you want to use for production. So if you created a different user for production here on MongoDB Atlas, enter the username and password of your production user here, of course, because these are the values that will be used in production. So db name is the next key I add here. And for db name, I indeed want to use that special database I prepared for production. I named it MERN Prod, so I will also name it MERN Prod here and click add. The Google API key also should be provided. And here I also want to use my production ready one, which I can quickly get from my frontend here, because there I already did enter it. So this is my production Google API key. Let's enter it here. And last but not least, we need to provide our JWT key value here. And this is my production secret key, or whatever you want to name it. Click add. So now we have all these environment variables set up, and with that we should be able to run our application. At least almost. One thing would still not work. On MongoDB Atlas, keep in mind that there, under network access, we're allowing our local IP address, but not the IP address of our Heroku deployment. And of course, that will be the server who wants to connect to the database in the future. Now, one important thing to keep in mind here is that Heroku uses dynamic IP ranges, and you can learn more about how you could get a static IP here with the help of a certain add-on, or if you have a private space, so a premium paid plan in the end, how you could set up a static IP here. For our local free sandbox environment, I will simply add an IP address here and allow access from anywhere. Now, of course, you could say that's a bit insecure, but keep in mind, this allows anyone to communicate to my database, but that person will still need a valid user and a password for that user. So you still need these credentials. So it's just one extra layer of security which I gave up here, but you could restrict that if you have a static IP. Here in the free sandbox, we just don't have that. So I will open that up to everyone, and once this is done, once everyone can talk to our database, we can finally try deploying this to Heroku. So let's wait for this to finish. So with this finished, let's go back to our instructions here on how to deploy, and let's try this git push Heroku master command here. However, before we push it, make sure you also git add again to reflect your changes to package.json, changed starting script. Otherwise, you will push your old code, your old snapshot, where we still used NodeMon for starting this up. And thereafter, let's try this git push Heroku master command. So this will now deploy this application, will install Node modules there, will automatically detect that you're using Node because you have a package.json file, will build everything, and in the end it will launch your application. Now let's wait for this process to finish here. And with it finished, it gives you a URL where your page in the end is hosted, or where your application is running. Of course, you can also connect a custom domain and so on, and you can learn all about that in the official Heroku docs if you want to do that. With that, let's visit our page here. And eventually you will see that you get an error. Now this error makes sense. If we have a look at our app.js file, we see that we're listening to port 5000. Now this was good during development, but now it isn't anymore. On Heroku, we want to use a different port. Thankfully, Heroku gives you a default environment variable, which provides the port on which your application is served. You can just enter process.env.port here, port all caps, and just use 5000 as a fallback value here. So if that is not provided, we will use this, i.e. during development. If that is provided, which Heroku will do for us, then this will be used instead. And then our application will be served on a port Heroku wants to serve it on, and therefore it will be reachable. So with this, let's add this change, added port env, and then let's repeat this git push Heroku master command. So this will now update our application on the server with this new version of it. We'll replace the old one with it, and we'll start it, of course, and hopefully then it will work. And indeed, if I now visit /API/users, I get back an empty array, which makes sense because we have no users yet in our production database. So our API seems to work, seems to be up and running. Now let's test this with our React app, and let's deploy the React app as well. So let's move over to React, and there, when we build for production, we of course now also want to use our real backend URL. Now we got this URL now, so let's grab it here and insert it instead of localhost 5000, like this. So this is now where our application should be served at in the end, and remove these trailing slashes here. So once we get this set up, we hopefully have a React app which is able to talk to our backend. So let's run npm run build again to create this production build. And then before we deploy this to a static host, I want to test it locally. For that, we need a simple local server which can serve our static assets. And for this, you can search for npm serve to find an npm package which you can install globally on your system to simply serve any static files with it. So here I will run npm install -g serve, and on Linux and Mac you might need to add a sudo in front of this to get the right permissions. And this will now install this serve package. Again, it's just a simple server which we can use locally to serve our build assets. So now cd into the build folder and simply run serve, and this will now serve your production ready React application. So it is a way for us to test this application. It's served on localhost 5000 here. So let's enter that and let's see whether this works. Now it finds no users initially, which makes a lot of sense because we haven't created any. So let's now in the end go to authenticate here and let's try signing up with one. So here we'll enter max and pick an image, of course. Here it is. Enter an email address and a password and click sign up. And this seems to work. Here is our user. Now if I click on the user, I could not find any places for the user, but if I try to create one, Marienplatz, a great place in Munich, I'm sure you know this place by now. We can configure all of that, click add place. Now when we go back here, I see we got kind of a strange style here, I would say. If I reload, it's gone, not sure. It's always there when we navigate to this page. Simply a styling issue though, it does work. And we see our place here. We can also view it on a map. Let's try editing it. Looks good. And let's try, before we delete it actually, let's go to MongoDB and have a look into our database to see whether it's stored in the right database, which should be MERN prod. So let's go to MERN prod. And in MERN prod, in places, we have one document with one place, and we have one user, and that user has a reference to our place. And if we now go back here and we delete this place, this works. And if we go back to MongoDB, therefore in the places collection, this should be empty now. And on users, our reference should be gone. And it is. So this works. our production-ready React app works, it talks to our backend. Now we should be ready to also deploy this React app to a static host. Now, just as for the Node code, there are many hosts you can choose to deploy a static application. I go with Firebase hosting because there we also can get started for free and all we need is a Google account, which we already should have by now. But again, if you search for static hosting, you find plenty of alternatives. Now, you can go to Firebase hosting docs to learn more about it. And as always, you also want to check out their pricing to understand what costs you money and what doesn't. The hosting we will use here will be free, but again, if you're running a bigger application there and so on, then this might not be the case. So how do we host an application with Firebase hosting? For that, we can click on Get Started here on the left, and we learn that first of all, we have to install the Firebase CLI. So just as we had to install a Heroku CLI, we need that, and you can click on your button to simply install it on your system to see the steps you need to run to install it on your system. So simply make sure you do that. You install the Firebase tools here, as it's called, on your system. And once you're done with that, you can run Firebase init. However, and that was part of the installation actually, you also need to sign in. So you need to run Firebase login and log in with your Google account there. So once you ran Firebase login, you can run Firebase init in the project you want to host. So in my case, in this frontend folder here. And there, make sure you're in the frontend folder, not in the build folder anymore. So navigate into the root frontend folder and run Firebase init. Now it will ask you which features of Firebase you want to use, and here we only need hosting. So navigate to that, hit space, and then confirm with enter. Then it asks you whether you want to create a new project or use an existing one. You can choose create a new project here and simply enter a project name into the field once asked for it. Here I will go with an existing one, but you can, as I said, create a new one. As a next step, you're asked what your public directory should be. The default is public, but in our case, the files we want to deploy, and that is in the end what it's looking for here, are in the build folder. So enter build instead. You're then asked whether you want to configure this as a single page app, and you should choose yes here, so that all requests on the server are redirected to that index.html file. As a next step, it asks you that it already found the index.html file, if it should overwrite that, and there you should choose N for no. And thereafter it initializes this, and you should be done. 2 new files are added with the general configuration. And one important note here in the Firebase JSON file is that rewrites entry. In the end, that says for any request sent to your backend server, so whatever URL you're entering there, it will always serve the index.html file because in there we have React and the React router, which parses the URL and then renders the right component. And that's important for single page applications. The location where you're serving them always needs to return the index.html file, that single page you're having, because you're not resolving URLs on the server side, but instead you always want to return your HTML file with your React app in it so that the React app and the React router can do something with the URLs. That's why this configuration is important here. With this configured, if we go back to the docs, we see that now as a next step we can run Firebase deploy. So let's run this command here, Firebase deploy, and this will now push our files in the build folder to a host, to a server provided by Firebase. And once it's done, it will also give you the URL where you find that. Of course, before you run that command, make sure that you ran npm run build with your latest changes applied. I did this already, but in case you didn't, run it first before you deploy. And thereafter, you find your hosting URL. So let's copy that and open it in a new tab. And this is now our application. And you can already tell that it works because it fetched the user I created before. We can also try logging in here. Yeah, that looks good. Still got that strange styling bug here, but besides that, everything is working just fine. And with that, we got our application up and running on 2 separate services. Heroku for Node.js and Firebase hosting for React. And I would say that this is the most common way of deploying such MERN apps. You want to split your REST API from the front end because that REST API you built, which is served through Heroku, really can be utilized by any client. You're not restricted to your React frontend. If you serve this on a standalone server, you can easily connect other clients to it as well. Now, of course, that technically would also be possible if React is served by the same server. But the more you serve from the same server, the more requests hit that server. So splitting the apps on two servers also makes sense from a performance perspective. Users who are just visiting your React app, who are not doing something that hits your database and your REST API, will therefore only hit the static host. And therefore you split the amount of requests and which servers the requests reach. So that would be another argument for using multiple hosts. Nonetheless, in the next steps, I also want to show you how you can deploy everything to one server. Now, before we deploy everything as one app, let's just fix this little styling issue. In the end, we're getting this here from this div where we have the card, which is getting rendered here for our user item here, which applies its own card style, and where we then have user item content, which should override this style. Now, the problem here is that the precedence CSS uses here is such that our card style overrides our user item style here, which should reset the padding to 0. And the reason for that simply is related to the order of styles in which they're imported here into our HTML file. Now, a quick workaround around that is that in user item here on padding, we add the good old important flag thereafter. This allows us to ensure that this definitely gets added. Alternatively, since we know that this will be applied on a card, we could also make our rule here a bit more specific and say this applies when you have a card style combined with that, which would override the raw card style. So the pure card CSS class being added. This is how you could adjust this to make sure that the styling looks the way it should. That, however, was just a minor thing. Still, I wanted to share my thoughts on that here. The main thing I'm interested here is, of course, how we can now make sure that we serve both React Frontend and Node.Express Backend from the same server. Because thus far, we were, of course, using two servers. To serve everything from one server, we need to work on our Node application. We need to deploy this onto a host which is capable of executing our Node.js code, for example, Heroku. But, and that's the new thing, we now don't just need to render our routes there, but in addition, now we also need routes that serve our React files. So the single page application we got there in the end. And that is new. It isn't too difficult though. What we need to do in the end is we need to grab our build application. So we still run npm run build here on the React side. We can do that right now to apply our latest style changes. So we still need to run npm run build here. But then we will grab our build folder and copy it over into the backend folder. Though, before we do that, let's double think about our production environment variables in React. The backend URL now will be a different one, or to be precise, it will be the one where our Node application will be served on later. Now, in my case, this is correct here. This is the URL under which I will still serve my Node application later. But if you now want to serve this on a new Heroku project or on a different Node hosting provider, then you need to ensure that you find out which URL you will have after you deployed your Node app and enter this here. So in my case, this should be fine though. So let's now grab the build folder and go back to the backend folder and there maybe add a public folder and copy everything that's in the build folder. So we'll actually grab the content of the build folder into this public folder here. The name is up to you, but public is the more common name you would choose for that. Now we want to ensure that everything in the public folder is statically served. And we did something similar already in app.js with our images. So in the end, we can copy this line here and add it after, and that's now really important, add it after our routes here. It also means that this middleware here, where we handle unknown requests, is no longer needed, because now I want to say any request going to any URL will be served statically. So here, I remove that filter at the beginning, and I want to serve my public folder here. Just like this. So what I'm saying here is any request which reaches my backend, which was not handled by these routes, and I need to do this first so that my API still works, but any request that was not handled by these routes will now be handled by this route. And this route will simply return the content in the public folder. So for example, the index.html file. Now, if we rethink this solution, however, it doesn't look that great anymore. Indeed, we would serve everything in that folder statically, and that generally is something we want to do because we want to ensure that, for example, any JavaScript file and any CSS file that is requested from our React app can be served. But, and that's now the problem, this alone is not enough. We can move this back up there actually to our other static serving solution here, so that we simply register this as another static path, where we basically say, if you're requesting something which does not start with uploads images, we'll see if we find a file here and we will serve it. What this unfortunately won't do is it will support our front-end routes. If we are on our running React app and we go to /auth there, so in the front end now, then the request which gets sent to Express is actually that we're looking for an auth folder and by default for an index.html file in there. And of course we have no auth folder here in the public folder. So this works for the initial index.html file and it works for all the JavaScript files and all the CSS files, so for all the assets we need here, but this does not work for our different routes. To make that work, I will now go to that place after my other routes and use a new one where I want to catch all unhandled requests, because here I now want to set up a middleware function with request response and also next, of course, where I will always return the index.html file. So in here the idea simply is that I call res send file, and that's a method provided by Express, where I send back a response that is basically made up of one file. And there I always, for any unknown route, want to send back the index.html file, so that the front-end routing, the React router, can take over and resolve the unknown URL. So here I want to send that file, and we can build a path for that with path resolve, where the first argument is dir name, so that constant which is available in Node and Express that gives us the current folder of this app.js file. And then we want to go into the public folder, of course, and in there serve the index.html file. That's my idea here. This file should be served. And with that, we should have a setup where we can request any route, and either it's a backend route and these routes kick in, or it's a static file like a JavaScript file, then these routes here or these handlers help us, or it is anything else, and in this case we always send back our single page. Now we can also test this here. We can start up our local server, and for that just make sure that in package.json you also add a script like this dev script which I added here that allows us to still run this with NodeMon. So add such a script, because starting this with Node would not work because that wouldn't take these environment variables into account, and for local development I want to use them, so let's use dev which uses NodeMon, and then run npm run dev to start this Node server locally, and let's see whether that works. And locally we are using port 5000. We can ignore the fact that this image is missing. We'll take care about this later. But what we can tell is that this works. And if I reload on the auth page, this also is getting served. And if I try setting a request here, so our API should be hit, this also works. We can see in the network tab that indeed we sent a request there. We got back our places here, for example. So we are interacting with the API. So this is working, but in addition to that, serving the React app through that very same Node Express app that hosts our backend API is also working. Now also remember what I said earlier on the slide. When you're serving both from the same host, you can also omit these course headers. So I will comment out this middleware. You can leave it here, it's not a problem, but you can also get rid of it. We don't need it anymore. If I comment it out and I reload here, you will see this still works. If I try to log in again, this still works without any errors besides the image which it doesn't find, to which I will come back later. So this works, and this is now the app prepared for hosting with combined apps where we have Node Express and React in the same project. So with that, we should also be able to deploy this Node.js application. So whenever we have a new version of the React app, we just build it, and then we copy the content of the build folder into the public folder and replace everything in it with it. And once we got that replaced, we deploy our React app here. So how does this work? Well, we use git add again, where we can say added new React app frontend version, whatever you want to name it. And then we use git push Heroku master again to push this updated Node application to Heroku. And this is basically the same application as before, but it now includes our React application and the logic to serve it. So let's wait for this process to finish now. And thereafter, let's visit this URL again. And if we enter it like this, we should see our application. Now you will notice that the image of the user is missing though, and it was there a second ago. Now I will come back to why that is missing in a second, but let's first of all try authentication and so on, if that works. This seems to work. Let's also try creating a new place. Like we did many times before. Let's click add place here. And this really all seems to work. So why are we not seeing the user's image here? Because in general, the deployment seems to be all right. And that's the important thing. I'll come back to that image thing here in the next lecture. But first of all, let me make it really clear that this is now our app, both the React app and the Node API, served on one machine, on one server, on one service provider, Heroku in my case here. So we got everything on one server, and this therefore is the other option of deploying this. You can use two hosting providers like Firebase or any other static host for React, and then a Node.js hosting provider for the backend, for the Node REST API, or you use one combined setup. It's up to you which one you prefer. Splitting it onto two servers can give you certain performance advantages because requests are split up and not all requests hit the same server. But depending on the size of your app, that also might not really matter, and then you might find it easier to just host everything on one host. Ultimately, it's up to you. I just wanted to show you both alternatives. And now let's find out why this image is missing. This image here is missing because I deployed a new version to Heroku. And the thing is, whenever you do that, it in the end restarts your server, you could say. And with that, I don't just mean the Node process, it restarts the entire machine where your Node app is running on, kind of. Of course, in the end, it uses a system where multiple apps sit on one and the same machine, but your virtual, the machine on that machine, so to say, will be restarted. The same, by the way, will also happen if you manually restart it here through your console, of course, or also, since we have the free plan, the same will also happen every 30 minutes. Then it goes to sleep, which means your virtual machine kind of gets shut down. And when a new request arrives, it's restarted. Now, the thing is, the files you upload are not persistently stored on Heroku's servers. Your code is stored and it's simply restarted whenever it is required to, but your other files, like the uploaded images, are not stored. Now, that's not the same for every hosting provider, of course. For example, on AWS, if you rent an entire virtual machine, which you can manage on your own, then files are not lost when you restart it. It really depends on the hosting provider and the exact service, and maybe also the pricing tier you are using. In Heroku's case, if you search for Heroku persistent storage, for example, you'll find a help article where this is explained. And there you also get the recommendation to, instead of storing files on the file system, store files on dedicated static file hosts like AWS S3. And you can also learn how you could adjust your Node.js code to move your files to that host. So that is something you can look into if you choose a certain hosting provider. But again, depending on which provider you are choosing, you might also be on one where this isn't an issue because files are deleted there, because maybe you rented an entire server or something like this. So it really depends on the exact hosting setup you're using. It just is something you also should be aware of. And with that, we're done. You learned how to deploy your application, both separated on two hosts, but also combined on one host, on one machine. And you learned not just how to get it there, but you also learned about environment variables, the difference between development and production mode, how to control your API keys and that you might want to lock them down. And in general, you hopefully now have a good understanding of how you build a MERN application, but then also how you can take that built application, prepare it for production, and then also upload it to a server. And with that, you're well prepared to dive deeper and build your own MERN applications.